Section 10 of Civilization and Climate by Ellsworth Huntington. This is a LibriVox recording. All LibriVox recordings in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Leon Harvey. Chapter 10. The Ideal Climate. We are frequently told that the Riviera or Southern California has an ideal climate. Florida lays claim to it in winter, the Alps in summer. Two of the few regions which rarely assert their preeminence in this respect are Boston with its east winds and London with its fogs. Yet in many ways they have a strong claim to high rank. It all depends upon what we mean by ideal. For rest and recreation, a warm equatorial climate is doubtless most delightful. For a fishing or camping trip, something quite different is desirable. For most people, the really essential thing in life is the ordinary work of every day. Hence the climate which is best for work may in the long run claim to be the most nearly ideal. But such climates are also the ones that are best for health. Hence they are the ones which people will ultimately choose in large numbers. The few disagreeable features at certain seasons are no worse than the shiver at the beginning of a cold plunge. On the basis of both work and health, the best climate would apparently be one in which the mean temperature rarely falls below the mental optimum of perhaps 38 degrees, or rises above the physical optimum of about 64 degrees. From this point of view, the most ideal conditions would seem to be found where the temperature for the year as a whole averages not far from 51 degrees, as at London, Paris, New York, and Peking. In four chief portions of the globe, the winter temperature averages not far from 38 degrees, and that of summer not far from 64 degrees. The first of these is England. At London, the thermometer averages 38 degrees in January and 63 degrees in July, while at Liverpool, the figures are 39 degrees and 60 degrees. If an average of 51 degrees at all seasons were ideal, southwestern Ireland, with a range of about 45 degrees to 59 degrees, and the Hebrides from 42 degrees to 55 degrees, would be more ideal than London. On the continent, where the seasonal variation is greater than in Britain, the length of the relatively unfavourable periods with temperatures above 65 degrees and below 38 degrees also increases. A second region where the temperature conditions approach the ideal is the Pacific coast of the northern United States and southern British Columbia. Seattle, averaging 39 degrees in January and 64 degrees in July, has practically the same temperature as London. Southward the seasonal range decreases. San Francisco averaging 49 degrees in January and 59 degrees in September, after the cool summer fogs have passed away, may claim in many ways to be ideal. Still farther south, the temperatures of Los Angeles and San Diego, 53 degrees and 54 degrees in January and 69 degrees in August, fluctuate about the physical optimum and would be ideal for physical activity if mean temperature were the only criterion. The mental optimum, however, is lower than the temperature. Of all except the unusually cold days, the variations from day to day are rare. A short distance inland, the Californian climate becomes less favourable than on the coast, for the average in summer at Fresno, for example, is 82 degrees, even though the heat is mitigated by low humidity, and continuance of such high temperature causes people to feel indisposed to activity. England and the Pacific coast owe their climatic excellence largely to the fact that ocean winds from the west blow freely over them. Two regions in the southern hemisphere enjoy the same advantage, namely New Zealand and part of South America, including southern Chile and portions of Patagonia. We have to think of these South American regions as sparsely settled places of little importance. This is true for the present, but it's not because the climate prevents activity. The climate, to be sure, is a drawback, but the harmful feature is not the temperature, but the rainfall. Plants, not man, are the chief sufferers. Unlike our other three regions, this part of the world has a deficient rainfall except in the west, and there high mountains hinder settlement. In spite of this, the few small portions of Patagonia that permit profitable agriculture are making progress and will doubtless do so rapidly if not hampered by remoteness, by the absence of railroads, and by the social handicap of their aborigines. It must be inferred that the climates of Patagonia, New Zealand, England, and the Pacific coast of the United States are necessarily ideal. Mean temperature is not the only important factor. Among other things, relative humidity must be considered. The deficiency of moisture in Patagonia not only is disastrous economically, but to judge from the preceding studies, it lessens man's energy. A similar effect is produced by excess of moisture, and thus harm is done in Ireland and western Scotland, which would otherwise be almost as fortunate as England. New Zealand, the Central Pacific coast of North America, and England itself are sometimes unduly damp for long periods, but nevertheless enjoy a relative humidity of not far from 70% much of the time. Other regions, however, such as the eastern United States and Central Europe, seem to be more favoured in this respect. The change of temperature from day to day, as we have seen, seems to be as important as relative humidity and must accordingly be considered more fully. Its effect on human activity seems to be second only to that of the mean temperature of the seasons. The intensity and number of daily changes depend upon two chief factors. First, the range of temperature from the warmest to the coldest part of the year, and second, the number of cyclonic storms, when the winters are cold and the summers hot. The changes from day to day are also extreme. For instance, in the Dakotas, where the mean temperatures of January and July differ by 60 degrees Fahrenheit, a change of equal magnitude may take place in 24 hours. On the other hand, in a place like the Congo, where the difference between the coldest and warmest months is only 3 or 4 degrees, the days are correspondingly uniform. The whole matter is illustrated by maps in many physical geographies and in such publications as Bartholomew's Meteorological Atlas. The parts of the world where the change of seasons favours a highly advantageous degree of change from one day to the next include most of North America, but omit Florida, the Pacific coast of the United States, and the regions from the Mexican border southward. All of Central and Eastern Europe is also included except parts of Italy and Greece. A large area in North Africa and a small area in the south of that continent also rank high, as do Central Australia and the part of South America which includes Central Argentina. Finally, all except the southern parts of Asia lie within the high area. Thus, this particular favourable condition occurs not only in many regions whose climate is also good from other standpoints, but in a much larger number whose general climatic conditions are decidedly unfavourable. This is not surprising, for the beneficial effect of pronounced changes of temperature from day to day is often nullified by great heat in summer or extreme cold in winter. Moreover, the seasonal range of temperature forms only one of the two factors which determine the amount of stimulation derived from changes of temperature from day to day. The other factor is a number of cyclonic storms. By this, as has already been explained, we mean the ordinary storms which produce our changes of weather from day to day in the United States and Europe. Probably the storms are more important than the range of temperature from season to season, for they bring rain, humidity, changes in the winds, and all sorts of stimulating variations. The world's stormiest region, so far as known, includes the Great Lakes region of the United States and southern Canada. Around this centre there is an area of great storminess extending southward approximately to Maryland and Kansas, and northwestward through the Dakotas to Alberta. Eastward it includes New England and the Maritime provinces, while northward it quickly disappears. To the south the storminess diminishes gradually, so that Florida has a moderate degree of variability in winter but not in summer. Southern California is the least stormy part of the United States. In Europe, the various stormy regions include Britain, most of France, Germany, parts of Scandinavia, and the northern part of Italy, together with Western Austria and the Baltic region. In Asia, Japan is the only place where cyclonic storms are at all numerous. The lands of the southern hemisphere generally have few storms. New Zealand is a chief exception, although they do not cause such great changes of temperature as in America and Europe. The extreme southern tip of South America is likewise stormy, but its storms do not cause much variability. On the contrary, they give rise to a monotony of winds and clouds, which is extremely deadening. According to the testimony of those who have lived in such places as Tierra del Fuego or the Falkland Islands, farther north in central Argentina, there is a moderate number of storms, comparable to those in the southern United States, and their effect is distinctly favourable. We are now prepared to estimate the relative stimulating power of the various climates of the world. In England, for example, the mean temperature of the seasons and the degree of storminess are both highly favourable, while the seasonal changes are only moderate. Germany is above medium in temperature and high in seasonal changes and storminess. In this respect, it resembles the northeastern United States and southern Canada. Japan is similar, except that it is somewhat too warm and damp. The coast of British Columbia and of the neighbouring states is highly favourable in mean temperature and medium in storminess and seasonal changes. Around San Francisco, the mean temperature is still better, but both seasonal changes and storms are mild. In compensation for this, however, there are frequent changes of temperature because fogs blow in from the ocean, and are quickly succeeded by the warm, bright weather which generally characterises the interior. Farther south, where the fogs cease, the conditions become less favourable from the point of view of the changes from one day to another, although the mean temperature of the seasons still remains advantageous. The chief defect of the climate of the California coast is that it is too uniformly stimulating. Perhaps the constant activity which it incites may be a factor in causing nervous disorders. When allowance is made for the fact that California's urban population is relatively smaller than that of states like Massachusetts and New York, insanity appears to be even more prevalent than in those states. Moreover, the cities of the California coast have the highest rate of suicide. In 1922, 4 California cities held the list in suicides, the number per 100,000 population being San Diego 47.8, Sacramento 37.9, San Francisco 30.4, and Los Angeles 30.3, against about 15 in the eastern cities. Possibly these facts may be connected with the constant stimulation of the favourable temperature and a lack of relaxation through variations from season to season and from day to day, although other factors must also play a part. The people of California may perhaps be likened to horses which are urged to the limit so that some of them become unduly tired and break down. In the same way, the people of the eastern and central United States are more nervous and active than those of Europe, but not necessarily more efficient, because of still different climatic handicaps. They are alternately stimulated and relaxed by frequent changes from day to day, and in this are like horses that are well driven. In the spring and autumn, however, the combined effect of ideal temperature and highly invigorating daily changes spurs them to an astonishing degree of effort. Then comes the hot summer or the cold winter, either of which is debilitating. People do not diminish their activity at once, especially in the winter. They draw on their nervous energy and thus exhaust themselves. They are like horses which pull on the bit and when urged a little break into a run, straining themselves by their extreme speed. Then they are pulled up so suddenly that they are thrown back on their haunches and injured. In Germany, somewhat the same conditions prevail, although not to so great an extent. England apparently comes nearer to the ideal than almost any other place. The climate is stimulating at all times, both by reason of abundant storms and because of a moderate seasonal range. It never, however, reaches such extremes as to induce the nervous tension which prevails so largely in the United States. In strong contrast to these highly favourable regions are such places as the centre of Asia, where the winters are depressingly cold and the summers unduly hot. The range from season to season is apparently helpful, but its good effects are largely nullified by the infrequency of storms. Day succeeds day with no apparent change. In the desert of Taklamakan in Chinese Turkestan in the fall of 1905, I found that one of the most surprising features was the way in which winter came upon us unawares. Each morning the thermometer stood a trifle lower than the preceding morning, but there was never any change such as that which we so often experience in America when the first severe frost suddenly comes after a series of days as warm as summer. Frost at last began to prevail at night, but not until we found the water frozen hard in the morning did we realize that winter was upon us. So it goes, month after month, with deadening monotony. And when a storm does come, the change is often much more extreme than in more oceanic regions. It is frequently so great that its value as a stimulus is much diminished. Tropical regions suffer even greater disadvantages than do places like the center of Asia. Not only is the temperature unfavorably high, but there are practically no cyclonic storms except in portions where a few hurricanes occur each year. Thunderstorms, to be sure, are abundant, but they rarely bring any important change of temperature. Moreover, the seasonal range from the warmest to the coldest month is generally less than the difference between day and night. Day after day displays no appreciable variation from its predecessor. The uniformity of the climate seems to be more deadly than its heat. Such uniformity, perhaps as much as the high temperature and high humidity, may be one of the most potent causes of the physical debility which affects so many white men within the tropics, and which manifests itself in weaknesses such as drunkenness, immorality, anger, and laziness. Even in tropical highlands the same deadening monotony prevails, although to a less degree than in the lowlands. Such monotony is perhaps the condition which will do most to prevent the white man from living there permanently for generation after generation. His general health may not seem to suffer, but if he works hard, he is in great danger of breaking down nervously. The temperature of the highlands may be highly stimulating. There are many places where the mean temperature during every month in the year is within a few degrees of either the physical or mental optimum, or of their average. At Quito in Ecuador, for example, the coldest month, November, averages 54.3 Fahrenheit, and the warmest months, February and September, 55 degrees. Nowhere within the tropics, however, are there any regions which enjoy the physical optimum at one season and the mental optimum at another. If we are justified in associating a high rate of insanity on both the Atlantic and Pacific coasts of the United States with the peculiar climatic conditions, we should expect that white men in tropical regions and high altitudes would suffer still more in the same way, or else would become inert, but no figures seem to be available to determine this point. We might proceed to discuss scores of ways in which a knowledge of the exact effects of climate may assist in the understanding of historic events, or help in guiding future development. As a step in this direction, let us construct a map of the world showing the degree of energy which we should expect among normal Europeans in various regions on the basis of climate. This map will be based entirely on our studies of work among factory operatives and students, and I shall leave the description of it unchanged for the first edition of this book, except for the correction of an error. Later we shall test this map of climatic energy by one of climatic health, based on our studies of morality and disease. Both maps are determined by 1. The mean temperature month by month, 2. The amount of change from one day to another, and 3. The relative humidity. The conditions which prevail at various seasons in the eastern United States duplicate those of almost every portion of the globe. There are hot, dry days like those of the Sahara, hot, damp days like those in the Amazon forests, cold days like those of the great ice sheet of Greenland, and days of almost every other description. At this point, we must make an assumption which cannot be tested until vastly more data have been collected. Let us assume that the continuance of a given condition produces the same effect as its temporary occurrence. For example, in Connecticut, our measurements of the effect of days having a mean temperature of 75 degrees are based on occasional days scattered through the summers of several years. Only in rare cases do 4 or 5 days of such extreme temperature follow in succession without interruption by more moderate weather. The actual figures show that the first hot day does not greatly diminish people's energy, for the human body is able to resist for a while and to carry the impetus of previous good conditions into the first part of a bad period. After 2 or 3 days, however, the heat takes hold on people and makes them inefficient, or even causes some to collapse. If such weather continued for months, we should become somewhat accustomed to it, and the period of collapse would be past. Just what the rate of work would then be, we cannot yet determine. It would almost certainly be slower than on the first hot day, but it would probably be faster than on the third or fourth. Because of this uncertainty, we are obliged for the present to assume that it would be equal to the average of a number of first days and a much smaller number of second, third, fourth, and so on. Having made this assumption, but recognizing that it needs testing, we may go on to construct our map. We must remember that it is not supposed to be a map of the actual energy displayed by the people of various places, but of the energy that we should expect among Europeans. They lived in these places and were influenced as are the people of the eastern United States. In making such a map, it is fortunate that the most important factor is also the one most carefully tabulated by climatologists, and for which our investigations of energy give the most unequivocal results. The mean temperature for every month in the year is given for about 1,100 stations in all parts of the world in Hans' climatology. The third curve from the top in Figure 10, it will be remembered, shows the average efficiency which would be expected at any given temperature on the basis of the work of factory operatives in Connecticut and New York. A table inserted as an appendix to this book shows the value for each degree of temperature according to the centigrade scale, the maximum being reckoned as 100 at a temperature of 15 degrees Celsius or 59 degrees Fahrenheit. To determine the effect of mean temperature upon human activity, we simply take from hand the mean temperature of each month, and then from the table in the appendix, or from the curve in Figure 10, find the corresponding relative efficiency. Then we add the values for all the months. If every month had an average temperature of 59 degrees, with a corresponding relative efficiency of 100, the efficiency of the place in question would be 1,200. As a matter of fact, this is never reached, but London stands at 1,196.6, San Francisco at 1,198.6, and Quinto in Ecuador at 1,198.9. The worst place is Maceió, near the southern end of the Red Sea, where the figure is 1,070. The next process in constructing a map of climatic energy is to determine the effective changes of temperature from day to day. Unfortunately, exact statistics are not available in most regions, and we are obliged to employ an approximation. Since changes from day to day depend chiefly upon the seasonal range of temperature and the number of storms, I have combined the two, giving equal weight to each, and giving the two together approximately 1/2 the weight assigned to seasonal temperature. That is, the difference between Quito and Maceió, as stated in the last paragraph, is 128.9. This represents the maximum effect of the seasons so far as the average temperature is concerned. The maximum effect of the seasons as far as changes from day to day are concerned is reckoned as 30, and the maximum effect of storminess on the same basis is also reckoned as 30. Since highly extreme conditions are not favourable, I have assumed that no seasonal change beyond 30 degrees Celsius or 54 degrees Fahrenheit is of value, and also that changes below -7 degrees Celsius, 19.4 degrees Fahrenheit, or above 23 degrees Celsius, 73.4 Fahrenheit, are of no value. In other words, if the range from the mean temperature of the coldest to the warmest month is from below -7 degrees Celsius to above 23 degrees Celsius, it is reckoned as having a value of 30, just as it would be if -7 degrees were the lowest point and 23 degrees the highest. If the range should be from 4 degrees Celsius to 16 degrees Celsius, it would be reckoned as having a value of 12, while if it were from 20 degrees Celsius to 28 degrees Celsius, the value would be only 3, because the extremely hot weather above 23 degrees would scarcely be stimulating even if there were slight changes from day to day. In the same way, extreme storminess does not produce an effect in proportion to the number of storms. One storm may succeed another so rapidly that the weather ceases to have sufficient variety, and becomes dull and lowering all the time. This is the case at Cape Horn, and also in certain parts of the North American Great Lakes region in winter. Accordingly, a storminess of 20 centimeters per year according to Collimer's scale, which means far more than 20 storms, is reckoned as the optimum. Greater storminess is held to have the same stimulating value as 20 centimeters, while everything lower is counted proportionally. The whole matter is so technical that it cannot be understood without detailed explanations. These are now unnecessary, since the very simple method to be described shortly gives an almost identical but more accurate map. Humidity has not been considered, because the necessary figures are not available. In most of the cooler parts of the world it would make little difference, although a few unduly damp places like Ireland, or excessively dry regions like Chinese Turkestan, would be lower than now appears. The chief difference would be in the warm portions of the world. Agra in northern India, for instance, now has a lower rank than Bombay and Calcutta, but if allowance were made for humidity, this would probably be reversed, for Agra is pleasantly dry much of the year. The same reverse would probably occur between dry Khartoum and wet Equatorville on the Congo. Arizona and other desert portions of the United States would also make a better appearance than on the present map. It must not be forgotten, however, that our data for New England show that extreme dryness does more harm than extreme humidity. This, however, does not apply to high temperatures. Under such conditions, great humidity is undoubtedly most debilitating. Yet even when the air is hot, it may be too dry. In such a place as Death Valley in summer, with a thermometer at 100 degrees to 135 degrees in the shade, it is almost impossible to drink enough water to preserve normal physiological conditions. Even a brief period of physical activity gives rise to much discomfort, and people who stay through the summer are in danger of suffering permanent injury to health. Our knowledge of the effect of both extreme humidity and extreme dryness is unfortunately still qualitative rather than quantitative. Someday, however, exact figures for all the various climatic elements will be obtainable, and we shall construct a map showing the actual efficiency to be expected in every part of the world. It will be so accurate that the manufacturer, for example, who contemplates establishing a factory, will be able to determine the precise efficiency of labor in the different places which he has in mind, and can put the matter into dollars and cents for comparison with the cost of transportation, raw materials, and other factors. Meanwhile, our map makes no claim to be more than a first approximation to the truth. Therefore, no maps of individual continents are now presented, but merely a map of the world. Figure 22 out of the United States, Figure 34. In preparing these, the figures for hand stations have been placed on the maps. Then a line has been drawn to include all the places falling not more than 25 points below the possible maximum. These are ranked as very high and are shaded black. A second line includes places falling from 25 to 50 below the maximum, and the area thus delimited is ranked as high, and shaded with heavy black lines. The next division, indicated by light lines, is ranked as medium, and the values range from 50 to 75 below the maximum. The area shaded with thickly scattered spots includes places ranging from 75 to 115 below maximum, and is counted as low. The fifth division, shaded with widely scattered spots, is very low, and ranges from 115 to 155. Finally, the hot desert areas which fall below 155 are left unshaded, but if humidity were considered, they would probably rank as high as the wet parts of the tropics. Let us now make a similar map on the basis of health. For this purpose, I have used the climatic graph for the eastern United States, as given in World Power and Evolution. Each column, each horizontal line of the original climate graph was plotted, smooth and prolonged to the necessary limits of temperature or humidity, where these exceeded those actually occurring in the eastern United States. It was assumed that a temperature of 100 degrees Fahrenheit and a relative humidity of 100% would speedily cause death, and that a mean temperature of 120 degrees for day and night, even with the lowest relative humidity, would ultimately be fatal. From the smooth data thus prepared, the departures of the death rate from the normal under any combination of temperature and humidity can be determined. On the basis of the data previously given, it was assumed that the effect of variability is approximately equal to that of temperature or humidity. Since the best degree of variability seems to be about 21 storm centers per year according to a Colmer's scale, this number was counted as the optimum. It was assumed that places having this degree of storminess or more have an average in health equal to 1/2 of that due to temperature and humidity combined. This combined effect was measured by the difference between the two extremes of Yuma, 7.8% above normal, and San Diego, 6.3% below normal. Although equal importance is thus assigned to temperature, humidity, and storminess in the United States, the importance of storms for the world as a whole amounts to only about 1/4 that of the other two combined. Unfortunately, the data as to relative humidity are scanty and lack uniformity. Excellent and uniform figures, however, are available for the United States and India, and less satisfactory figures for Russia and Siberia. These indicate that if complete data were available, a map of climatic energy on the basis of the effect of the weather on health in the United States would closely resemble the one based on factory work, as may be seen by comparing figures 34 and 36. Hence, in the absence of good data as to humidity, We may for the present use the map of climatic energy based on factory work, Figure 22. The similarity of this map to the Indian, Siberian, and American portions of the map based on our data for health and the weather in the United States goes far toward proving its general reliability. The most noticeable feature of Figure 22 is two large black areas of very high energy in the United States and southern Canada on the one hand, and in Western Europe on the other. Each is surrounded by a heavily shaded high area of large extent. One lies chiefly in Japan. It is shown as extending into Korea, but the correctness of this is doubtful, for the records of storms in that region are imperfect. The second lies chiefly in New Zealand, but extends into Australia. The records of storms in this region have been published less fully than in Europe and America, but the general appearance of the map seems to be approximately correct. The third of the minor high areas is located in the southern part of South America. The records here are very imperfect, and the extent of the high area is doubtful. The reason for this uncertainty is not only that reliable records of storms are not abundant, but that the available data do not enable us to determine how much change from day to day is caused by the average storm. The amount of change must be slight compared with that experienced under similar circumstances in North America and Eurasia, because no part of the southern end of South America is far from the ocean. The fourth of the minor high areas lies along the Pacific coast of North America. As already stated, its southern portion owes its character not to storms or seasonal changes, but to frequent breezes blowing in from the ocean. It extends only a short distance inland and is too narrow to be prominent on the small-scale maps of this volume. In the far north, human energy appears to decline more than would be expected. We know that population is scanty and civilization low, but we commonly ascribe this to the difficulties of agriculture. Little can be demanded of people who must get a living by hunting and fishing. From the map, however, it appears that even if other circumstances were favourable, we should not look for any great achievements. This accords with the slow, inefficient character of the Eskimos and of the Ostyaks and other inhabitants of northern Siberia. Grenfell, in his book on Labrador, says that the Eskimo cannot compare with the Newfoundland white fisherman for perseverance and snap. An Eskimo does not get one fish for the other's 10. This happens even when the Eskimo is in his native habitat and is doing work to which he has been trained from childhood. Racial inheritance may have much to do with this, but the testimony of white men is that after a long stay in the Arctic, they themselves lose ambition and energy. At the other extreme of climate, the regions within 30 degrees of the equator seem to be characterized by essentially the conditions that we should expect. The status of the highlands is striking. A high degree of energy among white men will not be expected permanently in any of them. We are often told that the climate of tropical highlands is as fine as any in the world. Not infrequently, people are urged to colonize such regions. In book after book we read that there is not the slightest reason why the white man should not live there as well as at home. I do not assert that this may not be possible. In fact, I strongly hope that some day will come to pass. Nevertheless, our map seems to indicate that previous to any such desirable consummation, we must greatly increase our knowledge of how to adapt ourselves to nature, and especially of how to select physical types which are capable of preserving their own health and raising children in spite of the monotonous climate. At present, while the white man may learn to preserve his health in tropical regions, he can scarcely expect to retain the vigour which he displays in the more favoured parts of Europe. The most unexpected feature of the map is a diminution of energy as one proceeds eastward from Western Europe to Central Asia. In the deserts of Turkestan and Mongolia, and especially in the Tibetan highland, the map should probably show lower conditions than are actually depicted. But as records are not available, the medium shading has been extended across the whole of the unknown area. Before making the studies here described, I should have said that a man in Siberia could be as efficient as in far western Russia in the same latitude. Yet the Baltic provinces are very high in climatic energy, while eastward there is a steady decline until only medium conditions are reached. The reason is readily apparent. In the first place, the Siberian winter is colder and longer than that of the region near the Baltic Sea. More important than this, however, is a decline in storminess as one passes eastward across Russia into Siberia. The cyclonic centers of low pressure, which constitute storms, are either broken up when they approach Asia in winter, or else swing out toward the sea to avoid the great area of high barometric pressure which lies over the continent during the cold season. Hence, during midwinter, the far interior is characterized by clear and extremely cold weather, not hard to bear, but steadily benumbing. In the spring and autumn, on the other hand, storms are fairly frequent, and are often of most terrific intensity. The bourans, as they are called, are even worse than our western blizzards, which are the same thing under another name. They destroy cattle and horses by the thousand, and human beings often perish within 100 yards of their houses. Only when the bourans are at an end, and the milder storms of late spring and summer prevail, does Siberia enjoy a highly stimulating climate. Only when the bourans are at an end, and the milder storms of the late spring and summer prevail, does Siberia enjoy a highly stimulating climate. The conditions just described afford an interesting commentary on the common idea that the plains of Siberia are to be the scene of a wonderful development of European civilization over the next few centuries. I formerly shared this opinion, but have now been obliged to modify it. While this chapter was being written, I spoke of this change of opinion to a Russian friend who has come to America for the sake of greater freedom. Yes, he said, that is just what the exiles say. I have many friends who are exiles. When they are sent to Siberia, they take books with them and expect to do much work in writing and along other lines. Some plan to carry on linguistic studies, and some to make various other kinds of scientific investigations, but they almost never do it. They say that at first they begin to work with great vigor, but after a year or two their energy declines. They have the desire to work, but do not seem to do so. They attribute this to being so far from home, and to the lack of stimulating contact with civilization. I think there may be more to it than that, for they seem to lose their energy. Nansen, in his fine book, Through Siberia, the Land of the Future, emphasizes this point. He frequently speaks of the slowness and inertia which he encountered. Here per acre the Siberians raise far smaller crops than the Norwegians, and the main reason assigned by Nansen is lack of care, forethought, and energy in cultivating and fertilizing the soil. There is no hurry here, he says. Siberia is still a country that had a superabundance of time, as of everything else. They may think themselves lucky for having so far escaped the nervous stress that we know too well in Europe. He also quotes Rodoshev, one of the most enlightened members of the Duma, who sums up his impressions of a journey in Siberia with the statement that the Siberians are a people without enterprise or initiative. Yet the vast body of Russians in Siberia consists of pioneers who voluntarily went to the new country. The mere fact that they broke old ties and made the hard journey into the wilderness bespeaks more than the usual degree of energy and initiative. Similar people in the United States and Canada display great activity. In Siberia, the climate seems to dampen their vigor. All this suggests that the old Russian autocracy accomplished its purpose more fully than it realized. It not only exiled many of its most thoughtful and active people, but sent them to a place where not only do the isolation and hardships diminish their power, but where nature insidiously accomplishes exactly the kind of repression that the authorities desire. From the standpoint of climate, without respect to the many other factors which may cause quite other results, the relative positions of Russia and Siberia do not seem likely to change. Both, we may rightly hope, are destined to advance far beyond their present position. But while there is reason to think that Western Russia may approach the standard of Western Europe, Siberia suffers from a handicap which may never let her overtake the Baltic regions on the west of the Great Northern Republic. Turning to China, we find that the summers are often debilitatingly hot, with a steady, damp heat that is apt to be trying. The winters, on the other hand, are by no means so long as in Siberia, nor so severe. Yet they are far worse than in Western Europe, and are as bad as any part of the United States. Cold waves often sweep down from the north, and are so severe that instead of being stimulants, they are depressing in regions like Peking. In the south, however, they are beneficial. Everywhere cyclonic storms are rare, so there is no stimulus of great importance from the source. This is one of the chief reasons why China does not stand high on the energy map. The northern parts of the country are more favoured than those in the south or in the far interior, but the difference is not great. Indeed, the uniformity of all parts is surprising. The disadvantages of high temperature in the south are balanced by those of low in the north. If China were part of a smaller continent, her nearness to the moderating influence of the sea would help her much more than is now the case. All through the winter she is under the benumbing control of the vast continent to the west, which not only sends out severe cold waves, but prevents the passage of storms. Japan, on the contrary, does not suffer so much in this way. Extremes of temperature are milder than in China, and stimulating storms are frequent. Her greatest drawback is a long period of hot, damp weather in summer. Nevertheless, she stands high. Here we must bring our review of the map of climatic energy to a close. We shall come back to it again when we have studied the distribution of civilization. End of section 10. Section 11 of Civilization and Climate by Ellsworth Huntington. This is LibriVox recording. All LibriVox recordings are in the public domain. For more information or volunteer, please visit LibriVox.org. Recorded by Leon Harvey. Chapter 11. The Distribution of Civilization. Doubtless the reader has already noticed the striking resemblance between the distribution of climatic energy and of civilization. Look again at Figure 22 and see how the black areas agree with the places of highest culture. In view of this, it seems advisable to construct a map of civilization to serve as a standard of reference. Only two methods appear feasible. One is by statistics, the other on the basis of opinion. Both present grave difficulties. The statistical method will ultimately prove far the better, but it may not be practicable for centuries. For a fair estimate of the position of a country, we need accurate statistics of education, morality, industry, inventions, scientific and artistic skill, wealth, pauperism, charity, crime, and many other aspects of human life which will rarely suggest themselves. No reliable figures for many of these things have ever been gathered in any part of the world. No statistics for any of them have ever been gathered in many countries. Statistically, it is almost impossible to compare Afghanistan, for example, with Kamchatka. Even when accurate statistics are available, the methods of compiling them are often so diverse as to make comparisons misleading. We may know exactly how many people are arrested and convicted for theft in half a dozen countries. But in one country, the police may be so inefficient that few criminals are apprehended, while in another, practically every thief may be caught. Thus the better may easily appear the worse. The only way to use statistics at present seems to be as a check upon the other method. We can select some country so extensive that its various parts differ decidedly, but sufficiently homogeneous so that the figures for all portions are comparable. Since the United States meets these conditions better than any other country, we shall examine statistics in several cases, and shall use them as a test of a map prepared on the basis of opinion. For a map of the civilization of the entire world, we must rely on the opinion of well-informed persons, but we shall find that this agrees closely with the indications of statistics. The value of a map based on personal opinion depends partially on our definition of civilization, and partially on our confidence in the judgment of the persons in question. Even the best and broadest experience does not eliminate personal or racial bias. Therefore, the only safe course is to obtain the opinions of many people belonging to different races and ruled by different ideals. Accordingly, in the autumn of 1913, I asked over 200 people in 27 countries to help in preparing a map. Most fortunately, this was before the Great War broke out. Good feeling prevailed everywhere, and among men of sound judgment, there was perhaps as little racial prejudice as at any time during the course of history. This is especially important because similar conditions may not prevail again for years. The persons whose assistance was asked were selected for various reasons. The larger number were geographers whose first duty is to know all parts of the world. Ethnologists in considerable numbers were included for the same reason, but they responded less freely than the geographers. Historians, diplomats, colonial officials, travellers, missionaries, editors, educators, and businessmen were all included. The only criterion was that each person should possess an extensive knowledge of the world through personal knowledge, or in a few cases, through reading. Some were selected because of knowledge of special regions not well known to most people and only reached by extensive travel. To all these many kinds of people, numbering 213 in all, I sent the following letter. May I ask your cooperation in the preparation of a map showing the distribution of the higher elements of civilization throughout the world? My purpose is to prepare a map which shall show the distribution of those characteristics which are generally recognized as of the highest value. I mean by this the power of initiative, the capacity for formulating new ideas and for carrying them into effect, the power of self-control, high standards of honesty and morality, the power to lead and to control other races, the capacity for disseminating ideas and other similar qualities which will readily suggest themselves. These qualities find expression in high ideals, respect for law, inventiveness, ability to develop philosophical systems, stability and honesty of government, a highly developed system of education, the capacity to dominate the less civilized parts of the world, and the ability to carry out far-reaching enterprises covering long periods of time and great areas of the Earth's surface. In preparing such a map, it is evident that statistics may afford much assistance, but they need to be supplemented. They touch only upon material things in most cases and are not available for a large part of the world. Therefore, our best resource is the personal opinion of competent judges. Accordingly, I am asking 100 geographers, anthropologists, and other persons of wide knowledge whether they are willing to take the time to divide the regions indicated in the accompanying list into 10 groups, according to the criteria mentioned above. Group 10 will include regions of the very highest character, that is, those where the greatest number of valuable qualities are found in high degree. Group 1 will include those which are lowest in these respects. On the basis of this grouping, I shall determine the average position of each region and shall prepare a map accordingly. The purpose of such a map is threefold. In the first place, it will prove intrinsically interesting to a large number of people and is likely to arouse considerable discussion. In the second place, in all geographical, historical, sociological, and economic discussions, it seems to me that we need a clearer, stronger emphasis upon human character, that is, upon the mental and moral qualities which dominate the civilization of the various nations. If this is so, it is highly important, in the third place, that we should determine much more fully than has yet been the case how far various moral and mental qualities are influenced by physical environment. Race, historical development, biological variations, and other causes. In order to determine these things, we need a map which shall serve, at least approximately, as a standard of reference. In discussing the influence of such things as racial character, differences of religion, social institutions, modern means of communication, the form of the land, the relation of land and sea, variations of climate, and the like, we shall be able to gain much light by comparing their distribution with that of human character as it now exists according to a consensus of expert opinion. The matter can best be illustrated by outlining a specific purpose to which I mean at once to apply the proposed map. Here follows a brief description of the map of human energy on the basis of factory work. I recognize that those to whom this letter is sent will say at once that they are not sufficiently familiar with all parts of the world, and that they have no means of distinguishing between different parts of China, for example, or between the different portions of equatorial Africa. This is certainly true, but it must be remembered that the classification is very rough. It is only desired that 185 names on the enclosed list be divided into 10 groups. No group to contain less than 15 names or more than 21, and each preferably to contain 18 or 19. It may not be easy to determine whether all of the divisions of France, for example, fall in the first group, but it is perfectly evident that none of them will fall in the fifth or lower. The chief thing is to place them as nearly as possible in their proper group according to one's own personal opinion. A given region may probably fall in the fifth group, but the purpose of this classification will not be defeated if it is placed in either the fourth, fifth, or sixth, or when the opinions of 100 persons are averaged, individual idiosyncrasies will disappear. In view of the varying degrees to which each individual is familiar with the different regions of the world, I should be glad if each contributor would underline the names of regions with which he is well acquainted either by travel or reading, and would place question marks after the names of regions as to which his knowledge is especially deficient. Names not underlined or questioned will be considered as intermediate. The 3 grades of familiarity thus indicated will be weighted in the ratios of 3-to-1. This has not been done, partially because only about half of the contributors made the division into 3 grades, and partially because the final results were not appreciably changed by using the unweighted values. The grade of the various regions should be indicated by underlying or questioning the names upon the small slips mentioned below, but may be done upon the accompanying list if that is more convenient. But in that case, please be sure to return the list. For convenience of classification, I enclose slips containing the names of the different divisions. These may be spread out upon a table and arranged in 10 columns, and shifted from column to column until an approximately satisfactory arrangement is reached. When thus arranged, those of each column should be placed in the corresponding envelope of the 10 here closed, and all may be mailed in a large addressed envelope. Envelope 10 is for the highest group, and 1 for the lowest. In making the classification, 1 or 2 points need to be borne in mind. In the first place, the past should not be considered. Greece, for example, should be placed in the group where its condition during the past 100 years would place it without reference to its ancient greatness. In the second place, if 2 races inhabit a given region, both must be considered, and the rank of the region must depend upon the average of the 2, giving each one a weight proportional to the number of people. For instance, in a state such as Georgia, where nearly half the people are Negroes, they must receive half the weight. Still another point is that the rank of a country can often be determined by considering the position which its people take when they migrate elsewhere. For instance, the position of Syrians as compared with the Germans when they migrate to England or the United States is a fair criterion as to the relative merits of the 2 races. After the first generation, however, this should not be applied, for the younger generation owes much of what it is to the new country. A final point concerns countries which are poor in natural resources, or which are not located in the main centres of the world's activity, but which are nevertheless of high character. For example, so far as importance in the affairs of the world is concerned, England vastly outranks Scotland. Nevertheless, our estimate of the greatness of England owes much to the large number of Scotsmen who have gone out to build the British Empire. Therefore, in estimating the relative merits of Scotland and England, the matter of size or even of commercial importance should receive relatively little consideration, whereas the character and ability of the people as rulers, merchants, scientists, writers, and men of all sorts should have a predominating weight. In publishing the final results, I should be glad if I might print the names of those who have contributed, but of course this must be at each individual may choose. The individual lists will not be published, and will be treated as confidential. I judge that our contributors will feel, as I do, that their classifications are of necessity so imperfect that they do not care to distribute them to the world at large. Hence, while the list of contributors will be published unless the contributors prefer otherwise, their individual opinions will be withheld. I hope, however, to publish a list showing the average rank of each country and the range of opinion between those who put it highest and those who put it lowest. Inasmuch as the plan here outlined depends upon the cooperation of many contributors, no single individual can in any respect be held responsible for features in the final map which do not meet his approval. In addition to the general list of divisions, I enclose a set of cards bearing the names of the states of the United States and of the provinces of Canada. Would you be willing to arrange these in groups and place them in the proper envelopes, employing the same method as for the large divisions? Group 1 will be the states or provinces which are least progressive, or least influential, so far as the general character of their citizens is concerned, and Group 6 the highest. Each group should contain about 10 names. The object of this, you see, is to make a map of the United States and southern Canada on the same basis as that of the world, but on a more minute scale. The rough grouping here suggested ought not to take more than a few hours' time. Many days, to be sure, might be devoted to it, but the added accuracy thus gained would not be sufficient to make it worthwhile. If you can give the necessary time at your earliest convenience, I shall be most grateful. If you cannot, would you be willing to return the list, the slips, and the envelopes in order they may ask someone else to do it in your place? Whether you contribute or not, I shall take pleasure in sending you copies of the final results, trusting that I may hear from you soon. I am, very truly yours, Ellsworth Huntington. Replies were received from 137 persons, while others sent copies of their publications, so that an answer of some sort came from about 3/4 of those addressed. The majority of the remaining fourth were foreigners to whom a 6-page letter in English might appear formidable. About 90% of the English and Americans sent replies, which is a very large proportion as such things go. I am convinced that the rest failed to answer chiefly because the classification required more time and was more difficult than I at first realized. The fact that classifications continued to be received for an entire year indicates that many meant to answer, but put my letter aside for a more convenient season, which never arrived. A third of those who replied, 54 to be exact, actually made classifications, and all but 2 or 3 conformed so closely to the general plan that it has been possible to use them. The names of the contributors are given in the appendix. I take this opportunity to express the warmest appreciation of their kindness in cooperating so cordially. Not only their classifications, but their letters were of the highest value, and in many cases contained suggestions which had been of great assistance in preparing this volume. The same is true of many letters from persons who did not contribute, but who took pains to explain their reasons and to suggest ways in which my plan might be improved. Except where direct quotations are employed, I have not attempted to acknowledge my indebtedness for various ideas which distinctly modify the tenor of these pages. This is partially because the same thought was often expressed by several persons, and partially because in many cases I cannot tell from which of several letters an idea was derived. Except in 2 instances, I have also refrained from mentioning names, because where so many have contributed materials of great value, it might seem invidious to mention some and not others. Therefore, I can merely express my gratitude to all concerned. The net result of this attempt at scientific cooperation among men of many races and tongues leaves a strong impression of the spirit of fellowship and friendly helpfulness among men of wide interests in all portions of the world. The countries represented in the final classification and the number of contributors are as follows: Australia 1, Canada 1, Norway 1, Sweden 1, Netherlands 1, Russia 1, Spain 1, Portugal 1, France 2, Italy 2, Japan 3, China 3, Germany 5, Great Britain 7, and the United States 24. The number of Chinese and Japanese is particularly gratifying. The ratio between the number of contributors and the number to whom letters were sent is higher among them than any other main group except the Americans, as may be seen in the appendix. It is to be regretted that no one from India or South America cooperated, and only one, a Russian, from the European countries east of Germany. The difficulty of making the classification is considerable. Several contributors spoke of spending an entire day upon it, or of taking out the slips time after time to arrange them more satisfactorily. Some said that they spent 2 entire days upon it. All seemed impressed by the way in which a systematic classification of this kind brings out the weak spots in a man's knowledge. For instance, here is the way in which one contributor expressed himself. One appreciates what a big world this is and how little one knows about it when he attempts such a task as you have set. It is a most excellent means of taking the conceit out of one. Another puts it in this way: I must confess that it is the most difficult and one of the most humiliating games I have ever tried to play. I always knew I was a fraud as a president of a geographical society, but I never knew how great was my deception. The greatest difficulty I found lay through my ignorance of the proportion of the different races inhabiting a district. An interesting feature of the letters was the diversity of opinion as to the advisability of any such classification of countries. To take the adverse opinions first, one of my best friends, an American geographer, put the matter very strongly. I am complying with your request for a sorting of the slips you sent me. It is a very bad plan, and not, I think, of value. Indeed, I am not sure that I would have done it for anyone else than you. I am glad to say that later he expressed a much less severe opinion. Another geographer, a Teutonic European, speaks more cordially in part of his letter, but comes out bluntly in opposition to this particular plan. I am wholly unable to take part in this work. I take your scheme as a failure. I guess you are here, like some other Americans, under the influence of a too systemizing spirit. it seems to be impossible to classify mankind by this simple method. Still a third, an American anthropologist, is equally uncompromising. Speaking frankly, I do not conceive that the method you suggest is possible of scientific results. One must choose between statistics which are definite and mere judgments which are general. To apply the geographic method to a compound of statistics and loose generalization may be productive of grave error. And a fourth, also an American anthropologist, expresses himself as follows. It has been my endeavor in my anthropological studies to follow the same principles that are laid down for natural sciences, and the first condition of progress is therefore to eliminate the element of subjective value, not that I wish to deny that there are values, but it seems to me necessary to eliminate the peculiar combination of the development of cultural forms and the intrusion of the idea of our estimate of their value, which has nothing to do with these forms. It seems to my mind that in doing so, these obtain subjective values, which in themselves may be the subject of interesting studies, but which do not give any answer to the question that you are trying to solve. Another anthropologist, this time a European, at the end of a particularly long and suggestive letter, expresses himself thus. Taking all that I have written here into consideration, I think that if we are going to grind all the different regions of your long lists in the same statistical mill, and to try to compute an average, a highly improbable and fantastic result would be obtained. For my own edification, I put some of your criteria to the test, though in a different way. I drew up a list of 12 characteristics of the highest value, in which I included sense for beauty in literature, belles lettres, and a few others, and then distributed them to 11 different regions of the globe. My familiarity with those regions by a long sojourn or travel and reading covers a lifetime. To each characteristic for each region, I assign a number from 1 to 10. I then added the different values of points to try to find a ratio, which might be called index of civilization. I give it Vedit quantum valeria protest. The table possesses so many points of interest that it is inserted below. At the end I have added a column showing the rank of the various regions according to all the contributors, as computed according to the system presently to be outlined. If the plan embodied in this table could be carried out on a large scale, it would undoubtedly be better than mine. The difficulty is that it requires a vast amount of work and a degree of familiarity with the various peoples of the earth, which is found only among a few exceptional students who can almost be counted on the fingers. In course of time, we may perhaps hope for a map based on some such minute study of human nature. Yet when it is before us, there is every reason to think that its general features with which alone we are concerned in this book will be almost identical with those of the map which we shall shortly consider. The reasons for this will be given later. One important point stands out in this table. I have given too little weight to the aesthetic side of human nature. In framing a definition of civilization, I consciously thought of art in all its forms, but it seems as if this were included in the capacity for formulating new ideas and for carrying them into effect, just as science is meant to be included. Moreover, the course of history seems to show that every nation which rises high in other respects sooner or later experiences a period of high development in art, architecture, literature, and science. Nevertheless, these things should have received more specific recognition in my definition. To turn now to the other side of the question, those who believe in the utility of the plan presented in my letter naturally do not feel the necessity of stating their reasons. Nevertheless, a considerable number will take pains to express approval. For instance, a widely travelled Englishman thinks that there are tremendous possibilities in all such attempts. An American who is familiar with most of the countries of the world says, "Permit me to say how heartily I thank you for engaging in this enterprise, despite any and all sympathetic or hostile criticism of such a work, or the cheap and hasty, or really valuable appraisal likely to be made. Such a scheme will be invaluable to all students of human progress." Another American, who has spent a large part of his life in the Orient, is of the opinion that it is a fascinating and very significant set of standards by which you have asked us to group the regions. From the time I started after lunch until now, late in the evening, I have done nothing else. But there is more than fascination. There is a very deep issue involved, and I am glad to share in the construction of the map and the charts you are aiming to devise. A table is displayed on the previous page, distribution of some characteristics of higher civilization by H. 10 Kate. One of the fairest estimates of both the advantages and disadvantages of the plan is contained in a letter from Ambassador Bryce, as we Americans still like to call him. With his permission, I quote it in full. Your idea is ingenious and interesting, and I should much like to see how it works out. Though it seems to me on first impressions that the various factors involved are so many and so complex that the visual presentation you contemplate will need an amount of comment and explanation which would require something like a treatise to accompany the map. You give one instance in the case of the state of Georgia. Another might be found in the other Georgia, south of the Caucasus, where besides the native Georgians, Karthli, there are Armenians, Tatars, and Russians, not to speak of minor races. Or take Japan. If one were to think of the educated and ruling Japanese and the sort of civilization they have created, what would make a rating quite inapplicable to the ordinary Japanese, without therefore doubting that by means of a map presenting very interesting results may be obtained, I should think that some modifications would be needed. Efficiency is a very complex conception. If I had time, I should like to try to think further about the scheme, and lend what aid I could to it. But unfortunately, I am so fully occupied by trying to finish a book for the sake of which I retired from the embassy at Washington, that I am, to my regret, unable to cooperate with you. I shall be grateful for any information as to the results you can send me if you have leisure. P.S. Dated 2 weeks after the letter. I have kept the papers some weeks in order to see if I could help you. I have dealt with the states and provinces of the United States and Canada, though roughly, but I have found the difficulty of any adequate arrangement of the extra-European world in point of efficiency impossible in respect of the extraordinary mixture of races. Turkey and India are nuts too hard to crack. In South America it would be easier, because the races are really so mixed that a new race results. But in India they live side by side and are quite different. Here follows a classification of South America. It is quite interesting and makes one think, but after all it is the natural race divisions rather than territorial divisions that count everywhere outside Western Europe. Even in Russia and the Balkans, race doesn't correspond to territory. These various letters give a good idea of the general opinion of the attempted classification. As an illustration of the difficulties to be overcome, let me quote from an Italian contributor and anthropologist. What is the standard of these various civilizations? Yours, as it seems to me, is an European one, and this, I think, is a very limited one and cannot solve the problems. A similar objection is expressed in a letter from an English anthropologist. Quoted from my letter, he says, "The power of self-control, high standards of honesty and morality, high ideals, respect for laws, are eminently characteristic of many savage and barbarian peoples, notably the North American Indians. And in my opinion, these latter stand very much higher than the average American citizen, but the latter lead in the power to lead and control other races, and capacity for disseminating ideas, inventiveness, highly developed systems, etc." I recognize the force of these comments. Races certainly differ greatly, even though they happen to dwell in the same physical environment. Moreover, people of a given race who live under the same environment may differ widely because of diversity in religion, government, or institutions. Furthermore, the definition of civilization here presented does not pretend to be perfect. It is a European definition. It is also a worldwide definition. The contemplative Hindu may perhaps be a higher type than the aggressive citizen of Western Europe, but the contemplative type has made relatively little impression upon the world as a whole. If we turn to antiquity, the people who have left their impress are those who had this so-called European activity. The Greeks and Romans had it to a marked degree. The people of India had something of it when they wrote the Vedas. Gautama had it when he founded the Buddhist religion. He was contemplative, but yet he had the qualities expressed in our definition. He was preeminently possessed of high ideals, respect for law, inventiveness, in the broad non-technical sense, ability to develop philosophical systems, and the capacity to dominate the less civilized parts of the world. He dominated through ideas, not force. The Jews had this same power. Such men as St. Paul, although not aggressive under the ruder European sense, were unsurpassed in the power of initiative, the capacity of formulating new ideas and for carrying them into effect, the power of self-control, high standards of honesty and morality, the power to lead and control, and the capacity for disseminating ideas. The reason for regarding the standard here set forth as European is that Europe is today its great exponent. In the past, however, not only did Rome, Greece, Palestine, and even northern India possess it, but Egypt, Mesopotamia, and Carthage all displayed it. China, too, in her days of early greatness, and the wonderful Maya people of Yucatan, the only ones to develop the art of writing in America, were animated by the same active, stirring European qualities. That is why we remember them, but have forgotten most of their contemporaries. Granting that our definition of civilization is imperfect, but admitting that it includes the qualities which are of greatest importance in causing a nation to impress itself upon the world, let us now proceed to ascertain how these qualities seem to be distributed. The 50 contributors whose classifications could be used have been divided into 5 divisions as follows. 1. 25 Americans, one of whom is a Canadian. 2. 7 British, one of whom is an Australian. 3. 6 Germanic Europeans, 4 of whom are Germans, 1 a Swede, and 1 a Norwegian. 4. 6 Latin Europeans, namely 2 Frenchmen, 2 Italians, 1 Spaniard, and 1 Portuguese, with whom has been included 1 Russian because there is no other group in which he fits more appropriately, and 5 Asiatics, 2 of whom are Chinese and 3 Japanese. A third Chinese contribution was most unfortunately lost in the mail. The average opinion of each of these 5 groups is given in the tables in the appendix. To obtain the final rank of each country, the averages for the 5 groups have again been averaged. Thus each race, or at least each of our 5 divisions, has equal weight in determining the figures on which will be based the map under in later discussions. The opinion of 25 Americans, for example, has no more weight than that of 5 Asiatics. This may seem unfair, but on the whole it seems to be the method best calculated to give a reliable result. All of us are inevitably prejudiced. The Americans put America, especially its more backward parts, higher than is correct. The Asiatics put their own countries too high. By giving America and Asia equal weight, and by dividing Europeans into 3 groups animated by different ideals and different sympathies, we are able largely to eliminate the effect of racial prejudice. The final results are summed up in figures 23 to 28, but I shall defer comment upon these for the present. In the tables in the appendix, the countries of Europe, North America, and Asia have been divided into groups corresponding as nearly as possible to race, while those of Australia, Africa, and South America have each been put in a single group because the racial differences are either not strongly marked, as in Australia and South America, or are highly complicated, as in Africa. Under each group, the country whose final rank is highest has been placed first, and the rest in consecutive order. Figure 23 is displayed on the page, the distribution of civilization in Europe. To begin with Europe, England heads the list. It is the only region placed in the first rank by every contributor. Northwestern Germany, which includes Berlin, comes next. The Germanic Europeans and the Asiatics all place it in the first rank. The British almost invariably do so, and their opinion, 9.9, averages the same as that of all divisions. Among the Americans and Latins, several place this part of Germany in the 9th class instead of the 10th. Hence its average position, according to them, is about 9.8. Such slight differences have little significance, for 98% is almost as good as 100%. Yet they suggest that in 1913, people who live in other parts of the world were on the whole not quite so sure of the Germans as of the English. Following northwestern Germany, we find central Germany, then Scotland, Denmark, Holland, and so on to northeastern Germany. Here for the first time we come to a region which is placed by one group, the Latins, in a rank lower than 9.0. Yet even here the Latins do not assign a rank lower than 8.5, and everything above this rank is very high. Nowhere in these first 14 regions does the greatest diversity account to more than 1 degree on our scale of 10, or 10% on the scale of 100. This is comparatively insignificant, for it means that while the difference between the highest and the lowest may be 10%, each of them usually differs from the average by only about 5%. Thus, so far as numbers 1 to 14 are concerned, the difference of opinion among Americans, British, Germans, Latins, and Asiatics is almost negligible. All alike rank these regions very high. Coming to Ireland, a country which, for lack of any other suitable group, is placed with the Teutonic regions, we find much more diversity of opinion. The English, presumably because it is part of their own empire, and the Asiatics, perhaps because it seems to them like a part of England, place it very high with a rank close to 9.0. The Germans, on the other hand, place it at 7.0, scarcely above the medium grade, while the Americans and Latins place it near 8.0, which means that compared with the world as a whole, they think that Ireland stands high, but not very high. The fact that all the Teutonic regions except Ireland and the Austrian Alps rank above 9.0, and that these two, which are partially Teutonic, stand in the high group near 8.0, suggests that race is a dominant factor in determining the status of civilization. The same suggestion is enforced when we note that among the Roman nations, the most Teutonized portions stand highest. Yet the fact that innate racial differences may be of great and even overwhelming importance, as I have shown in the character of races, by no means alters the fact that geographical conditions also play a highly important part. Figure 24 is displayed on the page, the distribution of civilization in Asia. The Romance nations of Europe seem to possess much more diversity of civilization than do the Teutons, even if Albania and Montenegro be admitted as not being truly Romance. The range is from medium in Corsica and Sardinia to high in many regions, and very high in parts of France and northern Italy. Some places, such as southeastern Spain and southern Italy, are rated exceptionally high by the Asiatics, although the other contributors agree quite closely. Among the Slavic nations, Central Russia stands at only 6.2 in American opinion, possibly because Jewish atrocities were freshly in mind when the classification was made. In general, there can be no question that the Baltic provinces and Bohemia stand at the top, while southeastern and northeastern Russia are at the bottom. Figure 25 is displayed on the page, the distribution of civilization in Australia. The European region whose rank is most doubtful is southern Finland. The Asiatics reduce it to about 6.6, while the Germans rate it at 9.4. Even in so extreme a case, the average opinion is not open to much criticism. The final rank is about 8.0, which puts Finland at nearly the same level as Bohemia, the Baltic provinces of Russia, Ireland, and the Australian Alps. It would be interesting to go through all the tables and point out their special features, but this must be left for the reader to do by himself. Only 1 or 2 additional points can be indicated. In Asia, the first thing that strikes one is a great diversity of opinion as to Japan and China. This is due to the fact that the Japanese and Chinese place their own countries much higher than do the people of other races. Figure 26 is displayed on the page, the distribution of civilization in Africa. This is natural. The surprising thing is rather that these people, with their justifiable pride in a great past, do not place their own countries at the very top. Figure 27 is displayed on the page, the distribution of civilization in South America. They recognize that Europe and North America have in certain ways surpassed them. Aside from Japan and China, the agreement of the different groups as the position of Asiatic countries is on the whole surprising. Only in rare cases does the opinion of any one group depart from the average opinion by more than a single degree on the scale of 10. 2 of the few exceptions are Rajputana and the Syrian Desert, both of which are placed exceptionally low by the Asiatics. In Australia and North America, the diversity of opinion is much greater than in the older continents. It reaches a maximum in Canada, especially in Alberta, and in southern Greenland and Iceland. In such places, opinion ceases to be of any special value. People simply do not know what sort of conditions actually prevail. In Australia, likewise, the comparative newness of the country causes some people to overrate it and others to depreciate it. It has not yet reached the stable equilibrium which gives the world as a whole a well-defined opinion. In the United States, there is no more diversity of opinion than in Europe, for that country has taken its true place among the nations. In Australia and Canada, on the other hand, outsiders who live far away and who are not racially connected with the inhabitants are still skeptical as to whether those countries are actually destined to rise as high as their people claim. Thus far we have drawn attention to differences of opinion more than to agreements. Let us now examine the matter in another way, which brings out the essential agreements. We will take North America because it is the continent as to which there is the greatest diversity of opinion. Figures 28 to 33 present a series of maps based on the average opinion of all divisions and contributors, and on the individual opinion of each division respectively. Here, as in figures 23 and 27, the rank of each region has been written in its proper place on the map. Then lines have been drawn in such a way as to separate the areas above and below 9, above and below 8, and so forth. Figure 28 is displayed on the page, Civilization in North America according to all contributors. Figure 29 is displayed on the page, Civilization in North America according to 25 Americans. The areas ranking above 9.0 have been heavily shaded, those from 8.0 to 9.0 less heavily, and so on until places below 2.0 are more or less unshaded. This gives a map of civilization whose main features can readily be grasped. In Figure 28, which represents the average opinion of all groups of contributors, certain main features stand out prominently. They are 1. An area where civilization declines rapidly northward in British America. 2. A high area extending from east to west across the northern half of the United States and a narrow southern band of Canada. 3. An exceptionally high area in the northeastern United States from the Mississippi to the Atlantic Ocean. 4. A similar small high area on the Pacific coast. 5. A bight of lower but not of low territory extending into Nevada. 6. A rather rapid decline south of the United States, which is interrupted by 7. An area of slight improvement in central Mexico. Let us now turn to Figure 29 and see how the opinion of Americans differs from that of the world as a whole. The general aspect of the two maps is the same, for every one of the 7 features just mentioned can be detected. The older states along the Atlantic, from New England to the northern Gulf states, have almost identically the same rank in both maps. The chief difference lies in this. The Americans have a higher idea of the new parts of their country and of the new parts of Canada than have the people of other places. They have a correspondingly low idea of the countries immediately to the south of them. In Central America, their opinion does not differ greatly from that of the rest of the world, but they place the West Indies and Mexico relatively low. In the West Indies, this is probably due in large measure to the fact that in order to prevent internal convulsion, the United States has repeatedly intervened in Cuba during the brief period of self-government enjoyed by that country. The low estimate of Mexico probably arises from recent revolutions, which at the time when the classification was made were producing a most unpleasant impression in the United States. In Europe and Asia, the disorders of Cuba and Mexico attract relatively little attention, and the contributors to our classification probably thought of these countries as they were during their periods of long peace. Now let us study British opinion as expressed in Figure 30. One of the most noticeable things is the English opinion of the southern United States, and especially the southwestern deserts. No patriotic feelings, either conscious or unconscious, lead them to believe that high conditions extend to the Mexican boundary beyond which Americans believe that there is a great and sudden change. Their opinion of the Atlantic portions of the United States is almost identical with that of the Americans and the rest of the world, and they agree with other races in their opinion of the regions south of the United States. They believe, as does almost everyone, that the Pacific coast of the United States stands higher than the western part of the interior. but they do not think quite so well of it as do the Americans, although the difference is slight. The places where their national pride comes into prominence are in Newfoundland and the Canadian Northwest. It is interesting to notice that while they place Newfoundland and British Columbia higher than do the Americans, they do not have so high an opinion of the maritime provinces nor of Alberta, Saskatchewan, and Winnipeg. In the latter regions, this is easily explicable. A great number of Americans have gone to Winnipeg, Alberta, and Saskatchewan during recent years, and their glowing reports have made upon Americans a great impression which has not yet reached England so strongly, and has scarcely touched the rest of the world. Americans perhaps think more highly of the maritime provinces than do the English, because many of the most energetic Nova Scotians and other provincials come to the States and display marked ability. To cite a case which has come under my own observation, the students from Acadia College in Nova Scotia, who carry on work in the graduate school of Yale University, for some years maintain a higher average grade in their studies than did those from any other institution. Figure 30 is displayed on the page, distribution of civilization in North America according to 7 British contributors. Figure 81 is displayed on the page, civilization in North America according to 6 Germanic Europeans. In the German map, figure 31, the 7 general features already enumerated can readily be detected, just as in the American and English maps. The differences are largely matters of detail, such a feature as the assignment of a rank of 9.0 to the northern Rocky Mountain states of Idaho, Wyoming, and Montana, and of only 8.0 to the Dakotas, Minnesota, Nebraska, and Iowa is probably due to lack of familiarity with the interior of the continent. Why Newfoundland should stand so high is not evident, unless it is because the name has long been known and is very familiar. In the high position of Iceland, racial pride is again evident, for the Icelanders are close akin to the Germans. The Romance peoples present a map, figure 32, which again shows all the main features. They know, however, even less of the recent development of the western United States and of the Canadian Northwest than do the Germans. To them, Alberta and Saskatchewan are apparently undeveloped tracts where trappers and Indians still roam, for otherwise they surely do not assign so low a rank as 4.4. Newfoundland, for some reason, is also placed low, only 5.2, and Greenland still lower, 3.4. On the other hand, just as the presence of Germanic people in Iceland and Greenland draws the high lines far to the northeast in the Germanic map, and as pride of country bulges the high lines to include the whole United States in the American map, so a similar racial pride causes Cuba and the Creole regions of Louisiana to be much higher on the Latin map than on any other. Last comes the Asiatics with a map, figure 33, which is surprisingly like the other maps. They do not yet realize what has happened in the Canadian Northwest, but their opinion of Eastern Canada and Newfoundland is close to the average. The place where they differ chiefly from others is in their relative ideas of the northern Rocky Mountain states, to which they assign a rank of only 7.6, and of the southern states, which they place all the way from 8.2 to 9.4. Apparently the eastern United States seems to them highly progressive in all parts, and they do not attach much importance to the presence of the Negroes, a disadvantage which Americans themselves feel strongly. Taking these maps as a whole, we see that they all give the same general impression. Where one group goes to a great extreme, as in Newfoundland or Greenland, some other is likely to go to the opposite extreme. Thus the eccentricities of judgment displayed by one race are largely counteracted by those of another. When all are averaged, the number of inconsistencies is greatly diminished. To Americans and English it may seem that Alberta and Saskatchewan, for example, should have a rank higher than is here given them, but we are forced to admit that final judgment is not possible until these regions have been well populated for a generation or two. Taken as a whole, figure 28 seems to contain no important inconsistencies, even though one might wish to change the rank of certain places in which he is particularly interested. The map represents the judgment of thoughtful people in many countries. If 50 other equally well-informed people representing an equally large number of countries in 3 separate continents were chosen to make another classification, it is highly improbable that their map would differ from Figure 28 so much as this map differs from the others. The chances are that the two would be so nearly alike as to be indistinguishable. Inasmuch as there is more diversity of opinion in regard to North America than to any other continent, the maps of the others approach still more closely to a true representation of the opinion of thoughtful people all over the world. The maps are by no means perfect, for human judgment is fallible, yet they at least present so close an approximation to the truth that we may use their general features without danger of error. During the World War and succeeding period of hot prejudice, it seemed to many people that the truth of this last statement was doubtful. Figure 32 is displayed on the page, civilization in North America according to 6 Latin Europeans and 1 Russian. Figure 33 is displayed on the page, civilization in North America according to 5 Asiatics. But soberer thought today shows that this is by no means the case. During the war, the steadfastness and ability with which the various races fought was almost directly in harmony with their position in our map of civilization. The Portuguese, with a rank of 70, had to be taken out of the main line of battle, for they could not withstand Germans who rank above 95. The Austrians, Poles, Italians, and Russians, not to mention the Asiatics and Africans, came out of the war with less military prestige than the British, French, and Germans. Moreover, since the war, the European countries shaded black in Figure 23, that is, those ranking highest in civilization, have recovered more rapidly than their neighbours of lower rank. France and Belgium, in spite of being ravished, and Germany, in spite of her financial debacle, have strengthened their positions in many respects, and are pushing ahead with remarkable energy. Russia, on the other hand, remains in a curious state of suspended animation, perplexing the world by her combination of inertia and radicalism. The Soviet system is perhaps only nominally at the root of her troubles. The wholesale exodus and slaughter of the old leading classes have probably done irreparable damage, whose full results may not appear for many years. But back of both these facts lies something in Russian character, something which before the war held that country down to a rank of from 46 to 73 in Figure 23. Spain, Italy, Hungary, Greece, and the rest of southern and eastern Europe have likewise behaved as one would expect of countries on the level of progress indicated by their respective positions on our maps of civilization. Thus, on the whole, the World War and its aftermath seem to confirm the value of our method of estimating human progress. End of section 11. Section 12 of Civilization and Climate by Ellsworth Huntington. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information on a volunteer, please visit LibriVox.org. Recorded by Leon Harvey. Chapter 12. Vitality and Education in the United States. We now have before us maps of the world depicting the distribution of climatic energy and of civilization. Our ultimate object is to compare them and see whether they are causally related. It will add to the certainty of our results, however, if we first apply an independent statistical test to each of our 2 maps. Since the methods of compiling statistics vary greatly, our results will be most reliable if we confine ourselves to a single country. The United States is easily the best for this purpose. It possesses a large and highly varied area which tends to produce diversity. Its census and such organizations as life insurance companies furnish data compiled according to the same method in all parts. It is homogeneous in government and institutions. Equal opportunities are open to all, and the same ideals and methods prevail almost everywhere. Moreover, no part has been devastated by war or any other great disturbance for nearly 2 generations. The people have moved freely from place to place, and there has been a constant tendency to foster a single type of culture. From all these points of view, no other equal area is so nearly uniform. Racially, the country is of course complex, but until the last few decades the great majority of the people have been Nordics from northwestern Europe. The various types have mixed to such a degree, and have become so strongly Americanized, that the native white population is everywhere similar. The only large elements which tend strongly toward diversity are the Negroes and the recent immigrants from non-Teutonic countries. If these are eliminated, as they are to a large degree in the maps that we shall consider, essentially the same degree of energy and civilization ought to prevail throughout the country except where geographic surroundings, the presence of some special institution, or some other disturbing factor makes itself felt. Figure 34 is displayed on the page, climatic energy in the United States on the basis of factory work. Figure 35 is displayed on the page, vitality in the United States according to life insurance statistics. Figure 86 is displayed on the page, distribution of climatic health on basis of seasonal variations in 33 cities, 1900 to 1915. Figure 87 is displayed on the page, civilization in the United States. The numbers indicate the relative rank on a scale of 6.0 according to 23 contributors. The highest possible rank is 6.0 and the lowest 1.0. The scale is entirely independent of the one used for the world as a whole. One of the best tests of energy is vitality. We have already seen that the death rate varies from month to month in close harmony with variations in the strength of factory operatives. Let us now see whether there is similar geographic harmony. Figure 34 shows the distribution of climatic energy in the United States. It is a revision of Figure 22, but on a larger scale. Figure 36 is a new map of climatic energy based on seasonal variations in the death rate as described in chapters 7 to 9. The general similarity of these two maps compiled in absolutely different ways is one of the strong reasons for believing that they give a true idea of the distribution of climatic energy. Where either one is heavily shaded, we should expect people to be strong, vigorous, and long-lived. We might test this expectation by ordinary mortality data, but such data make no allowance for age, nor for such conditions as a preponderance of unhealthful cities and manufacturing in the northeast, and the natural selection of more vigorous types as migrants to the west. A more reliable test is furnished by insurance companies, for their policyholders are much more homogeneous than the population as a whole, and full allowance is made for age. A comparison between the actual deaths among policyholders and the deaths expected on the basis of standard life tables gives a good idea of the vitality of a community. Figure 35 shows such a comparison. It is based on the combined experience of 3 prominent life insurance companies whose officials have kindly placed in my hands the figures for hundreds of thousands of people arranged by states. On the map, the figures indicate the actual number of deaths compared with the average for the whole country, which is taken as 100. The country has been divided into 5 grades corresponding to those of the energy map. The 2 heaviest shadings include regions where the mortality is distinctly less than would be expected from the actual tables. The 3rd degree of shading indicates conditions little better than the average. The 4th, high mortality, and the lightest, very high. The individual maps for each of the 3 companies are closely similar, which indicates that the general features are not due to any special policy of one company. Indeed, so far as the policy of the companies is concerned, the southern states ought to present a better record than the northern, for the restrictions upon the issuance of policies are there more rigid. For instance, one company entirely refuses to issue any policies in certain unhealthful sections of the South. Elsewhere, only people engaged in special kinds of healthful occupations are accepted. Moreover, in the places where risks are accepted upon the same terms as in the North, the medical examination is often more strict, especially in respect to preventable diseases such as tuberculosis. Various other considerations differentiate one region from another. For instance, in cities, especially manufacturing cities, the death rate is higher than in country districts, and this causes New York State to be unduly high. Miners are an especially precarious class from the standpoint of the insurance companies, and therefore excluded by at least one of our 3 companies in some of the more remote western states, and are accepted only in small numbers by the others. They may account for the poor position of Montana, but the neighboring mining state of Idaho ought, in that case, to be equally bad. In all the more important respects, the tendency would be to cause the death rate in the South to be lower than in the North, were it not for the distributing element of physical weakness due to climate. In tropical countries, the figures are far worse than in the southern states, which is what would naturally be expected. The fact that sick people often go west for their health does not enter into the problem. Such people cannot obtain insurance. If they have been insured before they become sick, they are reckoned as belonging to the place where they lived when the policies were issued, and not to the place where they die. It would be interesting to enter into further details, but space does not permit. The outstanding feature of the vitality map is its agreement with the maps of climatic energy. As people die in greatest numbers during months when their energy is low, so they die in parts of the country where their energy would be expected to be diminished on account of the climate. In figures 34, 35 and 36, conditions are best in the north, from New England to Kansas. Westward and southward they become less favourable. The decline in health is probably due in part to the direct physiological effect of climate, and in part to its indirect effect upon sanitation and other methods for the promotion of health. The direct and indirect effects of climate almost inevitably go together, for where people's energy is great, they are quick to adopt new means for the prevention of disease and the improvement of health. Moreover, in dry and still more in warm regions, it is easy to tolerate unsanitary methods of disposing of sewage, which thus pollutes the water supply. Yet all these things would apparently lose part of their importance were it not for the weakening effect which certain climatic conditions unquestionably produce, as is so well proved by the variation of the death rate from month to month, even in places where the conditions of health are most carefully looked after. Here we must leave the matter. The general agreement of the vitality map with the map of climatic energy affords strong evidence that the climatic map is correct. We are now ready to test our map of civilization in the same way that we have tested the map of climatic energy, that is, by comparing it with a map based on statistics. Strength and energy of character cannot easily be reduced to statistics, for most of the conditions and activities for which we possess exact data depend too much upon outside circumstances and not sufficiently upon the actual qualities of the people. Professor Mark Jefferson has studied the matter carefully, and I have borrowed freely from both his published and unpublished work. It might seem as if such things as railroads, the number of letters, the amount of manufacturers, or other similar matters might furnish a good clue to the intellectual capacity and cultural development of a people, but unfortunately this is not so. Take the case of railroads. Nevada has more miles of railroad in proportion both to the number of inhabitants and the inhabited area than any other state in the Union. In 1920, it had 198 miles for every 10,000 inhabitants, while Rhode Island had only 3.3 and Massachusetts 5.5. This does not mean that Nevada is more progressive than New England. The case is like that of a desert through which a cowboy was riding when he met a friend. "What are you doing here?" asked the friend. "Nothing," was the answer. "I'm just crossing this here desert because it's here." In the same way, the railroads crossed Nevada because it happened to lie between the east and the west. If it were uninhabited, or peopled by savages, it would still have many railroads. The letters sent out by a community furnish a criterion of its state of civilization, but even this must be used with much caution. 100 letters sent by a Chicago mail order house in response to orders averaging $2 apiece are no more significant than a single letter from Detroit in answer to an order for an automobile. In this case, as in many others, a concentration of activity in certain regions may occur without any correspondingly high ability or culture. The same is true of manufacturers. Doubtless, manufacturers generally develop whenever a community rises to a high state of civilization, and the manufacturing processes and all that goes with them are in turn a help in the development of a still higher civilization. Nevertheless, the accidents of position or the presence of natural resources are commonly supposed to cause equally progressive and competent communities to differ enormously in the number of factories. We shall examine this supposition later. We are forced, therefore, to turn to something more personal. Illiteracy and education are fairly good tests, for they depend largely on the immediate surroundings of each individual. Illiteracy would answer the purpose excellently were it not that people had moved about so much in recent years. Education, however, is still a local matter, especially in a country like the United States. Each state, and often each country or town, decides for itself how much it will spend for schools, how long they shall be open, and how stringently attendance shall be enforced. Hence the schools form an unusually delicate test of the real character of a community. The quality of an educational system cannot indeed be measured exactly by statistics. Nevertheless, it is fairly well indicated by certain conditions for which accurate statistics are available. For this purpose, I have selected the following data for the year 1920 from the reports of the United States Commissioner of Education and from the census. 1. Percentage of young people 7 to 14 years of age who attend school. Colored children, those born in foreign countries, and the children of foreign-born parents are excluded in order to make our data as homogeneous as possible. The percentages range from 82.5 in Utah and 79.6 in Idaho to 66.9 in Maryland and Georgia and 65.4 in Louisiana. 2. Percentage of young people 18 years of age who graduate from a 4-year course in either a public or private high school. Since colored and foreign-born parents are not distinguished from native whites in the data for high school graduates, I have assumed that all the graduates were whites, and have calculated the percentage of high school graduates accordingly. This of course gives the South a certain advantage and thus compensates for the fact that in using the next two criteria, it has been necessary to include colored pupils in one case and colored teachers in the other. It must be remembered, however, that the foreign-born population of the Northeast tends to lower the standards there just as do the Negroes in the South, although not so much. The maximum percentage of high school graduates is reached in Maine, 28.6, New Hampshire, 27.8, and Oregon, 26.2. The minimum is found in Georgia, 3.9, and South Carolina, 2.2. But when the allowance described above is made for colored people, the figures become 6.6 and 4.5. 3. Average number of days per year that each pupil in the public schools was actually in attendance. Good schools as a rule are in session fairly long and always insist on a high degree of regularity in attendance. The range here is from 151.3 in New Jersey and 149.6 in Massachusetts to 76 in South Carolina and 76.9 in Mississippi. 4. Average salary of teachers. Unless teachers are well paid, the more capable young people are likely to give up teaching for some more lucrative and less nerve-wracking occupation. Contrary to general belief, teachers are paid at about the same rate in the Northeast and the Far West, the maximum averages being $1,282 in New Jersey and $1,262 in Massachusetts, compared with $1,375 in Oregon and $1,281 in Washington. In the intermediate regions, the general scale of recompense falls lower, dropping to $1,081 in Illinois, which outranks all its neighbors except Ohio, and to $696 in South Dakota. In the South, the level is very low, with a minimum of $426 in Georgia and only $291 in Mississippi. 5. The excess of young men over young women among students 18 to 20 years of age. This last item may at first sight seem unimportant, but its significance grows as one studies it. In regions when the standards are low, there is a tendency for the older boys to drop out of school, while the girls keep on in order to become stenographers, bookkeepers, or especially teachers. Maryland and Utah have the greatest success of boys over girls, and Wyoming, Montana, and the Dakotas the greatest success in girls. Figure 38 is displayed on the page, Distribution of Education in the United States in 1920, on basis of 5 factors equally weighed. Figure 89 is displayed on the page, Percentage of gainfully employed persons in the United States engaged in manufacturing 1919. In using these 5 criteria, each one was given exactly the same weight. That is, the census figures for any given criterion were all lowered or raised proportionally, so that for each criterion, the difference between the lowest and highest figures was the same. As the number of criteria was increased, it was noticeable that the resultant map, Figure 38, became more regular. In its final form, the map shows that in a relatively narrow belt extending from southern New England through New York, but not Pennsylvania, and continuing to Illinois, the general conditions of education are excellent. The same is true in Utah and on the entire Pacific coast. In those places, on the whole, a large percentage of the children are in school. A large proportion graduate from the high school. The school year is long and the pupils are regular in attendance. The teachers are well paid, and many boys, as well as girls, continue to study after the age of 18. One or another of these conditions may break down in any individual state, but when all are taken together, the heavily shaded areas in Figure 38 rank high. One of the most noteworthy features of Figure 38 is the relatively low position of the Dakotas and other states in the western part of the Great Plains, and also the similar position of all the Rocky Mountain states with the exception of Utah. The comparatively recent settlement of some of these states explains the situation in part, but Washington is almost as new as the Dakotas or New Mexico, and yet stands in the first rank. The sparsity of population is another factor which hinders education. Utah, however, has a population decidedly more sparse than that of the Dakotas and Wyoming, but ranks 126, where they rank from 113 to 119. Its density of population is scarcely greater than that of New Mexico, whose rank is 110. The relatively poor conditions in the Dakotas and Wyoming find a partial explanation in the fact that the population is more completely agricultural than in almost any other part of the United States. There are no large cities, and even villages are comparatively scarce or small. The great majority of the people live scattered over the vast plain, each family on its own quarter section. Hence the children are obliged to go long distances to school. Muddy roads often make this difficult in the spring, while the severe storms of winter are an even greater obstacle. In spite of this, the Dakotas stand at the top in the literacy of their people, so that the school system must be fairly efficient. In New Mexico, quite the contrary conditions prevail. A part of the people, to be sure, live on widely scattered ranches, where the children cannot go to school. By far the larger number, however, live in compact settlements, where the houses are grouped in a comparatively small area because of the necessity for using a common water supply for irrigation, or else because of mining industries. Under such conditions, schools can be maintained more easily than on huge townless plans like those of the Dakotas. The same conditions prevail in Utah and Nevada, and to a less extent in Idaho, Wyoming, and Montana. Nevada's rank of 117 may be less creditable than South Dakota's of 114, yet the fact remains that the Dakotas are lower than would be expected, while Utah is surprisingly high. The proud position of Utah is presumably the result of Mormonism. The leaders of that faith have had the wisdom to insist on a thorough system of schools, and have obliged the children to attend them. The Gentiles have in self-defense been forced to do equally well, and the result has been admirable. Whatever one may think of Mormonism as a religious belief, it must be credited with having accomplished a remarkable work in spreading a moderate degree of education almost universally among the people of Utah. Without its influence, the rank of Utah would probably be about 118, that is between Colorado, 119, on one side, and Nevada, 117 on the other. I emphasize this because it shows how clearly our maps reflect the influence of any peculiar condition. Manifestly, the distribution of education throughout most of the United States does not depend upon the influence of any particular institution, for essentially the same institutions prevail everywhere. Yet in the map of education, Utah is conspicuous because it is strongly influenced by a unique American institution which is limited to one small area. Another factor which would be expected to bear an important part in determining the distribution of education is the presence of the Negro. Doubtless this has a pronounced effect, for an inferior race inevitably retards a higher. Yet the map indicates that other factors are equally important. Not only is education at a low ebb in New Mexico, which has few Negroes, but also in West Virginia, which is comparatively free from both Negroes and Mexicans. Moreover, Texas, where the colored people form only a fifth of the population, stands lower than South Carolina and Mississippi, where half the people are colored. Another significant fact is that the education of Negroes varies from state to state almost as does that of whites. Although a smaller proportion of Negroes than of whites go to school, the two races are well or poorly educated in the same places. In Figure 38, the figures for states with a moderate number of Negroes, such as Virginia, with 30%, give a fairly correct impression, but the impression is not so accurate in those states where there are many Negroes. The reason is that our index figures for states with many Negroes are too high by reason of our assumption that all the high school graduates are white. Disregarding these minor discrepancies, it seems quite clear that the degree of education is not proportional to the number of coloured people. The southern states differ among themselves because of special circumstances such as good or bad laws, but all stand low because of more general factors. These factors give to Figure 38 its general character and seem to make it as good an epitome of the general distribution of culture in the United States as we are yet able to obtain on the basis of the statistics of a single activity. Nevertheless, it can scarcely be doubted that the general level of the South is much lower than it would be if there never had been any coloured people there, but that would not change the general aspect of Figure 38. Let us now compare our educational map with Figure 37, which represents the distribution of civilization in the United States according to the opinion of 23 people. All of these except Ambassador Bryce were Americans. They grouped the states and provinces of the United States and Canada into 6 classes, number 6 being the highest. Massachusetts is the only state invariably placed in the highest class. New Mexico and Arizona, which stand lowest, have an average rank of 1.6. In order to judge how much reliance to place on the classifications, I took the first 10 that were received and averaged them, and when 10 more had come to hand, averaged them also. Somewhat to my surprise, as much to my pleasure, the 2 sets of averages were practically identical. How much they differed may be seen in the appendix. The average difference is only 0.2, and the maximum 0.6. The agreement of the 2 sets probably indicates that any other group of equally well-informed persons would have made essentially the same classification. To be sure, in spite of several attempts, I was unable to obtain any contributor in the states west of Minnesota or south of the Ohio River. Local prejudices, however, have probably not exerted much effect on the final results, for California stands in the highest class, with practically the same grade as Minnesota and Iowa. A comparison of the maps of civilization, Figure 37, and education, Figure 38, is interesting. In general aspect, the 2 are similar. Both have 2 high areas, one in the northeast and center, and the other on the Pacific coast. In both there is a decline from north to south. Another common feature is a tongue of high conditions, jutting out toward Kansas. This eastern high area and its western counterpart are almost identical with those of the map of civilization. In both maps, Massachusetts takes first place. In the map of progress, Connecticut, New York, and Ohio come next, all 3 being equal. In the educational map, the rank is Connecticut, New Jersey, Washington, California, Ohio, Utah, Oregon, and then New York. Judging by this, our eastern contributors to the map of progress do not quite do justice to the Pacific coast. Nevertheless, the differences among the states just mentioned are too slight to be important. The only real discrepancies between figures 37 and 38 are the high position of Utah in the educational map, which has already been explained, and the absence of the low tongue jutting into Nevada. This is perhaps due in part to an undue lowering of the general educational level of the Southeast by reason of the Negroes. Also, the contributors to the map of progress probably paid too much attention to aridity, sparseness of population, and the ephemeral character of mining towns, and not enough to the fact that the inherent quality of the people of newly settled regions is almost invariably high. The process of selection incident to migration, as I have shown in the character of races, goes far to ensure such quality, provided the migration is unassisted and is beset with sufficient difficulty. In concluding this chapter, let us look at another criterion which is often supposed to be closely associated with civilization. This is the percentage of the population engaged in manufacturing. It is often asserted that manufacturing is most predominant in places where supplies of coal and iron are present, but this is a mistake. A mathematical analysis of the states of the United States by means of correlation coefficients shows that there is no relation whatever between the amount of coal mined per inhabitant and the percentage of the population engaged in manufacturing. In the world as a whole, the same is true. We've been misled by the accidental circumstance that England, Western Europe, and the United States happen to be places where coal is very abundant. But relatively speaking, those regions stood just as high in civilization before the age of machinery as since. They were leaders then as now. The important factor in determining the presence of manufacturing is the character and energy of the people. If anyone doubts this, let him study the progress of manufacturing in Switzerland, Sweden, New England, Japan, or on our own Pacific coast, in spite of small supplies of coal. Hence Figure 89, page 284, showing the percentage of the population engaged in manufacturing, is in many ways a map of the distribution of progress. It also reflects the location of certain natural resources such as cotton in the south and Cuban tobacco, which is manufactured on a large scale in Florida, at Tampa and Jacksonville. Nevertheless, the main aspects of Figure 39 are surprisingly like those of Figures 37 and 38. The similarity of our maps of education and manufacturing to one another, and to the map of progress based on the opinions of our 23 contributors, is too close to be accidental. It seems to show that all three present a fairly accurate portrayal of the actual distribution of human progress. Since our two maps of climatic energy likewise not only resemble one another but are closely similar to the map of mortality, we may feel fairly sure that in all parts of the world the same relationship holds true. End of section 12. Section 13 of Civilization and Climate by Ellsworth Huntington. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Leon Harvey. Chapter 13. The Conditions of Civilization. We have now reached a crucial point in our investigation. We must compare the distribution of civilization and of climatic energy. The reader has doubtless noticed that our maps of climatic energy in the United States, whether based on factory work or health, display an unmistakable similarity to the maps of human progress based on education, manufacturing, and general opinion. In spite of minor discrepancies, all the maps show the following features. 1. A high area elongated east and west from New England and New Jersey to a little beyond the Mississippi. 2. Another a much narrower area, elongated north and south along the immediate coast of the Pacific Ocean. 3. A decline from north to south in the east. And 4. A low bay running across the country in the Rocky Mountain region, with a pronounced accentuation in the dry southwest. While these details are fresh in mind, let us turn to 3 maps of Europe showing the relation of climatic energy, Figure 40, Health, Figure 41, and Progress, Figure 42. The map of climatic energy is based on our factory data, but with some modification, because we have found that the optimum temperature for health is 64 degrees or 65 degrees rather than 60 degrees, as was inferred from factory work. The second map shows the distribution of health. It is based on the official mortality statistics of the European countries for the years 1909 to 1913. Infants under 1 year of age and old people over 75 have been omitted because the figures for those groups, especially the infants, are unreliable. The data for other ages have been reduced to what is called a standard population, so that differences in age and in the proportion of children from country to country have been eliminated. The map shows the actual distribution of health in Europe under normal conditions. The third map illustrates the distribution of civilization. It is the same as Figure 23 in the chapter on civilization, but is reproduced here in another form in order that it may easily be compared with the other two. Figure 40 is displayed on the page, Distribution of Climatic Energy in Europe. These 3 maps are so much alike that if their titles were removed, most people would not be able to tell which is which. In each map, an area of heavy shading surrounds the North Sea, and shades off gradually in every direction. In each there are 3 projections of heavy shading, one toward Italy, a second toward the Black Sea, and a third along the Baltic. Figure 41 is displayed on the page, Distribution of Health in Europe. Figure 42 is displayed on the page, Distribution of Civilization in Europe. The maps are so much alike that there can scarcely be any question as to the reality of their relationship, and that relationship can be of only one kind. Civilization and progress undoubtedly influence health, and health in turn has an effect on progress, but neither civilization nor health can have any appreciable effect upon the distribution of climate. The only way in which the 3 maps can be so alike, less by sheer accident, which is practically impossible, is for climate to exert a direct and dominating influence upon the distribution of health, and an indirect and perhaps less dominating influence upon civilization through other agencies such as agriculture. Now turn to the world as a whole. Unfortunately, the mortality records of many backward countries are highly inaccurate, while for vast areas they are wholly lacking. Hence, it is impossible to construct a map of health. We can, however, construct maps showing the distribution of climatic energy and of civilization. A map of climatic energy based on factory work has already been given in Figure 22. This is repeated in Figure 43. The map of civilization on the same page, Figure 44, sums up the data already shown in Figure 23 to 28. All the regions to which our 50 contributors assign a rate of 8.5 or higher are rated as very high and are shaded in solid black. Those from 7 to 8.5 are rated as high and are shaded in heavy lines. Those from 5 to 7 are medium and are indicated by light lines. 3 to 5, low, shaded with abundant dots, and under 3, very low, and dotted only lightly. The first thing that attracts attention is the general resemblance between the maps of energy and of civilization. Both, for example, show a high area in northwestern Europe. A tongue extends into Italy, another towards Romania, and a third to the Baltic. Another projection runs into the western Siberia. Here the high area of the map of civilization extends about as far as the medium area of the map of energy. This is not surprising, for even if the people of Siberia have the energy indicated in Figure 43, they are hampered by the remoteness and newness of their country, not to mention other conditions. Figure 43 is displayed on the page, distribution of human health and energy on the basis of climate. Figure 44 is displayed on the page, the distribution of civilization. In central and northern Siberia, the difference between the two maps is slight. The significant thing is that in both there is the same falling off toward the center of Asia. Still farther east in China and Japan, conditions are once more alike, China being medium and Japan high. In Indochina, and especially in India, the maps differ. Apparently this arises largely from European domination, and is due to the constant addition of strength from that continent. This does not apply to Siam, however, which has worked out its own salvation. It ranks as very low on the energy map, and only as low on the other. This may have no significance, for our maps are still in their early stages. Further knowledge may change such slight disagreements into agreements. On the other hand, it may increase the disagreement. In that case, we may discover that, by long residence within the tropics, the races of Indochina and India have become differentiated from Europeans and less susceptible to the influence of steady heat. Again, race differs from race in its inheritance, and the Siamese may inherit stronger traits than are possessed by their neighbors. Finally, the level of Siamese civilization may have been raised by contact with other races, by the adoption of particular institutions of government, forms of religion or social organization, or by the inspiration and energy of a few men of unusual gifts. I mention these possibilities not because they are of special importance in Siam, but because they illustrate the many and varied influences which cooperate to determine the position of a country in the scale of civilization. In comparing the maps of energy and civilization, one of the clearest features is the effect of a strong race upon regions which it rules or colonizes. Again and again, the presence of such a race causes a region to be higher in civilization than would be expected on the basis of climatic energy. Java, the Philippines, and India are examples. It is especially noticeable in regions controlled by Great Britain. In Australia, for instance, the general decrease in both civilization and energy from southeast to northwest is the same in both maps, but the presence of the English raises the places of very low energy to low in civilization, and so on, each grade being raised 1 degree, so to speak, until the map of civilization shows a large high area in the southeast. In South Africa and Egypt, British influence is displayed in the same way. In the Canadian Northwest, on the other hand, it is not apparent. The northern parts of Alberta and Saskatchewan appear higher in energy than in civilization. We have already seen that according to American, and to a less extent, British opinion, this is not the case. for recent settlement has raised these regions to a comparatively high degree of culture. In the United States, the energy map shows a strip of medium conditions along the southern frontier, but this is rated as high on the other map. Such a condition illustrates how a high type of government causes efficient people to settle in unfavorable regions, and how it also adds to the effectiveness of less efficient people such as Mexicans and Negroes, thus in part overcoming the handicap of climate. In the central states, on the other hand, civilization is not rated so high as one would expect on the climatic basis. Probably this is because the country is so new that our Chinese, Russian, Spanish and other foreign contributors, though they have travelled and studied extensively, do not realize how great is the progress of recent times. California, like the southern states, is higher on the map of civilization than on the other. As already explained, this may in part be due to the impossibility of making a wholly accurate map of climatic energy. It may also arise from the location of California on the seaboard from its early development as contrasted with the newer states of the interior. A comparison of the United States as it appears on the world maps and as it appears on the maps of that country alone is important. Where the country stands by itself, and its parts are classified by people who live in it and are thoroughly familiar with it, the resemblance between climatic energy and civilization is greater than where the classification is on a rougher scale, and is made by people less familiar with it. Another reason for the difference is that of classification of places where a uniform standard of culture prevails and where the same race is everywhere dominant is much easier than where many types of culture and highly diverse races are considered. The maps of the United States represent the kind which must be made for each country. The difference between the features of the United States on the world map and on the other represents the extent to which our general map of civilization is in error. In spite of this, however, the general features of the country are unmistakably the same on both maps. So far as the conclusions of this volume are concerned, it makes no difference which we use. In this lies the importance of our various tests of the United States. They show that although much remains to be done before we can construct a map which is approximately perfect, the most important features are reasonably distinct and unmistakable. Turning to Latin America, we find about what would be expected in Mexico and Central America. The highlands are medium and the lowlands low. South America, on the contrary, presents some unexpected features. The Andean highlands, including Venezuela, Colombia, Ecuador, Peru, and Bolivia, are all ranked as low in civilization, whereas the climatic map would indicate medium energy. In the belt of highlands on the east side of Africa, the same phenomenon is observable. Perhaps an equatorial climate is more debilitating than would be expected from the work of factory operatives in summer. In South America, the presence of an ancient race whose vigor was already waning at the time of the discovery of the New World has doubtless hindered Spanish immigrants in accomplishing what might otherwise have been looked for. This, however, does not alter the case, for the original inhabitants in the Andean countries, just as in the African highlands, stand lower than would be expected. Argentina, on the contrary, goes to the opposite extreme, and is higher on the map of civilization than on that of energy. The importance of this must not be overrated, for the climatic data are somewhat doubtful because of the paucity of statistics as to changes of temperature from day to day. As the maps now stand, however, they are encouraging, for they suggest that even with a moderately favorable climate, the Latin race in America is competent to rise to a high level. Let us now turn from these details and look once more at the general aspect of the two maps. In spite of minor disagreements, the main features are essentially alike. There are, in each case, the same two great high areas in Western Europe and the United States. The decline from Western Russia eastward to the center of Asia, and the rise to high conditions on the eastern edge of Asia in Japan are equally apparent. Likewise, the maps are strikingly alike in the shape of the very low areas of Africa and South America. South of latitude 30 degrees south, each of the southern continents begins to rise in energy and in civilization, and the rise is more pronounced on the eastern side than on the western. Even where the maps disagree, the explanation of the disagreement is often obvious from a consideration of the recent movements of European peoples. Some of the remaining discrepancies are explicable on well-known grounds, such as the impossibility of agriculture, which hinders civilization in the far northern parts of America and Asia. In addition to all this, many differences in the degree of progress among people in similar climates are due to racial inheritance. A conspicuous example of this sort, as I have shown in the character of races, is a contrast between the progressive Icelanders and the backward people who live in a similar climate in the southern tip of South America. A still more conspicuous example is the difference between the primitive hill tribes of India and the highly competent Parsis, whose ancestors came to India more than 1,000 years ago because of their loyalty to the old Zoroastrian religion. When allowance is made for obvious facts like these, the resemblance between the two maps becomes more striking. Call to mind the method of their construction. Neither represents the personal opinion or bias of any one man. Any other person with the same data before him would have obtained similar results. The maps simply give expression to two distinct sets of facts. The first is that the opinion of men of many races agrees as to the general distribution of civilization. The second is that the various conditions of climate produced the same effect upon all the people of the world as upon students and factory operatives in the eastern United States. The amount of work accomplished in different countries would be closely proportional to the status of civilization. Aside from the map of climatic energy, it is hard to think of any other which would so closely reproduce the features of the map of civilization. Suppose that race were made the criterion, and that a map was shaded in proportion to the number of Teutons. We should find that in Europe such a map would closely resemble the map of civilization, except that places like Finland, southern France, central Italy, Hungary, Bohemia, Serbia, and others are relatively high in civilization, even though none are more than half Teutonic, and some only very slightly, or almost unappreciably so. In Asia, on the other hand, there is much more Teutonic blood in Syria and Asia Minor than in Japan, yet Japan ranks far higher. The Japanese might claim racial superiority almost as fairly as the Teutons, and both the Latins and Slavs may justly point to the fact that they predominate in some of the most advanced portions of the globe. When we look at the low places, we find that Teutonic areas, such as the Transvaal, Alaska, southern Greenland, and parts of Australia, make a poor showing. The Latins in parts of Latin America are even worse. The Slavs at their worst fall no lower than the Teutons, while the Japanese nowhere fall so low. A map of religion does not resemble a map of civilization, no matter which religion is employed. Protestant Christianity indeed prevails chiefly in regions which are either high or very high. Iceland is by no means an exception, for its civilization is much higher than would appear from our table, where it is grouped with Greenland. Roman Catholic Christianity, on the other hand, prevails in locations which range from very high to very low, and Greek Christianity from high to low. Buddhism likewise ranges from high in Japan to low in Tibet, while Mohammedanism never rises above medium, and in some places falls very low. That religion raises or lowers the tone of a country, I do not for a moment question, but if a people are physically weak and are lacking in self-control because of something in their surroundings, the history of the world as exemplified by groups of people who have long been nominally Christians in Abyssinia, India, Latin America, and elsewhere, seem to show that they debase even the finest religion. The higher the form of religion and the more self-sacrifice and devotion it requires, the more difficult it becomes to keep any but the most energetic and determined races even approximately true to it. The only cases where people of low efficiency seem to remain true to a high religion are where they are continuously stimulated by the presence of a stronger race. As a third criterion, suppose we take form of government and inquire whether a map of governments would resemble one of civilization. Of course, the excellence of the government is closely related to the degree of civilization, but not so with the form. Republics range from very high in Switzerland and France to very low in Venezuela. Limited but autocratic monarchies existed in high countries like Germany, at least before the Great War, and also in low countries like Turkey and Persia. Thus we might go on to consider one after another of the great factors which cooperate in giving form to modern civilization. The nature of a nation's religious faith its form of government, its social organization, its ease of intercourse with other nations, and various other conditions play a fundamental part in the distribution of civilization. Yet each is conditioned by the degree of energy possessed by a people, for if a race lacks energy, no amount of excellence along other lines will place it in the first rank. Energy, in turn, is greatly influenced by climate, and thus climate becomes an essential element in determining the status of civilization. We may well reverse our statement, however, and say that no amount of energy will make a nation great if none of its people are gifted with genius, or if it never evolves an ordinary form of government, or a moral code which allows a man to enjoy life, property, and home without constant fear of outsiders. Thus the material and immaterial elements of civilization play into each other in such a way that either seems the more important according to the angle from which we view it. The interplay of diverse factors is so important that it is worthwhile to examine it in a concrete case. Dr. Scott Nearing in the Popular Science Monthly for 1914 published an article entitled The Geographical Distribution of American Genius. While it is impossible to measure genius, it is impossible to ascertain how many people of unusual ability are born in a given region. That useful publication, Who's Who in America, though not infallible, forms a good summary of about 20,000 people who have either achieved special prominence in credible lines of effort, making them the subjects of extensive interest, inquiry, or discussion in this country, or who occupy positions which could scarcely be attained except by persons of unusual ability. Taking the Who's Who for 1912 to 1913 as a basis, Nearing has tabulated the birthplaces of the first 10,000 names according to states. He took only 10,000 because the number seemed enough to give reliable results. His tabulation strikingly reinforces the common opinion that New England, especially Massachusetts, has produced far more than its proportionate share of persons of unusual ability. The utility of his investigation seems so great, and the method so reliable, that I have asked Dr. Nearing for permission to make use of fuller data than were contained in his article, and he has kindly supplied me with the figures for each state. In order to determine the relative status of the various parts of the country, it is not fair to compare the number of eminent persons who were born in a given area with the present population. At the time when the men who are now prominent were born, many of the western states contained only a handful of settlers. It is equally unfair to compare the number of such persons who live in a given region with the present population, for many persons who have achieved prominence owe it to the place where they grew up and not to where they now live. The only fair way seems to be to ascertain the relation between the number of eminent persons born in a given region and the population of the region at the time of their birth. Accordingly, the first thing to do is to find when the people in Who's Who were born. Nearing gives us the following table. A table is displayed on the page, number of eminent persons in the United States in 1912 who were born at certain times. Before 1850, 2,818. 1850 to 1859, 2,715. 1860 to 1869, 2,717. 1870 to 1879, 1,304. 1880 to 1889, 95. 1890 to 1899, 2. Unknown, 349. Total, 10,000. The number who were born before 1840 is not given, but it must be considerable, for the people who attain eminence are among the most long-lived portions of the community. On the other hand, the number who were born after 1880 is too small to be considered. People rarely become eminent before they are at least 35 years of age. The 40 years from 1835 to 1875 cover the births of practically all who have attained sufficient distinction to be included in the Who's Who for 1912. Accordingly, we must find the average population of each state according to the census from 1840 to 1870, but inasmuch as the number who were born previous to 1840 is less than in latter decades, we shall come nearer to the truth if we give that census only half as much weight as the others. In all cases, we employ the figures for the entire white population, whether native or immigrant, but omit the Negroes, Chinese, and Indians. The way in which the matter works out is illustrated in the following table, where the population is given in thousands. The table is displayed on the page, comparing Massachusetts, South Carolina, Nebraska, and New Mexico, with the white population in thousands divided between 1840, 1850, 1860, 1870, and the average of 1840 to 70, the number of eminent persons, and eminent persons per 100,000. The figures in the last column show the relative rank of these states in the production of persons of unusual ability from 1835 to 1875. Similar figures for each state are given in Figure 45. Since Nearing used only the first 10,000 names of American-born persons in Who's Who, or only about 60% of the total, the index figures really mean the number of eminent persons for every 60,000 people instead of 100,000. In a few cases where the average population previous to 1875 was less than 10,000, 2 or more adjacent states have been combined so to give a total large enough to be significant. The numbers thus obtained have been enclosed in parentheses. On the map, the United States has been divided into 4 grades, much as in figures 34 to 39. Thus all these maps are comparable. The only essential difference is that Figure 45 belongs to a period averaging more than half a century earlier than the others. It presents the most accurate picture now available of the distribution of ability at that time. New states are at no disadvantage compared with the old, for if a region had no population previous to 1860, for example, and only a few thousand in 1870, full allowance is made for this. Many of our 10,000 eminent people have moved away from their early homes, but the great majority did not go until they had at least reached an age approaching 20 and the main elements of their character were already formed. Thus the peculiarities of the map depend not only on whether the population was of such a caliber that children of high ability were produced, but also on the conditions which moulded the early life of such children. Aside from accidents, 3 chief conditions determine the number of eminent persons in a community. The first is inherited ability. Unless a man is born with more than the average mental capacity, the chances of his inclusion in Who's Who are slight. The second condition is opportunity in the broadest sense of the word. A bright child born on a remote farm in Maine, or a ranch in Arizona, or in a clearing among the Tennessee mountains, may be so hampered by lack of education and of the stimulus derived from contact with people outside his own little circle, that he never accomplishes anything that attracts attention. The third condition is energy. Many a man of high ability who is also blessed with the best education and with all sorts of opportunities to develop his talents, fails to make any impression on the world because he is indolent. Frequently, a man of less ability but endowed with energy achieves much more. Energy depends partially on inheritance, but also on climate. So far as it depends on inheritance, it should be included under the first of our 3 conditions. Thus, the 3 may be briefly defined as 1. Inherited qualities of all kinds. 2. Opportunities, which include education, the degree of culture in a community, and the freedom with which a person can find scope for his particular talents. And 3. Energy so far as this depends upon physical circumstances not connected with either heredity or opportunity. Let us now inspect Figure 45 to see how far our 3 conditions make themselves evident. Each gives rise to certain features which stand out unmistakably. To begin with inheritance, Massachusetts gave birth to 98 eminent persons for every 60,000 of its white population during the specified period. That is, 1 white child at every 600 born at that time has distinguished himself. The figures for the surrounding New England states and New York range from 50 to 78. Such a striking difference is certainly not due to climate. It is equally certain that it is not due to opportunity. The average child in New York has as good a chance to go to school and enter any sort of occupation as has the child in Massachusetts. Yet the rank of New York is only half as high as that of Massachusetts. In Maine, Vermont, and New Hampshire, the opportunities are distinctly less than in New York. There is much less wealth. The people are more isolated. The number of cities is proportionally smaller. The common school system is no better developed, and the facilities for sending children to college are not so great. Yet even Maine outranks New York, for she produced 54 eminent persons per 60,000, while New York produced only 50. Yet New York itself stands very high. Aside from the New England states, only Nebraska exceeds it, while Oregon and Delaware rival it. South Carolina is another state which stands far higher than its neighbors, for although 89 is low compared with the 78 of Connecticut, for example, it is high compared with the 24 North Carolina and 25 of Georgia. Probably heredity plays an important part here, as in other cases, although as we shall shortly see, the matter is complicated by other conditions. Oregon and especially Nebraska, however, are unmistakable. Proportionally, they stand as high above their neighbors as Massachusetts, Connecticut, Rhode Island, and Vermont above theirs. Figure 45 is displayed on the page, birthplaces of persons of unusual ability in the United States. The numerals indicate the number of eminent persons born in each state per 60,000 of the average white population from 1835 to 1875. The case of these two states is most suggestive. So far as energy is concerned, there is nothing in the climate of either Oregon or Nebraska to give them a special advantage. Previous to 1890, by which time the education of 4/5 of the people in Who's Who was completed, these two states did not offer their children especially great opportunities. In fact, the opportunities were much less than in Oregon's next neighbor, California, or in Iowa, Illinois, Indiana, Ohio, and Pennsylvania, the states directly east of Nebraska. Yet Oregon ranks 30% higher than California, and Nebraska exceeds Illinois by 60%, and Indiana by over 90%. In striking contrast to Nebraska, we find New Mexico with a rank of only 1.5, which appears as 2 on the map because we have avoided the use of fractions. Here again, neither climate nor opportunities explain why this state falls so far behind its neighbors. The only reasonable explanation is that until 1870 or later, its white population consisted almost wholly of Mexicans. In reading the preceding pages, it may have occurred to the reader that the preeminence of New England is only apparent, not real. It may be due largely to the local prejudices or limited viewpoint of the compilers of Who's Who. This is not the case, however. The book is edited and published in Chicago, yet Illinois and the neighboring states all receive a relatively low rank. The facts just stated are of profound significance. Massachusetts, because she was settled by the strong-willed Pilgrim Fathers and by other Puritans who fled to the wilderness to maintain their high ideals, have produced vastly more than a proportion of the men who have made America what it is. Connecticut and Rhode Island, for similar reasons, have followed closely on their heels, while the northern New England states have much more than held their own compared with the rest of the country. It has been a fad to decry Puritanism, but people of Puritan descent have taken the foremost place. They have done so because they inherit the strength of mind which made it possible for the Puritan fathers to develop their stern, conscientious system and carry out their noble purposes in the face of temptation and opposition. When that old stock has been transported to places such as Nebraska and Oregon, where, for a while, it was dominant before the great tide of later immigration, it raised the average ability to a level reached nowhere else except in New England. In New Mexico, on the contrary, we harbor a group of people, fortunately small, who are even more conspicuous by their lack of ability than the New Englanders are in the opposite way. We may excuse the Mexicans by saying that they do not learn our language and do not merge themselves in our civilization. The competent Mexicans, however, usually those who possess the greatest proportion of Spanish blood, do learn English and make themselves felt among us. The others, perhaps because they inherit an inert disposition from their Indian ancestors, are content to remain backward. This brings up the great question of immigration and racial character. In the earliest days of colonization, we received only the stronger elements of the various European populations. The North had its Pilgrims, Puritans, Quakers, and others, while in the southern states a part of the settlers were people who, as Huguenots, or other religious refugees, were notable for tenacity of purpose and high ideals. The rest of the settlers were in large measure people of unusual courage and initiative, for others were not brave enough to come. For this reason, apparently, the states of the Atlantic coast from Georgia northward stand higher than those west of them. After America has been settled so long that migration thither was easy, we began to get immigrants of medium grade, not the best nor the worst, but from advanced countries and from the substantial middle classes. These are what predominate from Pennsylvania to Iowa. They are good material, but not so good as the old. Otherwise, why should so fine a state as Wisconsin have produced only half as many eminent men per 100,000 as has Connecticut, and no more than South Carolina, which labours under far greater disadvantages? In these last decades, we are taking into our midst many people scarcely better than the Mexicans. We may say that we choose about absorbing them and making them good Americans. It is our duty to do so as far as we can, but why blind ourselves to the facts of biology? Plough horses cannot race like thoroughbreds. Do men gather grapes of thorns or figs of thistles? Today, Massachusetts and New England seem to be losing their supremacy in the production of men of special ability. A study of Who's Who for 1922 shows that the conditions of 10 years earlier still prevail, although less marked. But where the old New England families have sent their sons out over the wild expanse of our land, the loss to the mother states is more than compensated by the gain to the rest of the country. Unfortunately, the change means more than that. It means, first, that we are steadily diluting our strength. We are acting as would a dairyman who thought that by adding a dozen low-grade animals to his herd of 100 prize winners and letting them breed together, he was going to increase the value of his stock. In addition to this, we are losing in another and more dangerous way. It is as if the dairyman should not only add poor animals, but should also prevent his best animals from bearing young. No amount of care would make the low-grade animals give as much milk, or be of as much value as the prize winners. Man is subject to the same biological laws as animals. High mental ability and strength of purpose are his most valuable qualities. Yet we act as if we thought that though these are not reproduced, our country can continue to advance. Our unwillingness to live simply either prevents a large proportion of our most competent men and women from marrying, or causes many of those who marry to have few children. All men are not created equal biologically, and it is the best who are dying out. We must recognize that fact, and act upon it before we have worked irreparable injury. All this has been said many times by eugenists, but it must be repeated again and again, until it is not only believed but acted upon. Biology teaches it, common sense insists upon it, and now our purely geographical studies enforce the same conclusion. The second condition which controls the distribution of people who attain eminence is opportunity. This appears unmistakably in only one portion of Figure 45, but there it stands out sharply. Notice how West Virginia with 19 eminent persons per 100,000, Tennessee with 18, and Arkansas with 11 fall below the surrounding states. This is apparently because these are the portions of the South where mountains and other physiographic disadvantages cause the people to degenerate into poor whites and crackers in spite of a good inheritance. What these backward communities need is a chance. They need the opportunities that are brought by schools, railroads, factories, and the other appurtenances of civilization. They need also the opportunity brought by freedom from such bodily afflictions as the hookworm disease. Kentucky, which now has a rank of 23, would probably stand much higher were not a large part of the state peopled by mountain whites. The same is true of North Carolina. Perhaps this state would not equal South Carolina, which had a large number of old families of unusual ability, but the two would be much nearer than now. A large fraction of North Carolina consists either of mountains or of swampy, unhealthy tracts along the coast, while South Carolina is almost free from such disadvantages. In another portion of the country, it may be that Maine lags behind New Hampshire and Vermont, in part because of a relative remoteness and lack of opportunity. Doubtless other places show the same conditions, but the matter is not certain. For example, Nevada's low position with a rank of only 15 is probably due in part to this cause, but it is doubtful whether she has been much worse off than Utah, which has a respectable rank of 36. Idaho, Wyoming, Montana, and the Dakotas certainly had no more opportunities than Nevada previous to 1890, for they were supplied with fewer railroads, and were much less easily in touch with the rest of the world. Yet their rank is 33, or more than twice that of Nevada. Taking the map as a whole, it seems that although opportunity is highly important, it is less important than heredity. The preceding paragraph stands as it was written 10 years ago. Today I am inclined to think that I have not given sufficient weight to inheritance in estimating the position of the mountain whites. Note first, however, that in Figure 36, where climatic energy is estimated on the basis of the effect of climate on health, the mountain white region, by reason of its altitude, forms a peninsula of more favourable conditions jutting southward. Some non-climatic factor seems completely to overshadow this climatic condition. That this other factor is in part the isolation of the mountain valleys, I do not doubt. But this is probably supplemented to a large degree by inheritance. When people are able to move freely from one region to another, there is a strong tendency for those who are most competent to gain possession of the best places. The rich cotton soil of the Black Belt of Georgia and Alabama, as R.M. Harper has well shown, has attracted and held a large number of unusually competent families, the kind that produce leaders. In such a region, the lands of the less competent people are gradually bought by the competent. The less competent often move into the mountains where land is cheap. There is likewise a backward movement whereby the most competent mountaineers drift to the lowlands. Thus, in course of time, there arises a genuine inherent difference of ability, and that may be one cause of the backwardness of the mountain whites. Turning now to our last factor, that is, energy as determined by climate, we see that in general the outlines of Figure 45 are like those of the climatic map in Figure 36. To be sure, there are important differences. For instance, the very high area which covers all the northeast and center of the country in the energy map is split into a New England and a Nebraska portion in the map of ability. Yet the Nebraska area of many eminent people displays an interesting resemblance to the tongue which projects out in the same direction on the energy map. The Pacific coast is likewise high on both maps, although there are differences of detail. Nevada, too, is at the head of a tongue of low conditions in both cases. On the Atlantic coast, both maps rise from Maine to Massachusetts and decline from New York to Florida. In the map of ability, however, high conditions go somewhat farther south than in the other map, and South Carolina, presumably because of heredity, rises unexpectedly. The other southern states from Georgia to Louisiana are also a little higher on the ability map than on its companion, probably because of the wealth and opportunities which prevailed in them previous to the Civil War, or else because of the abundance of old families with high ideals and strong minds. Yet even these states are lower than the tier of northern states from Pennsylvania to Iowa, where the average inheritance is probably no higher, if as high, but where the climate gives energy. Taken as a whole, the map of ability is an admirable example of the way in which a variety of factors cooperate in determining the status of civilization. Climate, as it were, paints a broad background, shading gradually from very high in certain areas to lower in others. Then the other factors come into play. They paint fresh colours which may or may not resemble those of climate. In some cases, such as Massachusetts, the same colour is laid on by climate, heredity, and opportunity, not to mention proximity to the sea and to Europe, facilities for manufacturing, and various other factors which perhaps may be considered as opportunities. Where that happens, high civilization is sure to prevail. In other cases, such as South Carolina, the climate paints only a moderately high colour, inheritance paints a high one, education a low, the presence of the Negroes a still lower, and so on indefinitely. Such, then, is the meaning of our maps. They do not indicate that climate is the only factor in determining the condition of civilization, or even the main one. Far from it. Yet they indicate that it is as essential as any other. Today's civilization seems to make great progress only when a stimulating climate exists. A high civilization may be carried from such places to others, but it makes a vigorous growth and is fruitful in new ideas only where the climate gives men energy. Elsewhere it lags, or is kept at a high pitch only by constant reinforcements from more favoured regions. In the past, men have perceived that climate is apparently one of the most important conditions which favour or retard the growth of civilization. They have been greatly impressed not only by its effects upon their own bodies and minds, but by the fact that in warm countries the amount of progress is closely in harmony with what would be expected on the basis of one's own feelings. At the same time, they have realized that among countries located in the same latitude, there are differences of culture almost as great as between temperate or tropical countries. This is seen to indicate that climate is not so important as the tropical regions would suggest. Now, however, we see that when people's actual achievements under various climatic conditions are measured, we must revive our opinion. Variations of temperature from day to day are much more important than has been realized. Therefore, in the same latitude, the stimulating effect of the climate may differ greatly. The civilization of the world varies almost precisely as we should expect if human energy were one of the essential conditions, and if energy were in large measure dependent upon climate. End of section 13. Section 14 of Civilization and Climate by Ellsworth Huntington. This is a LibriVox recording. All LibriVox recordings in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Leon Harvey. Chapter 14. The Shifting of Climatic Zones. We now have before us the main hypothesis of this book, as stated at the end of the last chapter. But even if many facts suggest that civilization at present varies from place to place almost precisely as we should expect if it were dependent on climatic energy and health, is there not abundant evidence to the contrary? 3 objections at once present themselves. 1. The great nations of antiquity developed their culture in regions where the climate is now relatively unstimulating. 2. The American Indians, even when they lived in some of the world's best climates, failed to evolve a high civilization. 3. People of European races are today maintaining and developing a high civilization in relatively unstimulating climates such as that of Northern Australia. Each of these objections is highly significant and must receive careful attention. The first will form the subject of the present chapter. In a series of books, among which The Pulse of Asia, Palestine and its Transformation, and Climatic Changes are the most important, I have set forth the hypothesis that during historic times the Earth's climate has been subject to pulsatory changes. It cannot be too clearly understood that this hypothesis was not framed with reference to the hypothesis of civilization and climate presented in this book. It was developed independently before I realized how closely the distribution of civilization is bound up with that of climate. In fact, the hypothesis of climatic changes was what led originally to the studies described in this book. The steps which have led to this hypothesis may be summed up as follows. In many parts of Asia, Africa, and America, ruins of towns and cities are located where now the supply of water seems utterly inadequate. Old strands surround lakes that are now dry. Old alluvial terraces which lie remains of human occupation show that the rivers have changed their habits of erosion and deposition since men began to become civilized. Old roads traverse deserts where caravans cannot now travel. Traces of dry springs are seen. Bridges span channels which carry no water for years at a time. Old fields are walled and terraced in places which now the rainfall is too scanty to permit agriculture and where no water can be brought for irrigation. Elsewhere, old irrigation canals abound in districts where today there is little or no water supply, or where that water there may be in the streams is so salty that it kills the crops instead of invigorating them. These things and many others, which almost every traveller in semi-arid or desert countries has seen for himself, seem to be almost irrefutable evidence that at some time the climate was moister than now. Such evidence long ago gave rise to 2 hypotheses, which are now almost abandoned, those of deforestation and of progressive desiccation. According to supporters of the first hypothesis, the reckless cutting of forests has not only allowed the rains to denude the mountainsides of soil, but has also caused an actual diminution in rainfall. This view once had a considerable popular vogue, but for various reasons it has now practically ceased to be considered among scientists. In the first place, modern measurements of rainfall before and after the deforestation of large tracts are contradictory. At best they show only slight differences, too small to have any appreciable effect, and in practically every case so doubtful that they may be due merely to the accident of an especially dry or rainy period of a few years coming not long before or after the forest was cut. Moreover, many of the strongest evidences of desiccation are found in places such as southeastern Syria, where there is no reason to think that the country has ever been forested since it was first occupied by civilized man. Finally, there are thousands of square miles in Chinese Turkestan, where the forests themselves have died because of lack of water, and are still standing as gaunt skeletons preserved for 1,000 years or more because of the extreme dryness of the air. The hypothesis of progressive desiccation assumes that during historic times the Earth has steadily been growing drier. It was my own view when I published Explorations in Turkestan in 1905. Many careful students still uphold it. The majority of its supporters, however, apparently think that it needs modification along lines which will shortly appear. While evidence of more water in the past than at present is prominent in many places, there is also much of the contrary nature, less noticeable, but no less convincing. For example, ruins are located on the floor of lakes, which must have been partially dry when the structures were erected. Elsewhere, one finds irrigation canals in places now so damp that their construction would seem to be a waste of energy. In North Africa and Syria, huge irrigation works are located in regions of another kind, which not only are dry now, but must have been dry in the past. Otherwise the Romans would not have expended such enormous labour to get water. These things and others furnish almost irrefutable evidence that at certain periods the water supply of many semi-arid regions was no greater than at present. Because such evidence is less abundant and noticeable than the other kind, the believers in progressive desiccation have overlooked it. On the other hand, other students have been so impressed by it that they have held that there have been no changes of climate during historic times, and that the fluctuations which follow the last glacial epoch came to an end before the beginning of history. There seems only one way to reconcile these two opposing views, each of which is based on unassailable evidence. That way, as I first showed in The Pulse of Asia, 1907, is to group the evidence according to its date, and see how far the indications of moisture and aridity come at different times. For example, several lines of evidence, such as the location of dwellings in tracts that are now great swamps in Ireland, unusually prolonged famines in China and Western Asia, and vegetation of warmth-loving types in Europe suggest a dry period perhaps 1400 to 1200 years before Christ. At the time of Herodotus, between 400 and 500 BC, all the evidence points to moist conditions in Western Asia and Northern Africa. About 200 BC, a somewhat drier climate apparently prevailed, although not so dry as now. Then at the time of Christ, conditions were once more favourable. After about 6 centuries of gradually increasing aridity, a dry period more severe than that of 1200 BC reached its climax about 650 AD. An improvement followed, which culminated about 1000 AD, and then came another bad time, reaching its worst in the 13th century. It was followed by a rapid recovery, which did not last long enough to be of great value. Since the 14th century, minor fluctuations have continued to take place. The whole matter is summed up in the dotted line of figure 46. There, the high parts of the curve represent moist conditions and the low dry. The curve is only approximate and does not represent all the data now available, but it seems wise to reproduce it in the original form from which it had when the pulsatory hypothesis of climatic changes was first formulated. From what has been said, it appears that during historic times, climatic pulsations have taken place. They seem to be of essentially the same nature as glacial epochs and post-glacial stages, the difference being only in degree. Apparently, the conditions of the geological past merge without break into those of the present. This in fact is really appreciated by historians and archaeologists who naturally have little occasion to come in contact with it. Students of glaciation, however, have carried the matter so far that we now have abundant evidence of a great succession of climatic variations covering the entire period from the present time back to the date when ice covered much of the northern United States and Europe. They find no evidence of any sudden break between the past and the present. On the contrary, by means of varves, or layers of clay deposited each year in lakes that disappeared after the retreat of the ice, De Geer and Antevs, for example, find a constant series of pulsations. In studying the retreat of the ice in North America, F. B. Taylor and others have discovered a series of some 50 small moraines indicating stages of retreat. These point to climatic cycles, having an average duration of somewhere around 500 years, although varying considerably. Most students of post-glacial climates believe that such cycles, on a diminishing scale, have continued into the historic period. In order to test the pulsatory hypothesis, some means of actually measuring the climate of the past seems necessary. In the southwestern United States, there appear to have been changes like those in Western Asia. In that region, Professor A. E. Douglas has found that the thickness of the annual rings of trees furnishes a reliable indication of variations in the water supply from year to year. In California, among the big trees, I found that correlation coefficients for a period of about 50 years show clearly that the rainfall is a main determinant of the rate at which the trees form their rings of growth. Other factors, of course, enter into the matter, as Antevs has pointed out in a forthcoming publication of the Carnegie Institution of Washington. But these likewise are climatic. Corrections must be made to eliminate the effects of age, but this can be done by mathematical methods of considerable accuracy. It is difficult to determine whether the climate at the beginning and end of a tree's life was the same, but it is easy to determine whether there have been pulsations while the tree was making its growth. If the trees from various parts of a given district form thick rings for a century, then thin ones for another 100 years, and again thick ones, we may be almost sure that they have lived through a long period of unfavourable climate. During the years 1911 and 1912, under the auspices of the Carnegie Institution of Washington, I measured the thickness of the rings of growth on the stumps of about 450 sequoia trees which had been cut for fence posts, shingles and pencil wood in California. The trees varied from 250 to nearly 3,250 years of age. The great majority were over 1,000 years old, 79 over 2,000 and 3 over 3,000. Even where only a few trees are available, the record indicates the main fluctuations, although not the details. Figure 47 is displayed on the page, changes of climate in California for 2,000 years, adjusted to the level of Owens Lake. Dotted lines indicate main respects in which Antev's method of correction gives a different result from that of the author. Where the number approximates 100, accidental variations are largely eliminated. Accordingly, in California, we have a climatic record which is fairly accurate for 2,000 years and approximate for 1,000 years more. This is expressed graphically in the solid line of Figure 46. In order to bring out the details, the more reliable portion from 100 BC to the present time have been reproduced in Figure 47. This resembles the corresponding part of Figure 46, except that the vertical scale is 3 times as great, and corrections have been made on the basis of Owens Lake. In general, the tree curve resembles that of changes of climate in Asia, although there are differences in detail. Beginning with 1000 BC, both curves have a maximum. They dip down about 800 BC and rise high not far from 700. About 400 BC they disagree, but this is probably due largely to the absence of reliable data for the Asiatic curve. In the 2nd century before Christ, both are low, but not so low as at present. At the time of Christ they rise high and continue to fluctuate together till 300 AD. At that time they show a difference which may have arisen because I was unduly impressed by the abandonment of many ruins in Chinese Turkestan at the end of the 3rd century. The dashed line is probably more accurate than the dotted and should be used. In the 7th century both curves reach their lowest point, then from 650 AD onward their general course is closely similar, especially about 1000 AD. In the tree curve, the evidence of pulsations is even clearer than in the Asiatic curve. The general agreement between the two curves seems to indicate that the main climatic variations of Western Asia and the region of similar climate in the United States are approximately the same. Moreover, the fluctuations of both tree growth and rainfall among the Sierras during the last half-century show a strong resemblance to those of rainfall in Palestine as is set forth in Climatic Changes and in Post-Glacial Climatic Cycles, a publication of the Carnegie Institution of Washington. Since the present growth of trees in California shows so close an agreement with the rainfall in Western Asia, it is almost certain that a similar agreement existed in the past. The growth of the trees, with its pronounced variations lasting hundreds of years, is generally accepted as the strongest single piece of evidence that pronounced climatic pulsations have taken place in historic times. The agreement between the curve obtained from exact measurements in California and that obtained from physiographic and archaeological evidence in Western Asia unites with present climatic variations in proving that these two regions of similar climatic type have experienced a similar series of climatic pulsations. Another line of evidence in the Western United States is peculiarly important because it employs a method absolutely different from those already mentioned, but reaches the same conclusion. Every river holds in solution a certain amount of sodium, chlorine, calcium, carbon dioxide, and various other materials. Under ordinary circumstances, this cannot be detected except by chemical analysis. If the river flows into a lake, which has no outlet, however, the water is evaporated, but the dissolved constituents remain, and gradually increase until a brine is formed. Certain materials, such as the calcite, which forms tufa and other kinds of limestone, are removed by algae or bacteria, and certain others, such as potassium, seem to be absorbed by the clays of the lake bottoms. Sodium and especially chlorine, however, do not appear to be removed until the brine becomes completely saturated, so that crystals of common salt are formed. Hence, if we know the amount of sodium and chlorine brought in by the rivers each year, and the amount dissolved in the unsaturated lake, we can easily calculate the time that has elapsed either since the lake was first formed or since it last overflowed. A body of water that overflows, as everyone knows, soon becomes essentially as fresh as the rivers that supply it. On the eastern side of the Sierra Nevada mountains, Owens Lake, a body of salt water in southern California, is peculiarly well adapted to our present purpose. Owens Lake receives most of its water from the river of the same name. Both have been measured and analyzed with unusual thoroughness because part of the river is carried to Los Angeles in a remarkable aqueduct nearly 250 miles long. H.S. Gale of the United States Geological Survey has carefully gathered all the available data. He concludes that, according to the figures of the aqueduct engineers, the accumulation of the chlorine of Owens Lake would require 4,200 years, and the sodium 3,500, the average being 3,850. A series of fresh strands and an old outlet channel show clearly that the lake overflowed not long ago. Hence Gale concludes that 4,000 years or considerably less is the length of time since the lake stood at the outlet level 180 or 190 feet higher than at present. These figures, however, require modification. The reason why Gale gives the period as 4,000 years or considerably less is that the figures of the engineers omit the lower third of the drainage area of Owens Lake, and this is the part where the waters flow most slowly, and where the clays and other deposits which surround them are most saline. Hence, more salt proportionally should be accumulated here than higher up. Moreover, as he carefully points out, no allowance is made for the well-ascertained fact that when the rivers are more abundantly supplied with water, as must have been the case when the lake was full, the amount of dissolved salt is also greater, although not in direct ratio to the water supply. When due allowance is made for these conditions, and for others of minor importance, the time since the last overflow is reduced to 2,500 or 2,000 years. In other words, at the time of Herodotus, and perhaps at the beginning of the Christian era, the climate of the Owens Lake region was so moist that the lake expanded to 2½ times its present size and sent a stream down the outlet channel. Owens Lake does more than indicate a change of climate within 2,000 or 3,000 years. It also shows that the change has been highly irregular. This is proved by a large number of strands lying below the level of the outlets, and by the way in which these vary in character, and in the extent to which they have been covered by fresh detritus washed down from the mountains. At Owens Lake there are 4 series of strands. These apparently correspond to the 4 chief periods when the climate has grown moist as shown by the growth of the big trees in Figure 47. Fortunately, Owens Lake lies only 50 miles east of the region where the trees were measured. The general climatic fluctuations of both districts are the same. The outermost strand, the huge gravel beach at the level of the outlet, was presumably last reached by the water about the time of Christ, or possibly in the days of Herodotus, for both the chemical evidence and the trees point to this conclusion. A series of similar but much smaller beaches at lower levels record the approach of a dry period during which the lake fell to a low level whose exact position cannot be determined. Judging by the trees, this must have accumulated about 650 AD. During this period, gravels were washed in by mountain streams and formed what are known as fans, or low flattened cones, which may be several miles long. These cover the old strands in many places and extended far below their level to the diminished lake. Next the waters rose again, but not halfway to their former level. They formed 2 small strands, not gravelly like their predecessors, but faint and sandy as if the winds were weak. They must date from about 1000 AD, when the trees indicate a wet period, for they are younger than the gravel fans of the preceding dry time. The next phase of the lake was a dry period, which was most extreme about 1250 AD. More gravels were then deposited, and the fact that they cover the preceding strands and extend to a much lower level shows that the lake then stood low, as would be expected from the trees. The next high period of the lake, about 1350 AD, according to the trees, is unusually interesting. The water did not reach so high a level as formerly, perhaps because the rainy period was short, but it formed a large beach of gravel quite different from the preceding beaches. This seems to indicate great storminess, a condition which is also suggested by the fact that the growth of the trees at this time increased more rapidly than at any other period for nearly 3,000 years. In Europe during the same century, unprecedented storms caused great floods in France, while the severity of the waves was so intense as to break through beaches and sand dunes and convert large marshy areas into portions of the sea along the coast of Holland and Lincolnshire. During the winters the rivers froze to an unheard-of degree, and 3 or 4 times men and animals passed from Germany to Sweden on the solid ice of the Baltic Sea, an occurrence unknown in our day. In England the summers were so rainy that the average yield of grain diminished disastrously. In self-defense many landowners gave up grain raising, and turned their attention to sheep and cattle. Distress and discontent were the inevitable result among the peasants. Far away in Central Asia, the Caspian Sea and the Lake of Lop-Nor both rose with great rapidity between 1300 and 1350 AD. Thus from California to China, evidence of various kinds unite to indicate that during the 14th century there occurred a short period of unusual storminess. Such conditions, if intensified and prolonged, would probably cause the accumulation of enormous glaciers. To return to Owens Lake, the lowest series of strands is sandy and small compared with the large gravel bar of 1350. It was evidently formed under different conditions. Presumably, the lake fell to a low level about 1500 AD, and rose during the next century or more to form the highest strand of the later series. The evidence of Owens Lake is much strengthened by that of its neighbors. At Monroe Lake, farther north in California, the more recent strands are almost identical with those at Owens. Since 1900, Monroe Lake appears to have risen higher than at any time since at least 1775, as we judge from the rings of growth of a tree killed by the rising salt water. Thus on all sides there is the strongest evidence not only that the climate of the past differed from that of the present, but that many minor pulsations have occurred and have grown less intense during the historic period. Up to about 1912, I supposed, as did practically all students of the subject, that the same kind of climatic changes have taken place in all parts of the world. At that time, Penck, a leading student of the glacial period, came to the conclusion that this is by no means the case. He showed that the northern side of arid or desert areas we find densely saline lakes, like Great Salt Lake in Utah, surrounded by old strands. These indicate that the lakes have long been contracting, so that they have abandoned first one strand and then another, while at the same time their waters become more and more highly concentrated. On the equatorial side of the desert belt, on the contrary, we have such lakes as Chad in Africa, a shallow sheet of water, only slightly salty and not surrounded by any great series of strands. It has the appearance of being a new lake formed by a recent increase in rainfall. Penck points out a similar contrast between the sand dunes on the poleward and equatorial sides of the desert belt in both hemispheres. On the poleward side, the dunes consist of loose, moving sand appropriate to places that are growing drier. On the other side, there are plenty of dunes, but they are covered with a sparse vegetation which is sufficient to keep them from moving and to prevent the formation of new dunes. Since their formation, the rainfall has evidently increased from the dunes and lakes, as well as from other evidence, such as the snowline. Penck concludes that changes of climate consist of an alternate shifting of the climatic zones. During our glacial period, he holds that the northern storm belt is shifting southward, so that the storminess of Germany and the northern United States is pushed into Italy or the southern United States. In the same way, the desert belt is displaced toward the equator. Thus, the polar side of the desert has more storminess and moisture than formerly, while on the equatorial side, the desert is shoved into an area where equatorial rains formerly supported abundant vegetation. During a time such as the present, on the contrary, the desert expands on its northern border. Its lakes diminish, leaving strands behind them and becoming very saline. Vegetation dies, and the wind is free to pile up sand dunes. On the other, or equatorial side of the desert, the amount of rain is greater than before. Hence, basins which formerly contained no water are now filled with shallow lakes, such as Chad, which have not yet had time to become highly saline. Vegetation also spreads into the desert, and sand dunes become covered with it and cease to be moved by the wind. Few people have studied glacial problems more carefully than Penck. One result of the minuteness and care of his studies is that he is one of the foremost advocates of great climatic complexity. He distinguishes several post-glacial stages, and in addition brings his conclusions so far toward our own time that he states that a peculiarly dry period prevailed in Central Asia as late as the early part of our era. While Penck was formulating his hypothesis of a shifting of climatic zones as an explanation of the glacial period, I was working out the same hypothesis in respect to historic times. Our work was wholly independent, being based on different lines of evidence, and so far as I am aware, neither knew what the other was doing. The shifting of climatic zones is by no means a new idea, for it has been vaguely suggested many times. The new thing is to find direct evidence of it, such as Penck presents in his discussion of lakes and dunes. As to historic times, the ruins of Guatemala and Yucatan furnish perhaps the best available test, for those regions are the most notable example of a civilization which developed within the torrid zone. The ruins of that civilization are the most remarkable archaeological remains in the Western Hemisphere. Part lie near the central coast of Yucatan in a relatively dry region inhabited today by a fairly prosperous agricultural population. Many of the finest ruins, however, and most of the more ancient ones, lie back from the coast of a wilderness of dense forest and jungle. There, agriculture is almost impossible. The difficulty of clearing the rank vegetation and getting it dry enough to burn before a new crop of lusty bushes grows up is enormous. Fevers, too, prevail most of the year. They include the worst types of tropical malaria, as well as many other kinds. Foreigners are quickly attacked, and it would be dangerous for a white man to attempt to live there permanently, even with all the appliances of modern medical science. The natives also suffer terribly. Many of the children are apparently killed by malaria and other tropical diseases in infancy. Those who grow up carry the effects with them through life. 75% of the tropical workers at the Panama Canal are thought to have had malaria germs in their systems, even though they do not show outward signs of the disease. And the case is probably even worse among the natives of the lowland forests of Quintana Roo, Campeche, and Petén, where most of the early Maya ruins are located. One has only to look at their swollen paunches to see that something is the matter, and their dull, apathetic manner, both in work and play, is another sign of some deep-seated physical ailment. Here, where today the Indians are so diseased and agriculture is so difficult, there dwelt an ancient race characterized by the qualities which have been defined as most essential to a high civilization. The Mayas of Yucatan and Guatemala, alone among the Aborigines of America, carried to high perfection the arts of sculpture and architecture. The Incas of Peru, to be sure, made striking buildings, but they had no idea how to adorn their simple structures with columns, rosettes, arches, gargoyles, pediments, and many other agricultural devices which were universal among the Mayas. These clever people were also adepts in astronomy, for they framed the most exact calendar ever known except our own. Theirs was better than that which Eastern Europe used up to the time of the Great War. Most remarkable of all, the Mayas developed the art of writing and carried it to a pitch higher than that reached by the Chinese, for they apparently began to use signs to denote sounds instead of having a sign for each individual word. Their temples are great structures which sometimes rise 3 stories in height and have a length of 300 or 400 feet. A single city often contained a score of noble buildings and extended over not blessed with progressive neighbours to spur them on and teach them new ways. They had no beasts of burden. They could not plough the fields nor transport loads except by their own labour. Every one of the great stones which form their temples and palaces must have been brought by human effort, a task which none but a most energetic race would undertake. Another disadvantage was the absence of metal tools. The Mayas perhaps had a little copper, but not a trace has been found of any metal tool that would be of service in carving their intricate facades and delicately wrought statues. Flint or obsidian was all that they had, and yet with such poor tools they created works of art which command sincere admiration. To do all this with such small opportunities was surely one of the greatest feats ever achieved by any race. The most surprising thing about the Mayas is that they developed their high civilization in what are now the hot, damp, malarial lowlands, where agriculture is practically impossible. 100 miles away on the coasts of Yucatan or in the Guatemalan highlands, far more favourable conditions now prevail. There agriculture is comparatively easy. The climate, while not bracing, is at least good for the torrid zone, and malarial fevers are rare. Today the main cities lie in these more favourable regions. The energetic part of the population is there, and the interior lowlands are hated and shunned by all except a degraded handful. In the past, the more favourable localities were occupied by people close akin to the Mayas, yet civilization never rose to any great height. Ruins are found there, but they are far behind those of the lowlands, as the cities of Yucatan are today behind those of the United States. In explanation of these peculiar conditions, several possibilities suggest themselves. First, we may suppose that the Mayas were the most remarkable people who ever lived. They were able to carry on agriculture under conditions with which no modern people, not even those of European race, have ever succeeded in coping. They chose the worst part they could find, almost the worst in any part of America, even though far better places lay close at hand and were occupied by an allied people relatively few in numbers and backward in civilization. They were able to preserve their energy for 1,000 years or more under the most debilitating climatic conditions, and lastly they are immune to the many fevers which today weaken the dwellers in their old habitat. It is possible that a process of natural selection had given these people an extraordinary degree of genius, energy, and ability to combat disease. Indeed, it seems to me that this must have been the case. Nevertheless, I doubt whether it fully explains why the Mayas settled and thrived in what would now generally be accounted the worst parts of their general region. A second possibility is that in the time of the Mayas, tropical diseases were less harmful than at present. We have no shred of evidence one way or the other. Such a thing is possible, but in view of the fact that there are several kinds of malaria, not to mention other diseases, any one of which greatly weakens a race, there is little chance that the Mayas were free from disease unless something else was also different. Even if diseases were not so prevalent as now, this does not explain the other apparent anomalies of the Maya situation. It may be, however, that a fairly satisfactory explanation will be found if the two preceding possibilities are joined with a third, namely, a climatic change, such as the dry conditions which prevail a little farther north, prevailed in the Maya region when these people attained eminence. Such a shifting of zones would increase the length of the dry season which now comes in February and March. This would diminish the amount of vegetation and cause scrub to take the place of dense forest. Under such conditions, agriculture would become comparatively easy. Fevers would also greatly diminish, for in the drier parts of Yucatan they are today relatively mild, and the lowland plain would be the natural site of the chief development of civilization, just as is the case in other countries. When the dates of Maya history are compared in the curve of tree growth in California, they seem to agree with the hypothesis of a shifting of climatic zones. The early chronology is so doubtful that we may pass it by. The 7th century, however, is known to have been a time when Maya civilization sank to a very low ebb, for scarcely a building dates from that time, and the traditions become most vague. The great fact of this period is that, for some reason, the Mayas completely abandoned their old homes in what is now the forested south of Mayaland. They migrated north to the drier, less forested, and more healthful regions of northern Yucatan. This would be what we should expect, for when the California trees grew slowly, as in the 7th century, the desert zone that almost girdles the globe would lie far to the north. At the same time, the equatorial zone of rains would expand northward over Guatemala and Yucatan. The rainfall would be abundant and the dry season short. The forests would become rank, agriculture would be difficult, disease would be rife, and the vitality of the Mayas would be sapped. From about 900 AD to 1100 AD, on the other hand, the California trees grew rapidly. At such a time, the desert belt would be pushed south, and favorable conditions would prevail in the home of the Mayas. At that time occurred the last great revival of architecture and the construction of the great buildings whose ruins now adorn Yucatan. Whatever the cause, there is no doubt that there was a marked outburst of energy. The later history of the Mayas has no great abundance of architectural monuments to serve as landmarks, and hence cannot be correlated with the fluctuations of the California curve. Yet so far as the indications enable us to judge, the two sets of phenomena are in harmony. In addition to the Maya ruins, the conditions of Palestine and the growth of the California trees furnish independent evidence that the zone of cyclonic storms has at certain periods suffered a shift equatorward. In Palestine, the rainy zone apparently once extended at least 50 miles south of its present limit, in spite of the fact that the mountains there die out and thus render the conditions doubly unfavorable to rainfall. Today Hebron is the last large town and Beersheba the last village. In the old days, Ojer, far to the south, was comparable to Hebron, and other ruins indicate that settlements were located still farther southward. In California, trees indicate a shifting of zones because they grow most rapidly during years when storms continue late into the spring. At such times, the winter zone of storms is pushed equatorward and continues to give moisture late in the spring. Further consideration of changes of climate is not here possible. For that the reader must turn to climatic changes in earth and sun. Here our main interest centers in the results of such changes and in the degree of certainty with which we can make use of them in the interpretation of history. For our present purpose, the essential point is that a series of climatic pulsations has apparently continued from a maximum phase in the last glacial epoch down to a minimum phase today. Nowhere do we find any marked break between the past and the present. On the whole, the early millenniums of the historic period appear to have been drier than the present in such regions as Syria and California, but this general condition of more abundant rain appears to have been broken by frequent dry periods which may have lasted hundreds of years. Some of these, as in the 7th century of the Christian era, may have been even drier than the present. Moreover, the effect of any given phase of a climatic pulsation is not the same in all parts of the world. On the contrary, the effects differ from zone to zone, from the coast of a continent to the interior, and from the east side to the west. Accepting magnitude, the climatic cycles of the past appear to have been like the small cycles of the present. California, for example, tends to be rainy when Florida is dry. It must be clearly understood that the chief characteristic of the climatic pulsations of the historic period has not been changes of temperature. Failure to understand this point has led to many mistakes. The chief variations have apparently occurred in the number, intensity, and paths of the kind of cyclonic storms which break ordinary changes of weather in the progressive regions of the United States and Europe. Such storms are by far the most variable climatic factor. The extent to which the mean annual temperature or relative humidity of a region may vary from one year to another is very limited, but the rainfall, and still more the number of storm tracks whose centers pass near a given place, may vary greatly. Some years, storm after storm sweeps across the country at intervals of only a few days, while in others a real storm occurs scarcely more than once a month. Even in a place like New York City, where the climate is very regular, the number of storm tracks whose centers passed within 200 miles of the city in the short period from 1900 to 1915 varied from 21 in 1903 to 48 in 1915. While from July to December the variation was from 7 to 24. In regions having the type of climate now found in the eastern Mediterranean region and in California, such variations are far greater. At San Francisco, for example, the number of storm centers passing within 200 miles of the city during this same period varied from 1 in 1900, 1904, and 1914, or none in the 12 months from December 1913 to November 1914, to 13 in 1903. In the past, according to our hypothesis, the number of storm tracks for century after century approached this higher figure, while at other periods it fell toward the lower figures. In other latitudes and in parts of the continent where other types of climate prevailed, an opposite type of change took place, while in intermediate regions no distinct alteration was evident. End of section 14. Section 15 of Climate and Civilization by Ellsworth Huntington. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Leon Harvey. Chapter 15. The Pulsatory Hypothesis and its Critics. Changes of climate are so vital an element in the main conclusions of this book that I shall devote a chapter to criticisms of climatic hypotheses. I shall begin by summarizing once more the changes in my own opinions, for these changes have had much to do with the nature of the criticisms. 1. When I first became convinced that climatic changes had taken place in historic times in Western Asia, I accepted without question and opinion, then somewhat widely held, that the earth as a whole was growing drier and warmer. 2. Further study, as already explained, soon led me to abandon this idea of progressive desiccation in favor of the hypothesis of pulsations whereby the climate first became warmer and drier, and then moister and cooler. 3. The next step was the conclusion that variations in temperature are of negligible importance, and that the main change has been in the amount of rainfall. 4. Investigations in regions other than deserts advance hypothesis another step by leading to the conclusion that changes of opposite types have taken place in different latitudes, and even opposite sides of a continent of the same latitude. 5. The last step was the conviction that the evidence points clearly to changes in the location, number, and intensity of cyclonic storms as a main factor in climatic pulsations. Bearing in mind, then, that the hypothesis of climatic pulsations as presented in this book has become quite different from what it was when first published in 1905, let us consider some of the main criticisms. 1. Many authors have endeavored to disprove all theories of climatic change during historic times by suggesting that the supposed evidence of moisture in the past are purely accidental. In one place, so they say, a river may have changed its course. In another, an earthquake may have diverted an underground water supply. Famous marches like that of Alexander with his elephants in Persia may have been possible not because the climate was moister than that of today, but because the march occurred in an unusually wet year. In the same way, the thousands of seemingly waterless ruins in the southwestern United States may have depended upon hidden springs, one or two of which have been found. Such arguments are of value merely as guides in determining the kind of investigations that shall be made in the field. They break down what is realized that although many conscientious investigators have led them in mind, the evidence that would give them weight is not forthcoming. It must be remembered that the evidence on which the hypothesis of climatic pulsations is founded is of many types. It is widely spread in at least 4 continents, and depends upon literally thousands of ruined towns, waterless roads, abandoned irrigation systems, old unirrigated fields now too dry for cultivation, old records of lake levels and the like. It is statistically impossible that so many accents should all point in the same direction. Accents by their very nature tend sometimes in one direction and sometimes in another. The evidence of climatic changes, however, is not only widespread, but extremely systematic. At certain periods and in certain types of climate, it all, so far as I can see, tends to indicate aridity. In other types of climate, and at other periods, it seems to point with equal unanimity in the other direction. If the evidence were merely the results of accidents, such a separation on the basis of both time and place would be impossible. 2. A number of persons have criticized the pulsatory hypothesis under a misapprehension, or have directed their criticisms at earlier statements of the hypothesis without knowing of later modifications. A good instance of this is Woykoff's book on Turkestan. Apparently that Russian author had not read or had failed to understand the pulse of Asia, but had become thoroughly familiar with a book written by his countryman Berg for the express purpose of combating what he believed to be the false conclusions in the pulse of Asia. At any rate, Woykoff pronounced the conclusions of the book inane, and then proceeded to prove the very thing that led to the choice of its title, namely that during historical times the Caspian Sea and other lakes in Central Asia indicate alternating periods of more and of less rainfall than at present. Herbert, a French critic, also aims his main arguments at progressive climatic changes, but agrees that the Caspian Sea affords unmistakable evidence of climatic pulsations. In general, the critics have tended to attack not only the idea of progressive climatic change in one direction during historic times, but the idea of climatic uniformity. The alternative to which almost all authorities turn is climatic pulsations having a greater intensity in the past than at present. Over 9/10 of the geographers of America, if we may judge from the 50 whose opinions have been expressed in writing, hold this view, although they differ as to the degree to which climatic pulsations have influenced history. 3. A certain type of critic has asserted again and again that in the southwestern United States, and to a less degree in other places, the population in regions that are now too dry to support many people was never so dense as the ruins seem to indicate. What really happened, they say, is that the same people built village after village and house after house. Superstitious fears of death or disease, or tendency to wander, may have caused a house to be inhabited for a few decades and then abandoned. The old house never was reoccupied, but a new one was built by its side. Thus ruins which appear to be large enough for 1,000 people may never have been occupied by more than 50 or 100 at any one time. Wherever the history of a region is well known, this explanation is wholly out of the question, as in Syria, the Libyan desert, Persia, and many other parts of the Old World. It has flourished in America simply because the history of pre-Columbian America is unwritten, and archaeologists have been free to exercise their imaginations. Douglas, however, who perfected the methods of measuring climate by means of tree growth, has most effectively proved that in at least one case a relatively large set of ruins was all built at practically the same time. By comparing the rings of different trees, he is able to tell just which ring in one tree is synchronous with a given ring in another. This is possible because the rings vary greatly from year to year, and the same succession of rings of various thickness is practically never repeated. By this method, Douglas finds that in one of the large ruins at Chaco Canyon, New Mexico, the houses were all constructed within about a decade. Thus the whole village must have been occupied at one time, and there was no successive addition of new rooms to replace those no longer occupied. Of course, this is only one instance, but a single concrete, well-established fact like this is worth more than any amount of supposition. 4. In many quarters, there has been an assumption that climatic uniformity is a normal condition. Meteorologists do indeed find that so far as records are yet available, which means for scarcely a century, there are no certain indications of progressive climatic changes, but there is overwhelming evidence of pulsations which increase in magnitude and duration as the records become longer. In the same way, the geological record continually discloses new evidence of climatic pulsations. Where one glacial period consisting of a single epoch was generally recognized half a century ago, at least 6 are now recognized. These date from all parts of geological time, and some have several epochs and sub-epochs. Moreover, the studies of Barrel, De Geer, Sailors, and many others are rapidly showing that, during practically the whole of the Earth's known history, smaller climatic variations have occurred. Thus, pulsations of climate are now almost universally regarded as characteristic of the vast periods covered by geology as well as of the short period covered by exact climatic records. The presumption is that similar pulsations of intermediate magnitude were characteristic of the intervening historical period. One of the most interesting facts in this connection is a change of attitude among meteorologists. For example, Ward of Harvard, who was for many years the only professor of climatology in an American university, has long been one of the strongest champions of climatic uniformity. In his latter works, however, and especially in his forthcoming Climate of the United States, his attitude toward the hypothesis of pulsatory climatic changes has altered from pronounced opposition to benevolent neutrality. His position is that of the kind of physiographic and archaeological evidence which must be used in solving the problem of climatic changes during the period prior to exact records is utterly different from the statistical data to which climatologists and meteorologists are accustomed. Therefore, specialists of those types cannot properly evaluate it, but must wait for the final decision of specialists in this particular line. As a matter of fact, the great majority of specialists in post-glacial climatology now accept the idea that climatic pulsations have continued into historic times. 6. The contrast in the types of evidence which are conclusive to workers in diverse lines of research is illustrated not only by the fact that meteorologists are slow to accept the evidence of historic changes of climate, while geologists are quite ready to accept it, but by the fact that historians seem to think that if changes of climate have occurred, there ought to be written records to this effect. This may be illustrated by two eminent geographers who follow the historical method. Bruns and Semple both reject the idea that climatic changes have had an important effect upon history, but neither gives reasons for such rejection. Ms. Semple, for example, in an admirable paper on the Mediterranean lumber trade, merely states that, having studied the evidence, she does not think it convincing. Her work, with its remarkably complete references, even when minor matters are discussed, shows that to her the real evidence on this point is the written word. With her unusual fairness, however, she points out that the accounts of widespread forests in ancient Cyprus suggest a different climate. She also gives many other facts which seem much more consistent with climatic changes than with uniformity. At least they seem so to persons with a geological training. Such persons have become more and more accustomed not only to the idea of repeating climatic fluctuations of all grades throughout geological times, but to the idea that such fluctuations have caused the destruction of many types of plants and animals, and have hastened the development and migration of new types. The historian, on the contrary, is accustomed to attribute almost everything to purely human action. Hence, in the absence of records to the contrary, he assumes that human causes are mainly responsible for such facts as deforestation, changes in trade routes, and apparent drying up of sources of water, the abandonment of settlements in the drier parts of the world, and the migrations which so largely originate in dry regions. 7. Closely connected with the preceding attitude of mind is a reason for the rejection of the hypothesis of climatic changes which have been advanced by some historians. They say that such changes are not needed in order to explain the historic facts, but this has nothing to do with the matter. The primary question is whether climatic changes have taken place during historic times. If they have taken place, the historian must perforce take note of them and inquire into their effect, just as he inquires into the effect of barriers like the Alps or of great men like Socrates. This wholesome attitude is beginning to prevail in many quarters and will doubtless grow. A good example of the way in which a knowledge of climatic changes throws light on history is set forth by A.T. Clay in an article on the so-called Fertile Crescent and Desert Bay. From a study of Babylonian tablets, Clay discovered that a Semitic people known as the Amaru or Amorites had already risen to a position of relatively high civilization in the 4th millennium BC. Their capital was at Mari on the Euphrates River, not far from 37 degrees north, in the very heart of what the Oriental historian Breasted has described as a desert bay. The tablets seem to show that this capital was powerful enough to rule Babylonia, but Breasted maintained that this was impossible because there was no sufficient material basis for an empire such as that of the Amorites. The arable land along the Euphrates is too limited to supply an empire, and the surrounding land is desert. Nevertheless, Le Grain of the University of Pennsylvania found a fragment of a dynastic list which showed beyond question that the Amorite city of Mari on the Euphrates ruled Babylonia in the 4th millennium BC. Thus the historic facts and the present condition of climate are completely out of harmony. When Clay investigated the matter on the spot, he found about 700 square miles of arable land within the alluvial tract which might be watered from the Euphrates. Much of this, however, could not now be irrigated under the present conditions of floods and erosion. Even if it could all be irrigated, it is scattered in so many small bits that would form a very inadequate basis for an empire which could rule Babylonia. The region round about, however, is full of evidence that the country was by no means a desert in the past. As Clay puts it, to include the Euphrates Valley in the so-called Desert Bay would be equivalent to including the Nile Valley in the Sahara Desert. The difference, however, being that unlike the Sahara, Mesopotamia was not a desert in ancient times. It is not improbable, since we know that the climate has changed within the past 2,000 years, that practically the entire area of many thousand square miles of Mesopotamia north of the Euphrates River was fertile, or at least was a great pastoral territory. The Kabur and the Baliki rivers, which flow through this region southward to the Euphrates, were augmented by numerous streams. Some of these at present containing water, while others are dry. Today, the Bilik River at the end of the summer is almost dry at its mouth. In commenting upon the Kabur and its territories, an Arab writer says it is such as is not to be found in all the land of the Moslems, for there are more than 300 pure running fountains. Certainly the Hebrew writers and redactors of the Old Testament would not have made themselves ridiculous in the eyes of their intelligent contemporaries by placing the Garden of Eden in this region, if it were a desert bay. And what is true of the region north of the Euphrates is true of the land lying to the west of the river. There are dry beds of rivers and streams with sand and pebble bottoms in which, at present, water is not seen from one end of the year to the other. Even many of these streams are spanned by well-constructed bridges. There are wellheads, spring houses, in which water formerly gushed from the earth, some even containing inscriptions, but where neither wells nor springs exist today. Even in the flat and once fertile plateau, which was thickly inhabited, there are no signs of irrigation having been practiced, showing that there was once sufficient rain to make the country habitable. There are reasons for believing that forests existed in certain regions, where today the tree and the vine could not secure a footing, for the hills are denuded of their soil. The land which the Greeks and the Romans found so profitable to develop is now largely a waste, and it's difficult to appreciate, for what we see at present, what certain ancient writers tell us about the land. For example, Cicero, who said that the country is so rich and so productive that in the fertility of its soil, in the variety of its fruits, and the vastness of its pastoral lands, and the magnitude of all things which are matters of exploitation, it is greatly superior to all other countries. Manilian Law 6. A little to the west of this upper Mesopotamian kingdom of Amaru, Butler points out that a pronounced change of climate is necessary in order to explain the history of Syria, where an area of 20,000 square miles, which is now practically desert and deserted, was more thickly populated than any area of similar dimensions in England or the United States is today, if one excludes the immediate vicinity of the large modern cities. It has also been discovered that an enormous desert tract lying to the east of Palestine, stretching eastward and southward into the country which we know as Arabia, was also a densely populated country. How far these settled regions extended in antiquity is still unknown, but the most distant explorations of these directions have failed to reach the end of ruins and other signs of former occupation. It would be easy to cite many other instances where a knowledge of climatic changes helps greatly in understanding history. In World Power and Evolution, I have shown this in relation to Rome, while The Character of Races gives similar illustrations for China, Iceland, and other regions. But regardless of whether the historian feels the need of changes of climate to explain the historic record, no scientifically minded historian can fail to take account of such changes if the specialists in such matters agree that they have taken place. The general attitude of such specialists, even in 1916, and still more at present, seems to be well summed up in the words of D. W. Johnson, Professor of Physiography in Columbia University. The climatic factor, he says in a review of that book, does not solve all the problems presented by a theory of climatic pulsations. It does not pretend to do so. It does aim to show that the evidence thus far available strongly supports the belief that there have been within historic time climatic changes of a pulsatory nature. In this the author has, in the opinion of the reviewer, been successful. One of the latest expressions of opinion is that of Antevs in Postglacial Climatic Cycles, 1924. The view of distinct climatic fluctuations, advanced especially by Huntington in a number of papers, is being more and more accepted. The very best evidence of the occurrence of climatic fluctuations of short as well as long duration, up to thousands of years, is probably to be found in the varying rate of growth of the big trees and in periodic retreat and halt to the edge of the Pleistocene ice sheets. Huntington shows that there have been, during historic times, within limited regions, climatic fluctuations of different length and character, but particularly in precipitation. The most noteworthy fact is that, especially in Western and Central Asia, the climate 2,000 or 3,000 years ago appears to have been distinctly moister than today. End of section 15. Section 16, 5. Civilization and Climate by Ellsworth Huntington. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information on a volunteer, please visit LibriVox.org. Recorded by Leon Harvey. Chapter 16. The Shifting Centers of Civilization. The final stage of our investigation is now before us. We have compared the present distribution of civilization and of climatic energy, and have seen their remarkable similarity. We have found that during historic times a pulsatory shifting of climatic zones appears to have taken place. Let us now examine this shifting of civilization and determine how far they are in harmony with those of climatic energy. The black area of the map of energy, figure 43, embraces about 1,100,000 square miles, or 2% of the total land surface of the Earth. Its population is about 260 million, or 17% of the world's total. Consider what would have happened if all except this small 2% of the lands had ceased to exist 17 or 18 centuries ago. Civilization would probably have been altered only slightly, although history would have been very different. If the rest of Europe had ceased to exist, Byzantine art, the works of the early Christian fathers, Moorish architecture, and Spanish explorations, conquests, and colonization would be lacking. Yet this would not seriously change the conditions under which we now live. Suppose that not only the more backward European countries, but all the rest of the world except the very high European area had been blotted out in 200 AD. The influence of Greece and Rome would have persisted in Italy. The Roman Church, the Renaissance, and the Reformation would all have played their part. The absence of new lands for discovery in the Middle Ages would doubtless have retarded the development of certain ideas. Otherwise, the status of civilization would have been changed only a little. The United States is the only non-European country which has succeeded in touching the daily life of the world as a whole. American inventions have gone everywhere. The denizen of Turkestan would discuss news received by telegraph, and whose wife makes his clothes with an American sewing machine is being generally touched by the New World. Yet America must not boast too loudly, for without her aid, Britain, France, Germany, Italy, and their small neighbours would have made most of the world's great inventions. To an even greater degree, they would have been able to develop the arts and sciences. The energetic area of Western and Central Europe has been the great centre of civilization for 1,000 years. From it have gone forth more new ideas than from all the rest of the world combined. Its manufacturers have flooded all parts of the earth. Politically, it dominates about 60% of the earth's surface. Socially, its domination is still greater. The United States has long been chagrined because South America has looked to Europe not only commercially, but for her inspiration in literature, art, education, and almost every other phase of activity. Politically, the United States helped greatly in inspiring the South American republics, and was at the front in stirring Japan to the new life of the last half-century. Yet those countries have turned their faces Europeward, because that is where ideas have been most numerous and have been most fully embodied in the concrete form of institutions, inventions, or scientific principles. Wherever one turns, he feels the tentacles of the great European centre of civilization reaching out and vivifying the life of the whole world. To tell why this is so would require a volume. The position of Western Europe, the strong racial inheritance of its people, their legacy from the civilizations of the past, their inspiring religion, their political freedom, and their many powerful institutions all play an essential part. With these, however, and as one of the conditions which make them possible, stands the fact that Western and Central Europe is the only large region which for many centuries has had these advantages, and at the same time has enjoyed a highly stimulating climate. The main American high area differs somewhat in shape on the maps of civilization and climate, but not essentially. In general, it occupies a portion of the United States lying north of about latitude 38 degrees and east of the Rocky Mountains, together with the adjacent strip of southern Canada. Its area, taking the average of the black portions of the two maps, is approximately the same as that of the similar European region, that is, about 1,100,000 square miles. The population, however, is only 70 or 80 million. Here, then, we have another 2% of the Earth's land surface, containing between 4 and 5% of the Earth's total population. Consider how disproportionately great an influence it exercises. To be sure, it falls far behind Europe, but that is partially because it is newer and less densely populated. It differs from Europe only in the degree, not the kind of influence. We have already referred to some of its inventions. All the world recognizes that the telephone and telegraph and many other forms of applying electrical energy are primarily American. In architecture, we have evolved such wholly new types as the new skyscraper. In art and literature, we follow far in the wake of Europe. Yet we have done some things which are widely known in other countries, and which are steadily molding the world's opinion. The same is true in science, for the day is past when Europeans can ignore the work done on the western side of the Atlantic. In the future, the disparity between Europe and America along this line bids fair to decrease rapidly, for great institutions devoted to pure science are growing on a scale unknown in other lands. This is in part the result of another line of effort in which Americans have achieved unusual success. By this I mean what is sometimes called big business, the amalgamation of many minor industries or branches of an industry into one huge whole. It is illustrated in such organizations as our great railroads, and the United States Steel and Standard Oil companies. These represent in part the effect of unusual opportunities, but they also indicate a great expenditure of energy in planning and directing such widely ramifying activities. Lastly, and perhaps most important of all, the United States has touched the world upon the political and social side. In spite of political sins, which are many, this country has stood for freedom and justice. Its example has inspired other nations, including parts of Western Europe, and has given them a stronger desire for equality of opportunity and for the breaking down of unfair discriminations between man and man. In more backward places, a similar influence is felt. Good judges say that in Turkey, for example, one of the most potent causes of the revolution of 1908 and the establishment of representative government was the teaching of American missionaries. The same is true in China, except that there the Americans have been associated with missionaries of many other nations, while in Turkey there have been almost none. In many other ways, the ideas of this small area radiate in all directions, and that lies the essential point. Because as 4 or 5% of the world's population are endowed with unusual energy, they are rapidly obtaining an influence wholly disproportionate to their numbers. The third important region of high civilization and energy is Japan. Although the area is only about 1/10 that of the corresponding portion of Europe and America, the population is over 50 million. In proportion to population, its influence upon the world is less than that of the European countries and the United States, which perhaps corresponds with an apparently lower degree of climatic energy. Yet we all recognize that Japan is a factor to be reckoned with. We admire its art and the skill and certainty with which the country has made use of our Western civilization. We see students flocking thither from China. In India, the news of the progress of Japan causes stirring of dead leaves as by an autumn wind. As Japan has done, so India would do. In India, however, the agitators chiefly talk and commit violence, whereas in Japan they go to work quietly without much talk or violence and make themselves so efficient that they do not need the help of Europeans. When Japan sees an opportunity, such as was afforded by the war in 1914, she takes it, and thus advances another step in her role as the most capable nation in Asia. Like Europe and America, she makes mistakes sometimes, but they are the mistakes of strength more than of weakness. Next to Japan, among our areas of high civilization, comes New Zealand, together with the adjacent corner of Australia. Here we have chiefly a reflection of British civilization. Most of the 5 or 6 million people are grouped in an area somewhat more than twice the size of Japan. The question is not whether they show evidences of a high civilization, which they certainly do, but whether they have added to the endowment of ideas and institutions with which they came from England. They have clearly done so, for when we think of Australia, there come to mind such things as the Australian ballot, whereby man is enabled to vote freely without undue influence from bystanders. We think also of progressive labour legislation and of a pioneer attempt at old age pensions, especially in New Zealand. We are made conscious that these people are not mere followers, but are blessed with ideas which they themselves originate and which spread out from them to other parts of the world. The last area which rises to the very high grade on the map of civilization is California, and the coast farther north. The population is still relatively small, and the majority grew up in other regions. Hence it is too soon to judge of the ultimate status of this area. It is so bound up with the rest of the United States and Canada that its particular contribution to civilization cannot be clearly differentiated. Yet through their universities and their readiness to attempt great things, the people of the Pacific coast impress the world as unusually capable and energetic. Altogether, these 5 regions comprise less than 1/20 of the lands, though they are densely populated because of the skill of their people in agriculture and manufacture. They contain only about 1/4 of the world's population. In influence, however, they many times outweigh the remaining 3/4. If they decide on anything, the rest of the world must submit. They never care to imitate the more backward nations, whereas such nations show a growing desire to imitate Europe, the United States, or Japan. The reason seems to be that the favoured 1/20 of the land is inhabited by people of great energy, and this energy appears to be due, in part at least, to the frequency of cyclonic storms with their stimulating changes of weather from day to day. This leads to the question whether similar conditions prevailed in the past. Throughout the course of history, there have been centers of civilization like those which exist today. One of the most important was the plain of Mesopotamia. Here in the earliest days, the people of Sumer and Akkad invented hieroglyphs, founded great cities, built mighty irrigation works, drained the marshes, and laid the foundations of a complex system of law and religion. They clearly possessed the power of originating ideas and of putting them into effect in a way that is now a characteristic of the modern centers of civilization. Where they originally came from we do not know, but apparently they were not Semitic. In course of time, they were overwhelmed by Semites, who presumably came in as rude invaders. Then there happened one of the most characteristic events in the history of centers of civilization. The Semites dropped their old culture and adopted that of the people whom they had conquered. They began also to be inventive like their predecessors, and thus developed cuneiform writing out of the hieroglyphics of the Sumerians. In later days, other Semitic invasions took place. In each case, the invaders had done no great things in their original homes, so far as we know, but when they came to Babylonia, they blossomed into people of inventive minds, full of new ideas, which caused the arts to rise to higher and higher levels. Then the Semites were conquered by a non-Semitic race, the Scythians, who are also called Medes, and they in turn were stirred to great achievements. They were conquered by still another people, the Persians under Cyrus, and once more the old process of stimulation was repeated. One of the most significant things in Mesopotamian history is the way in which each invading race seems suddenly to have risen in civilization as soon as it reached a new country. How much of this was due to natural selection, whereby the weaker people among both the conquerors and the conquered were weeded out during the migrations, wars, and pestilences which preceded the final settlement? How much to contact with the higher civilization? How much to more abundant opportunities afforded by the new environment? And how much to a direct physical invigoration? I shall not try to answer these questions. That some of the invading races achieved great things because they possessed innate ability seems certain. That their minds were rendered more alert by contact with the achievements of the races which they conquered is likewise beyond doubt. That the wealth and agricultural possibilities of Mesopotamia and the abundance of labor stimulated the invaders to construct palaces and temples, build irrigation works, gather stores of treasures, carve huge monuments, spend money in supporting libraries and students, and carry on other great enterprises also seems certain. These principles are so firmly established that there is no need to discuss them. The question before us is simply whether they may also have been a climatic stimulus comparable to that which now seems so important according to our maps of civilization and energy. I do not purpose to discuss the empires of antiquity. I merely wish to point out some of the features of their location and history which pertain to our main hypothesis. While Babylonia was flourishing, Egypt in the same latitude was also developing a great civilization. The two were rivals. Which rose higher, it would be hard to say. They moved along parallel lines, and at last both fell during the same general period, although Egypt retained a moderate importance for some centuries after Mesopotamia had lapsed into insignificance. Far to the south, the Sabians in southwestern Arabia also developed a fairly high civilization, but they formed in no sense a great center. We know little about them, but apparently they were behind Mesopotamia and Egypt in the way that modern Bulgaria is behind England. Therefore, we may pass them by for the present, although they will come up again in another connection. East of Mesopotamia, the highlands of Persia were the set of a comparatively high culture, but it scarcely rivaled that of the two great countries in the river valleys. Going on still farther toward the rising sun, we find high civilization in northern India at a very early time. That region never rose to such a pitch as did the countries farther west, and decayed somewhat earlier. Beyond India, the chain of ancient empires is broken until we come to China. In Indochina, to be sure, traces of a state of culture higher than that of today are found, but they belong to a comparatively late date, and it's doubtful whether they were indigenous. They are important, but do not apply to the period now under discussion. China, however, stands in the same class with Egypt and Mesopotamia. It reached a higher state of development about as long ago as they did. Here too the art of writing developed, inventions of many kinds were made, strong governments were organized, other powerful institutions were evolved, and in general there was intense mental activity. At this point the reader is advised to consult a map of Asia and Europe. Notice how the great countries of the past lie along an arc. They begin on the east with China, whose main center was north of the Yangtze Basin. The civilization which flourished there possessed qualities like those of modern Europe and America. The Chinese were an aggressive, active people, able to fight or to evolve a new religious system, as the case might be. The sword was in their hands not merely because they were ancient days, but because the people or their rulers wanted to make conquests, or because they were quick to resent infringements of their rights. They were not like their modern successors who see themselves defrauded because they have not the power to cope with their despoilers. Follow the map westward along a band 8 or 10 degrees wide with the 30th parallel a little south of its center. At first we find ourselves among lofty mountains which merge into the Great Tibetan Plateau. Here we should not expect any great development because of the unfavorable topography. At length, however, our band descends to the plain of northern India. On the flank of the Himalayas lived Gautama, the great thinker who founded Buddhism. Out on the plains around Delhi and Agra, and in surrounding regions was the home of the early Aryans, who developed the Sanskrit language, wrote the Vedas, and made a real contribution to human progress. Here, just as in China, a broad expanse of arable land was favorable to the development of a great people. Next our band strikes the high mountain rim of Baluchistan and Afghanistan, then passes over the plateaus of those countries, high and rugged in the north, lower and intensely desert in the south. In these regions the ancient civilization was higher than that of today, but not until we reach the western side of the plateau do we come upon the really advanced country of ancient Persia. As our band leaves the Persian highland, let us change its direction a trifle, so that its central line will point toward the center of the Mediterranean Sea. First it lies over Mesopotamia. There in the highly fruitful plain we find the two great empires of Babylonia and Assyria. They were like their modern successors in the Europe of our own day. When they were weak, they were invaded by the more backward people from the mountains on the north and east, or from the desert on the south and west. When they were strong, they waxed ambitious. They strove to extend their borders. They desired to rule the world, and they were jealous of rival nations. Thus, at their strongest, like the great European nations which were locked in a death struggle only a few years ago, they fought tooth and nail for supremacy. The fighting in itself is a proof of superabundant energy. Weak people may fight in self-defense, or to gain new lands when sorely pinched with wanted home, but only a people who have a surplus of both strength and wealth can stand the strain of great wars, whose purpose is primarily national aggrandizement. On the flanks of our band of culture, as we call it, lay the Hittites on the borders of Mesopotamia and Anatolia. Beyond the Syrian desert, the Phoenicians, Syrians, and Jews lived in the center of the band. Their degree of culture was equal to that of the Mesopotamians, but displayed itself in different ways, partially because of the accidents of mountain chains and seas, and partially because of peculiar circumstances of their racial character or history. Next comes Egypt, still within the belt. Here still another fertile plain gave opportunity for the accumulation of great wealth and for the leisure which is essential to a part of the population if new ideas are to be developed. They fought the same kind of wars as did their neighbors on the east. When they were most powerful, their strength and energy were such that the mere conquest of their immediate surroundings did not satisfy them. Taking Palestine, they penetrated Syria and even advanced to the Euphrates to fight with Assyria, their great rival. And the Assyrians in turn came down through Palestine to wrest the sovereignty from Egypt. Now we pass on, curving our band a little more, so that its center shall pass along the main axis of the Mediterranean Sea. Rhodes, the Aegean Sea, Greece, Italy, and Carthage fall within its limits. Here too we see the same phenomena of the rise and fall of great nations. The rise did not begin quite so early in the west as in the east, and the fall did not come so soon. In Greece, as in Mesopotamia, a growth of strength brought with it a great struggle for supremacy, which did not end till Athens had subdued her rivals. The wars of Rome and Carthage were of this same kind, in which the great nations, jealous of the greatness of a rival, well nigh destroyed themselves. In this rapid sketch, we have mentioned each of the chief civilizations of Asia and Europe up to the time of Christ. All were in their day centres comparable to those which we have seen to exist at present. One main centre lay in China, and corresponded to that of modern Japan. A second, less important and less enduring, was located in northern India. It has no modern representative unless we hold that the vogue of an esoteric Hinduism among a few people in America and Europe is a sign of the existence of a widely pervasive influence derived from an Indian centre. The third centre extended widely. Its eastern limit was on the western border of Persia. It embraced Mesopotamia, Syria, Egypt and Greece, and on its flanks included surrounding countries such as Asia Minor. Ultimately, it moved westward so that Mesopotamia and then Egypt ceased to belong to it, while Italy was included. Finally, it migrated still farther westward and also northward, until now Italy is on its southeastern border, and its main area is a great European centre of our own time. In the Western Hemisphere, only two centres of civilization seem to have existed in ancient times. One was in Peru. We should not consider it here, partially because it will come up in another connection, and partially because it failed to rise to a great height, and never succeeded in spreading its ideas very widely. Figure 48 is displayed on the following page, the shifting of the storm belt. The other ancient American civilization, that of the Mayas, is much more important. It falls into the same class with those of Eurasia. Its fertility in ideas has already been discussed. Its influence spread to other lands, and may be seen in various ruins in Mexico, and in the calendars which were employed by several races in that country. It must have lasted many centuries, for we find splendid buildings whose dates are at least 700 years apart and possibly more. Moreover, before the first of these was constructed, there must have been a long period of development during which the arts of architecture and sculpture were perfected. At the same period, the Mayas must have been so far advanced that they kept most accurate records of astronomical phenomena, for otherwise they could not have determined the length of the year with the extraordinary accuracy displayed in their calendar. In all these respects, the Maya centre resembled those of Eurasia. It differed from most of them in not leaving a successor. So much for the ancient distribution of civilization. Now for that of climatic energy. Storms, as we have seen, are the most variable of the climatic elements, and also one of the most important in their effect on human energy. Figure 48 shows the approximate distribution of storminess in the northern hemisphere at the present time. It is constructed with the North Pole in the centre to show the complete storm belt encircling the North Temperate Zone. The lands are shaded to represent 3 grades of storminess. Heavy lines indicate the centres of the main storm belt and its branches. The region of maximum storminess lies in southern Canada, north of Lake Ontario. Thence the main belt extends eastward along the St. Lawrence River to the southern edge of Newfoundland, where it is joined by a branch coming up the Atlantic coast. Then it crosses the Atlantic with a slight inclination toward the north, and before reaching Ireland, splits into 3 branches. One passes along the northern edge of Scotland, through northern Scandinavia, and thence along the Arctic coast of Europe toward Asia, where it almost dies out, and probably merges with the second or main branch. The latter splits into 2 parts which unite again. One passes through Scotland and southern Scandinavia, the other goes through southern England, follows the Baltic Sea, and then, after joining its companion, extends eastward in the latitude of Moscow for an indefinite distance into Siberia. It apparently passes entirely across Asia, but in an attenuated form. The third branch swings from the central Atlantic toward the Bay of Biscay. It becomes weakened over southern Europe, strengthened once more in the stormy Gulf of Lions, continues with great intensity in northern Italy, then loses intensity as it crosses the Bosnian Highland, and finally passes through southern Russia, where it rapidly dies out. Returning to the main belt of storminess, we find that after it has crossed Asia, it is joined in the Pacific Ocean by a branch which has been highly developed in Japan, but which weakens northward. The combined branches cross the Pacific Ocean to the American shore. Then in southern Canada and the northern United States, after crossing to the east side of the Rocky Mountains, the belt once more becomes extremely stormy. It is joined by a branch from Colorado and so completes its course back to the point of greatest intensity. Several features of Figure 48 deserve careful attention. In the first place, wherever the storms in their eastward course approach an extensive highland, they tend to be weakened or deflected, after which they may or may not recover their former intensity. This may be seen on the western side of North America, where storms are relatively rare until the Rocky Mountains have been crossed. The highlands of Western Europe are not great enough to destroy the storms, but the main belt is broken into several branches, each of which seeks to avoid the high country. The northern branch would apparently skirt the whole of Scandinavia, were it not that some unknown force prevents it from going much to the north of the Arctic Circle. The next avoids the Welsh and English highlands, crosses into the North Sea over the lowest part of England, receives an ascension of intensity, and follows a line of least resistance along the Baltic and across the plains of Russia. Ultimately, however, the vast expanse of Eurasia, especially when it becomes a high-pressure center in winter, largely overcomes the tendency of the air to move in the cyclonic fashion, and storms become rare. The third branch, which swings still farther north, is also greatly weakened when it reaches the land of southern France, but becomes very pronounced in the northern Mediterranean, only to be weakened once more by the Balkan highland. Another important feature of Figure 48 is the peculiar detached areas of high storminess in northern Italy and Japan. In the United States, two similar areas are visible on a large-scale map of storms, although they are masked in Figure 48. In both cases, they are apparently remnants of a southern or subtropical belt whose existence at times of many sunspots is described in Climatic Changes. Another belt where storminess increases greatly at times of sunspot maxima is found on the north side of the present belt. It tends to reduce the habitability of the northern parts of Europe and North America, but with that we are not now concerned. In the southern belt of increased storminess, where sunspots are numerous, the American areas move somewhat southward, become intensified, and lengthen east and west until they coalesce, forming a continuous, although very faint belt. In Eurasia, the same thing seems to happen, although the meteorological records in Asia are not yet sufficient to permit us to test it. If the American subtropical belt were intensified by the way that appears to have occurred in the past, its place of maximum storminess would probably be in the Gulf of Mexico. There the obstacles presented by the highlands of the southwestern United States and Mexico give place to the open sea and allow free play for the development of storms. A development of this subtropical storm belt seems to be a pronounced feature of the changes which now take place from sunspot minima to maxima, and would presumably be magnified if the changes were on a greater scale than those of the 11-year cycle. Hence we should infer that when the Mayas made their greatest progress, their country was blessed with a stormy area like that of the Gulf of Lions, which now does much to make northern Italy far more progressive than the southern part of the country. Under such conditions, the climate of Yucatan would have been comparatively stimulating in spite of its warmth, for during much of the year cool waves from the north would have been frequent. In Eurasia, the same principles apply with appropriate modifications because of the topography and the size of the continents. If the subtropical storm belt should be magnified in the way that seems characteristic of times of many sunspots, it would apparently reach its chief development in the places where the great civilizations of the past were located. The present Italian center would presumably move south and then expand eastward along the open Mediterranean, leaving the highlands of Asia Minor on its northern flank. It would pass over the Syrian mountains before it could not spread eastward in any other way. Possibly it would be forced a little southward so that northern Egypt and Palestine would get its full force. In the lee of the mountains, the storminess of the Syrian desert would be less than that of Syria, but by the time the storms reached Mesopotamia, they would have had an opportunity to form themselves anew, and we should expect a well-developed center. In Persia, judging by what happens today, this would be weakened but not destroyed. then the Great Plains in northern India would permit the storms to gather once more in a centre corresponding to the faint one of today. That would probably be the end of any distinct belt for 1,000 miles, for the eastern Himalayas and the mountains of western China interpose so tremendous a barrier that we should not expect the Japanese centre, even though it moved southward and westward, to coalesce with the Italian. The plains of central China, especially the Yangtze Valley, would be the place where the present Japanese centre would be most highly developed, provided it suffered changes corresponding to those indicated in the corresponding American area. Japan, on the other hand, would presumably be less stormy than now, for the storm tracks would be pushed southward and oceanward. If these things actually occurred at the times indicated by our Californian curve, the countries which now stand highest in civilization would then have had a long cold winter, ending in a very stormy spring and followed by a cool damp summer. The stimulating qualities of the climate would have been less than now, and the possibilities of agriculture, especially in such places as Germany, would have been much diminished. In the countries like Greece, where civilization was then at its highest, on the contrary, the number of storms and the duration of the stormy period would have been decidedly greater than now. The rainfall also would have been greater, so that agriculture would have been favoured. More important than this, however, would have been the higher degree of climatic stimulus because of frequent changes of temperature. To apply the matter correctly, Lower Egypt has an average temperature of about 80 Celsius during July, and Mesopotamia and northern India are even hotter. 3,000 years ago, the heat was probably almost equally intense at certain periods, although somewhat less extreme on an average, and by no means so uniform. All the summers were probably hotter than was the summer of 1911 in the northeastern United States. That summer in some localities was the most severe for a century, yet its effect on work was no worse than that of an ordinary winter. In Mesopotamia and Egypt, summers of that kind doubtless made people slow and inert. They were probably not so bad as the present summers, however, for although no appreciable quantity of rain may have fallen, a large number of storms must have passed over regions not far to the north. Such storms would stir the air and bring fresh breezes. Everyone knows that in hot weather, a change in the wind, even without rain, is most refreshing. When the summer was over, the storm belt, according to our hypothesis, would migrate southward in its normal fashion, and soon Egypt and Mesopotamia would be swept by storm after storm. During the early fall and late spring, conditions would be about as they are in the homes of our Connecticut factory operatives during cool summers such as 1912 or 1913. For the intervening 5 or 6 months, the average temperature would range from about 55 degrees to 65 degrees Fahrenheit. There would be a constant succession of cool waves, and the conditions would be almost ideal for great physical activity. Thus, even though the summers were distinctly bad, the total debilitating effect would be little greater than that of summer and winter combined in Connecticut. In Greece and Italy, with their more favourable mean temperature, conditions would be still better than in Egypt or Mesopotamia. In the same way, favourable conditions appear to have prevailed in each of the great countries of the past at the time when it made its most rapid progress. The two phases of our climatic hypothesis are now before us. In point of time, though not of presentation in this book, the first step was a study of the climate of the past. 10 years of work along this line had led to the hypothesis of pulsatory changes, and finally to the idea that the changes consisted primarily of a shifting of the belt of storms. After this conclusion had been reached, a wholly independent investigation of the effect of present climatic conditions upon human activity led to 2 conclusions, neither of which was anticipated. One was that in the eastern United States, the cold weather of winter is as bad for work as for health, while only the warmest summers cause any serious curtailment of work. The other was that storminess and variability from day to day are of great importance. On the basis of these 2 conclusions, it at once becomes evident that the stimulating effect of climate in the same latitude and having the same kind of seasonal changes may be very different. It also becomes clear that the distribution of civilization at the present time closely resembles that of climatic energy. From this the next step is naturally back to our previous conclusion that changes of climate in the past have consisted largely of variations in the location of the storm belt. If this is so, evidently the amount of climatic stimulus must have varied correspondingly. Thus we are led to the final conclusion that, not only at present, but also in the past, no nation has risen to the highest grade of civilization except in regions where the climatic stimulus is great. This statement sums up our entire hypothesis. It seems to be the inevitable result of the facts that are before us. Other factors, to be sure, are also highly important. One of them is natural selection, a subject so much neglected in its bearing on human history that I made it the theme of a book on the character of races, which might almost be considered the continuation of the present book. The development of human culture and its spread from land to land is, I believe, a third factor quite as important as either of the others. Yet unless we have gone wholly astray, the surprising way in which independent lines of investigation dovetail into one another seems to indicate that a favorable climate is one of the essential conditions of high civilization. End of section 16. Section 17 of Civilization and Climate by Ellsworth Huntington. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information on a volunteer, please visit LibriVox.org. Recorded by Leon Harvey. Chapter 17. Aboriginal America and Modern Australia. Having seen that the objections to climatic pulsations are largely based upon misapprehensions, let us now take up certain other objections to our hypothesis of the relation between civilization and climate. How about the high civilizations of the past in places outside the storm belt, the objector may say? Yucatan and Guatemala may possibly have been stormy, but surely not Peru, Southern Arabia, Rhodesia, Ceylon, Java, and Indochina. Yet in the past these have boasted a civilization much higher than now prevails there. The force of this objection must frankly be admitted. The ruins of Indochina and northern Ceylon, and any other traces of high civilization located in tropical lowlands, with the exception of Yucatan and Guatemala, appear to have little relation to our hypothesis. Nevertheless, they do not require a modification of it. More probably they represent the triumph of other factors over the climatic factor. They apparently indicate one or both of two things. First, they appear to represent a temporary wave of progress due to the incursion of higher cultures from more favoured regions such as India or the neighbouring highlands. If that is so, they possess no more significance for our climatic hypothesis than do the railroads and other innovations introduced by Europeans within the past few decades. In addition to this, they probably indicate that prolonged migration or other difficult circumstances gave rise to pronounced natural selection. Thus the people who built the wonderful ruins of Java and Indochina, as I have shown in the character of races, and perhaps those of Ceylon, Peru, Southern Arabia, and Rhodesia, had presumably been gradually sifted so that only a very competent remnant was left. Under such circumstances, the effects of climate seem to be overcome for a while, but reassert themselves in due time as the strong inheritance becomes diluted or weakened. Another possibility is that the small and insignificant belt of storms which now traverses northern India may have been intensified in the past. In eastern India, because of the barrier of great mountains, a branch may have swung southeast around the lofty Burmese mountains to the neck of the Malay Peninsula, and then north to join the storm belt which now traverses Japan. In crossing the plains of Cambodia, where the most remarkable ruins of southeastern Asia are located, it may have developed a distinct storm centre like that of northern Italy. The conditions would resemble those inferred in Yucatan and Guatemala, although perhaps less favourable because cold waves would be checked by the Great Mountains. Indochina and Central America lie in the same relative position in their respective continents, a fact which may have considerable significance. I do not, however, attach much importance to what has just been said about storms in southeastern Asia, for it is pure supposition. Other conditions, such as racial selection and spread of the highly developed culture of India, seem competent to explain a large part of the sudden rise of these regions, while the tropical climate largely explains their rapid decline. Yemen, Rhodesia, and Peru furnish admirable examples of comparatively high civilizations which developed in tropical highlands and lasted for a considerable period without much intercourse with regions of higher culture. They lie at such an altitude that the mean temperature never departs far from the optimum. For instance, at Fontaine, near the Rhodesian ruins of Zimbabwe, the figures are 54 degrees Fahrenheit in June and 71 degrees in November. For Yemen, none are available, but judging by the altitude, its temperature is probably slightly lower than that of Rhodesia. Even at Cuzco, the elevated capital of Old Peru, although the monthly mean temperature, according to Han, ranges from 46 degrees in July to 52 degrees in November, the conditions are very stimulating compared with tropical lowlands. The temperature is too low for comfort, to be sure, but it is of the type that appears to stimulate mental activity. If immigrants possessed of an unusually high inheritance, either by reason of strenuous natural selection or of actual biological mutations, should come to such a region, the relatively stimulating quality of the climate would combine with their innate ability to enable them speedily to dominate the indigenous population and to develop many new ideas. Yet we should not expect such a civilization to endure so long or rise so high as those in more favored regions. The people would tend to exhaust themselves, for they would never experience any restful changes of seasons and would be stimulated at all times. To revert to an earlier illustration, their condition would be like that of a horse, which is always driven at full speed. Such a horse might go rapidly for a while, but would wear himself out at an age when carefully driven animals were in their prime. The constant nervous excitation produced by such a climate in immigrants from a less favourable region would induce both progress and decay. The most nervous people would die out, partially because they would exert themselves too strenuously, and partially because nervousness is a potent agency in reducing the birth rate. Self-control would also be weakened, thus leading to vice and excess of various kinds. The chewing of the coca leaf, a narcotic stimulant, which is thought by many people to be one great cause of the backwardness of Peru today, would harm the high-strung, competent parts of the community more than the dull, apathetic ones. In various other ways, such a climate as that of Peru would be stimulating for a while, but would lead to exhaustion sooner than one where greater variability prevails. We now come to perhaps the strongest objection, aside from the question of the reality of climatic changes. A large part of this book is being concerned with the United States. The present status of that country is one of the main foundations which originally led to the framing of our hypothesis. Yet before the coming of the white man, savagery prevailed where civilization is now highest. In the 16th century, the climate must have been approximately the same as that of today, so that no explanation can be sought along that line. It is true, to be sure, that before the coming of the white man, the most energetic and capable of the Indian tribes lived in what is now the northeastern United States. Dixon, for example, in The Racial History of Man, says that the Iroquois and southern Algonquin tribes were among the first of those north of Mexico in ability and prowess. Many other authorities speak in similar fashion. Whistler, in Man and Culture, reproduces a map by Moorhead, showing that the region from Illinois to New York was an important center of culture from which many new types of stone ornaments spread in all directions. In spite of this, we are still confronted by the stubborn fact that before the coming of the white man, no great civilization had ever developed in the northern United States, while Mexico, although far inferior climatically, harbored a relatively civilized population. At first this seems to prove that our hypothesis cannot be correct. Yet more careful examination leads to a different conclusion. The distribution of civilization in pre-Columbian America merely brings out a fact which I have again and again tried to emphasize, although climate is highly important. There are other factors whose weight is equally great. Even if our hypothesis be fully accepted, no less importance will thereby attach to the other great factors which condition the events of history. Because a man dies for lack of air, we do not think that air is more essential than food, drink, warmth, the circulation of the blood, the reproduction of the species, the ravages of virulent germs, and many other conditions. So it is in history. Even if our climatic ideas are correct, it will still be true that the ordinary events of the historical record are due to the differing traits of races, the force of economic pressure, the ambition of kings, the intrigues of statesmen, the zeal of religion, the jealousy of races, the rise of men of genius, the evolution of new political or social institutions, and other similar circumstances. Yet a comprehension of the part played by the climatic factor will enable us to explain some of the many events which hitherto have puzzled us. Not all will be thus explained, for others must wait until the action of some other set of as yet unknown conditions is understood. In the present case, I believe that the explanation of the failure of the Indians to rise to a level equal to that of the people of the Old World is found partially in inheritance, and partially in the history of their culture. I shall not dwell on inheritance, although it may be of great importance. In The Red Man's Continent, and more fully the character of races, I have set forth the hypothesis that the Aboriginal Americans, during their migration from Asia by way of Siberia and Alaska, suffered an adverse natural selection due to the severe Arctic environment. This may have given them a permanent handicap compared with the people of Europe and Western Asia, among whom the selection was peculiarly favourable. Among the Americans, so it seems, there was a premium on powers of passive resistance and endurance. Moreover, among all hunting tribes, there is a premium upon the ability to make sudden but not prolonged efforts, such as are involved in hunting and raiding. Only when agriculture is introduced does a new type of natural selection put a premium upon such qualities as steady industry. Among hunting tribes, moreover, the acquisitive temperament which stores up food or other property for periods of want is not nearly so great an advantage, and hence so strong a selective factor as among those who practice agriculture. Because the wandering hunter cannot transport much property, he loses the biological advantage which causes the people who have a careful, thrifty spirit to have a greater chance of survival than have the careless and unthrifty. Turning now to the cultural side of early America, at least two great factors appear to have imposed a tremendous handicap upon the Indians of the northeastern United States. One is the absence of tools of iron, and the other the lack of beasts of burden. These, in conjunction with the type of vegetation, offers such hindrance that the Indians could probably never have developed a very high civilization, even if they had been as competent as the races of Europe. The discovery of the use of iron depends on the coincidence of three conditions whose occurrence is almost accidental. One is the birth of a man with sufficient inventive genius to devise a way of obtaining the metal from rocky ores. The second is the occurrence of ores and other necessary materials within easy reach of such a man. The third is that the genius must be so relieved from the fear of enemies, the danger of starvation, and the ravages of disease, that he has both time and strength to elaborate his idea. The combination of these three fortunate circumstances never occurred in America. Although a little native copper was used, we have no assurance that the ore was ever smelted in any large amounts. It certainly never was used to any great extent. Iron, except a few bits from meteorites, was absolutely unknown. Hence, through no fault of their own, the original Americans were dependent upon such tools as they could fashion from flint, obsidian, and other stones, or from bones, shells, wood, and similar materials. We are so accustomed to iron tools that we scarcely realize their immense importance. Consider their effect upon agriculture. Go into a virgin forest with its labyrinth of trees. Imagine the task of cutting them down with a stone hatchet. The mere physical labour is such that none but people of high energy would ever attempt it. An easier way is to girdle the trees, cutting off the bark in a circle and then leaving them to dry until they can be burned. Even that, however, is a long process. In the moister parts of the world, its difficulty is greatly increased by the fact that while the trees are becoming dry enough to burn, new vegetation is rapidly growing. In many tropical regions, as we have already seen, the clearing of the forests is scarcely feasible even today. In temperate forests, the difficulties are not so great, but they are practically insurmountable from the standpoint of a savage who has never known the meaning of hard, steady work. In the hunting stage, a man may follow the trail until he falls from exhaustion, but that does not give him the power to wield a stone axe by day after day upon stubborn trees. Hence, if agriculture is to be practiced by primitive people, it must originate in regions where there are no forests. The vegetation must be such that the primitive savage, with his hands or with a stick or stone, can easily grub it up, or else it must be so scanty that it would not interfere with his crops. Anyone who has seen the agriculture practiced by people who are just emerging from some other mode of making a living knows that the fields are sown in the spring and then generally left untended until the time of harvest. Since the people are not yet able to get their living entirely from the crops, which is always the case during the transition period, they must perforce carry on their old occupations while the crops are growing. Hence the weeds are allowed to grow as freely as the grain. In a dry climate, where the natural growth consists only of bunchy grasses or low bushy weeds which grow apart from one another and can easily be pulled up with the hands before the next sowing, this does little harm. In wetter regions, such as the forested areas, the weeds are much more difficult to eradicate. The reader has probably noticed that I have said nothing about grasslands. The reason is that primitive people never attempt to cultivate them. If grass covers the entire ground and forms what we commonly call sod, crops cannot be raised in it. The dry grass may be burned off in the early spring and seeds may be dropped in holes punched with a sharp stick, but no crop will be reaped. The roots of the grass are not killed. The new blades shoot up at once, and by the time the seeds begin to sprout, are so high as to strangle them. The primitive savage who has no iron tools cannot possibly dig up the sod. Even if he has such tools, the laboriousness of the task bans it as a practical method of making a living. If anyone doubts this, let him spade up a turfy spot 10 feet in diameter, then let him calculate how many days he would have to dig in order to make a living for himself and his family by sowing grain. Let him also determine how a primitive savage who had to do this task would support himself and his children while he was digging before he could get a first crop. Finally, remember that the savage had no good spade to help him, but only a clumsy, heavy stone set in a handle, a brittle bone, or a piece of wood rudely shaped into a flat implement. I have emphasized the difficulties of grassland because they apply directly to the problem of civilization among the Indians. The part of North America which is highly stimulating climatically is covered either with grass of the prairie and Great Plains type or with temperate forest. It is universally recognized that a high state of civilization is impossible unless it is based on agriculture. Otherwise, people must wander all the time. They cannot accumulate the appliances which are essential even to the lowest real civilization. They are not attached to the soil, and thus have no incentive to improve a particular tract. If they possess domestic animals, the case is better, for these foster the sense of ownership and various other feelings which serve as uplifting influences. In North America, no domestic animals except the dog and the turkey were known to the Aborigines. This was not the fault of the Indians. The horse and camel families were then extinct in North America. The bison was the only animal, the ox family, with which the Indians came in contact. It was too large and fierce to be domesticated. The mountain sheep might possibly have been tamed, but it is very wild. Its habitat is the barren mountains and is too small to plough sod. Even if the Indians had been familiar with the idea of taming beasts of burden, they could not have achieved any important success. Without beasts of burden, ploughing is impossible. Unless the ground is ploughed, grasslands, as we have seen, cannot be cultivated. Therefore, civilization could not flourish in the grassy plains in North America before the coming of the white man. A few highly favoured spots, such as river flat plains where the grass grows in bunches and does not form turf, were cultivated, but the areas of that kind were too small and scattered to give rise to any widespread progress. They were exposed to the ravages of Indians who had not yet learned the value of permanent abodes and individual property, true primary requisites of civilization. The people who lived upon them were swamped in the flood of surrounding savagery. Moreover, the places which they were able to cultivate were subject to floods and other disasters, so that the cultivators were often forced to rely on the chase. Then again, without iron tools or beasts of burden, a man cannot cultivate a large area because the task is so great. Therefore the crops were likely to be insufficient to support the family throughout the year, even when the harvest was good. The only recourse was the chase. In Asia, people who were in such circumstances might rely on domestic animals, but not in America. Hence it was practically impossible for the Indians of the grassy plains to get away from the savage life of the hunter. In the forests which covered all the eastern states, conditions were scarcely better. A man might girdle enough trees and cut enough brush to make a small field. When the wood was dry, he might burn it and obtain a crop of corn. While it was maturing, he and his family would make a living by hunting and fishing. The crop would support them through the winter, but it is extremely doubtful whether they would ever cease to regard hunting as a main source of livelihood. The reason is this. The first crop on a burned piece of forest land in the eastern United States meets with little difficulty. For the second crop, it is necessary to cut down and burn the weeds and bushes that have grown up during the preceding summer. Remember that the savage has no iron hoe. His seeds are planted haphazard here and there among the stumps, and he cannot tend his garden while it is growing, but must go off and hunt. When he cuts the bushes and weeds the second spring, he does not root up the grass. He has no spade with which to dig it up, and no ox or donkey to draw a plough. If he takes good care of his field, he soon finds that he has a meadow of tough sod on his hands. If he neglects it, he has a few acres of bushes. In either case, if he would make a living from agriculture, he must go through the labour of clearing a new field. Meanwhile, he still must be a nomadic hunter. He takes no great pride in his field. He does not care to improve it. He rarely builds a permanent house beside it. Why should he? Next year, or at most in 2 or 3 years, he must build another. In a few specially favoured spots, the conditions may be such that agriculture is not quite so difficult. In the north, where the stimulating climate is found, such spots are few and dull. The chief reason for wonder is that the Indians had enough energy to cultivate any crops whatever. In the southern states, the grass does not form so dense a sod as in the north, but even there the difficulties are great. Yet a beginning had been made, and the civilized nations, including the Cherokees and others, lived in permanent villages and practiced agriculture as their main means of getting a living. If they had had iron tools and oxen, America today might be filled with highly civilized Indians instead of Anglo-Saxons and other Europeans. Thus, although an appropriate physical environment and a strong mental inheritance may be essential to the rise of a great civilization, these two conditions may be, at their best, yet savagery may prevail because certain cultural essentials such as iron or beasts of burden are lacking. From this example of people who lived in one of the finest climates but failed to make progress, let us turn to a case of quite the opposite type. The white settlers in northern Australia live in an almost tropical climate, which is poor as climates are rated in this book. Nevertheless, they maintain a high civilization and believe that they can raise that civilization still higher. They are sometimes cited as proof that climate in itself has little or no effect on health, and that high civilizations may arise regardless of climate. Nowhere else in all the world does so large a body of white people, chiefly of British descent, live within the tropics. Some 200,000 upon whom the sun shines vertically at certain seasons are doing all the work of life with their own hands. The men work in the fields, on the docks, and among the cattle and sheep. They cut sugar cane under the tropical sun, but their health does not appear to suffer. The women work in intolerably hot kitchens, often among swarms of pestiferous flies, and in rooms where the blazing sun on the unsealed roof joins with the kitchen fire to produce an appalling temperature. Yet their death rate is phenomenally low, and they give birth to unusually healthy children. In fact, the death rate in tropical Australia among all classes of the population is one of the lowest in the world. In order to make fair comparisons between regions where the proportion of young people is unusually large and those where the proportion is smaller, let us use what is known as a standard population. On this basis, which is universally accepted as the fairest yet devised, the death rate in Queensland, the most northerly state of Australia, was 12.1 during the normal years before the World War. Compare this with 10.5 in New Zealand, which is the healthiest country in the world, 12.4 in Denmark, the healthiest country in Europe, 15.2 in England, and 16.1 in the part of the United States then included in the registration area. In addition to this, the medical examinations of young men who enlisted during the World War showed that the Queenslanders, even the tropical Queenslanders, were certainly not less robust and vigorous than those from other parts of Australia, and much more so than we, the similar men of England. Moreover, children of the second and third generation have been born in tropical Australia and are fine, active specimens. It seems to be proved beyond question that the white man can live in tropical Australia, that he can enjoy good health, and that white children of high vitality can be born there, live there all their lives, and become the parents of other children who seem to be equally healthy. These facts are highly important and encouraging. They hold out a definite and not unreasonable hope that someday a branch of the white race may live permanently within the tropics and carry on all the work of life without the help of any coloured race. The fond hope of the Australians that they may permanently be a white Australia is by no means without foundation. Does this invalidate our hypothesis of the relation between climate and civilization? Let us see what the facts really are. The Australians are so much interested in the problem of a white Australia that their Commonwealth statistician has issued a special bulletin on tropical Australia. He has also kindly placed at my disposal certain other unpolished data. I am afraid that I shall seem to the Australians to use these data in a way that they will not like. But after all, what they really want is the truth. I am perhaps as keen as they are for a white Australia. Not only do I want to see my own race show its ability to conquer every kind of environment, but I am extremely anxious to see a conclusive tropical experiment on a large scale. I want to know beyond question whether white men can live permanently in a tropical country, conquer the diseases, and make progress without the help or hindrance of any coloured race. Tropical Australia affords by far the greatest opportunity for such an experiment. It is peculiarly free from tropical diseases, and there seems to be no good reason why it should fail to be kept free. Its coloured inhabitants are few in number, and most of them belong to the Aboriginal Australian race, which seems to be dying out, and which is quite easily kept separate from the whites. And it is under a government which is disposed to do everything possible to make the experiment a success. I would give a great deal to be able to see what kind of people live in tropical Australia 100 or 200 years hence. But if the tropical Australians of the next few generations are to succeed, indeed, if they are to avoid great misery perhaps, they must know exactly what they are facing. To let the dream of a white Australia and the hope of developing a great country blind ourselves to the facts is sure to produce evil. We have already seen how extraordinarily low is the death rate of Queensland. If we take only the part of Australia that lies within the tropics, we find that during the years 1920, 1921, and 1922, the following remarkable conditions prevailed. Table is displayed on the page comparing the birth rate per 1,000 women aged 15 to 44, infant death rate per 1,000 births, female death rate per 1,000 births, and male death rate per 1,000 persons. All these are compared to Australia as a whole, non-tropical Queensland, and tropical Queensland. In the first three of these conditions, non-tropical Queensland is more healthful and vigorous than Australia as a whole, while tropical Queensland is still more healthful and vigorous. In other words, the white women in the tropical part of Queensland enjoy remarkably good health. They give birth to a relatively large number of children, and those children are uncommonly healthy. What more could one ask as a recommendation of the climate of a country? The men, to be sure, have a much higher death rate than those of other parts of Australia, but from the standpoint of the future of the race, they are much less important than the women and children. The Census Bulletin on Tropical Australia attempts to explain the differences between the death rates of men and women as follows. As both sexes should be affected by tropical conditions to something approaching an equal degree, it is apparent that there must be some cause, apart from purely tropical attributes, to account for the unfavourable male death rate. The great excess of men over women in the tropical population suggests that there are many men living under primitive conditions. Under such circumstances, there is too frequently a disregard for precautionary sanitary measures, and a reckless neglect of the first symptoms of disease. There are other cases too, where it is impossible by reason of great distance to procure medical or surgical assistance. It would appear to be mainly to such circumstances as these that the high male death rate in the tropical parts of Queensland is due. Otherwise, a great difference between the mortality of the sexes is not readily explained. There may be some truth in this, for in tropical Queensland, there were in 1921 about 133 men for every 100 women. Nevertheless, it must be a minor factor. Not only is it generally believed that frontier life is far more healthful than city life, but much more than half the men of tropical Australia, as well as a still larger proportion of the women, live in the towns, where there are physicians and often hospitals. Moreover, as appears in the last sentence of the quotation from the Census Bulletin, the isolation of the men on the frontier is appealed to as an explanation of their high death rate only in the absence of any other reasonable cause. There is, however, another reasonable cause of the low death rate among the women, a cause which the census recognizes as applying to the population as a whole, but does not recognize as applying to women more than to men. That cause is natural selection. As a bulletin on tropical Australia puts it, perhaps the most potent influence in causing the low death rate of tropical Australia has been that sort of natural selection which operates in the settlement of all new territories. It may be stated, as a rule, that only the bolder and more virile of any community will venture on the role of pioneer in new unsettled country, and when such a new country is a tropical one to which popular opinion generally ascribes more than usual discomfort, the physical standard of the settlers is probably more than ordinarily high. The logical corollary of this statement is that among women the selection of those who are physically fit is much stronger than among men. Young men rarely think of their health. Young women think of theirs a great deal, and between men and women, 30 to 50 years of age, the contrast is still greater. That the women distribute themselves over tropical Australia in a different way from the men is obvious from the fact that in the tropical part of Western Australia, which is the most inaccessible and undeveloped, there were in 1921 about 524 men for every 100 women. In the tropical part of the Northern Territory, which is not quite so remote, the number of men per 100 women was 271. In tropical Queensland, which is still better, 133, and in Townsville, one of the two largest cities, 108. On the other hand, in Rockhampton, which is the largest city of tropical Australia, and also the one located farther south and hence in the least enervating climate so far as the coast is concerned, the number of men per 100 women was only 94. In other words, the women became relatively more and more numerous as one gets away from two conditions, namely the frontier and a truly tropical climate. But this does not end the matter. The women tend not only to concentrate in the best parts of tropical Queensland, but to remain out of tropical Australia altogether, or else to go away after once getting there. This is evident from the fact that among children up to the age of about 15 years, the relative number of boys and girls are normal. From that age onward, the number of men in proportion to women steadily increases. For example, among young people 15 to 19 years of age, there are 110 boys for 100 girls. But at the age of 30 to 34 years, this proportion has increased to 155, while between the ages of 65 to 69 it rises to 249. Yet in the normal population of this latter age, there are only about 89 men for 100 women. Whereas such conditions prevail, it needs no demonstration to prove that the women either have never come to tropical Australia or have come and gone away. In either case, it is certain that a large number of the women are missing because of their health. One has only to talk with those who are still there, or with the Australian physicians, to learn how often the men like the climate while the women dislike it, and how often the health of the wife or daughter causes a family either to move away or to be temporarily separated. The women frequently go to the cooler south, while the men stay in the tropical north. Often the whole family moves away from tropical Australia because the women do not like the climate. The selective process which causes the men in a new tropical country to be especially strong and vigorous works still more effectively in causing the women and hence the children to be even more markedly of the same type. The low death rate in tropical Australia does not indicate that the climate is favourable, but merely that natural selection has been unusually vigorous. Now look at the matter in still another way. Here is a little table showing the death rate among persons from 15 to 49 years of age in the 3 Australian states of Victoria, which is the most southerly and hence the coolest. New South Wales, which also lies quite far to the south, and Queensland, which lies so far to the north that a quarter of its population is within the tropics. The death rate has been calculated according to a standard population, so as to eliminate any differences arising from the fact that there are more young people in one section than in another. The residents of the 3 states have been divided according to their birthplace, the great majority of Australians being natives of one of the 3 states, or else of England or Scotland. A table is displayed on the page, death rates per standard population at age 15 to 49 years in Victoria, New South Wales and Queensland, according to places of birth and residence, 1920, 1921 and 1922. The significant fact about the table is this. No matter whether they reside in Victoria, New South Wales or Queensland, the people who were born in Queensland have a higher death rate than those born in the other 2 Australian states or in England or Scotland. If we combine the figures in the last column, it appears that the residents of Australia who were born in Victoria, England, Scotland and New South Wales have an average death rate of 4.01. On the other hand, the death rate among the people born in Queensland, no matter where they reside, is 4.66, or approximately 15% greater. The high death rate of Queenslanders in Victoria or New South Wales may be due to the fact that Queenslanders whose health is impaired migrate to those cooler states. But in that case, the born Queenslanders who remain in Queensland ought to be stronger than the average, and their death rate should be correspondingly low. On the contrary, their death rate exceeds that of the people born in any of the other 4 regions. In other words, although the people whose residence is in Queensland have a very low death rate, those who were born there have a high death rate. Those who reside there were largely born elsewhere, and have had the advantage of a strenuous, though unconscious process of natural selection. Those who were born there are more nearly like the average of their race than were their selected parents, for that is the universal biological rule, and they show what seems to be the effect of the tropical climate. Another significant fact in this connection is the number of children per family. We have already seen that in proportion to the number of women between 15 and 44 years of age, the birth rate in Queensland is higher compared with the rest of Australia, and is still higher in the tropical sections. That apparently is due to the fact that the weaker women either leave their husbands in the north and go to the cooler south, or else persuade their husbands to move away. Those who remain are strong and vigorous and have many children, but when we examine the number of children born to persons who are Queenslanders by birth, regardless of what part of Australia they later reside in, we find quite a different condition. The following figures show the number of children born to persons whose own birthplace was in various regions and who died in Australia during the year 1921. Germany 6.3, Ireland 5.8, Scotland 5.7, England 5.4, New South Wales 5.1, Tasmania 5.0, South Australia 4.5, Victoria 4.1, Queensland 3.8. The high birth rate among the foreign-born Australians is normal. There is nothing surprising about the differences among the birth rates of people born in New South Wales, Tasmania and South Australia. The low rate among natives of Victoria, however, is not easily explained unless it be that Victoria, more than any of the other states, has lost the pioneer frontier quality and hence has a relatively low birth rate which is normal in all regions. For Queensland, no such explanation can be advanced, for that state has more of the pioneer quality than any other in our table. The most probable explanation is that the birth rate is low for the same reason that the death rate is high. Both conditions indicate that in spite of the strong selective process to which their parents were subjected, the native-born whites of Queensland display qualities which suggest a lower degree of physical stamina than prevails among the other Australians, and which seem to be the result of the tropical climate. If this is the case, it strongly bears out the general thesis of this book. Even the part of Australia where the tropical Queenslanders live is not tropical in the ordinary sense. The climate is indeed quite trying by reason of the length and monotony of the summer, and because the dampness near the coast and the great heat in the interior. There is, however, a real winter in the regions where most of the tropical Queenslanders actually live. For 2 or 3 months, the temperature almost everywhere falls to between 40 and 50 degrees during the night, while in the highlands there is often frost. If a climate so mildly tropical can produce such clear results, it seems probable that a thoroughly tropical climate may handicap the white man to a far greater extent. Nevertheless, I do not despair of the ultimate triumph of the white man over the tropics, and much less do I despair of a white Australia. The process of selection for climate has never been really tested. All that has happened thus far has been purely fortuitous. The hope of the future, I believe, lies in an orderly and far-sighted selection of the right types of people, as well as in the further development of tropical medicine and hygiene. But suppose a matter of health should be taken care of to such a degree that the white race could live, thrive, and permanently reproduce itself within the tropics. Would civilization there advance as in cooler regions? I doubt it. In the first place, the most casual observation in any tropical region shows that the white man, as well as the coloured, does not act with so much energy as in cooler climates. No matter how good his health, he is forced to work comparatively slowly or for short hours, or else he exhausts himself. It was a Queensland sheep selector, the owner of 20 or 30,000 animals, who first called my attention to the Queensland walk. We were watching a man who slowly sauntered from the hotel to the railroad station. That's the way we all walk after we've been here in tropical Australia a while. Not only do people almost of necessity walk that way, but they often work that way. In tropical Australia, just as in other tropical countries, all sorts of things are allowed to lie at loose ends much more than among the same kind of people in more stimulating climates. The new point which I wish to make in regard to Australia is that natural selection works against a tropical country, and is working that way even more now than in the past. This sounds like a contradiction to what has just been said about the strong physique of the Queenslanders and the possibility of building up a genuine tropical race of white men. But there is no contradiction. I am talking now about the qualities which lead to progress of civilization. As one goes about in tropical countries, and especially in Australia, one soon finds that the people who complain most about the climate are, first, the women, and then the professional men. In other words, it is the people whose work keeps them indoors. The rancher, planter, promoter, real estate agent, cane cutter, and dock labourer do not seem to feel the heat half as much as do the minister, lawyer, doctor, engineer, and teacher. These intellectual workers may and do adapt themselves to the climate and achieve results of high importance. Nevertheless, almost without exception, they are on the watch for a chance to get away to a pleasanter and more stimulating climate. Many of them are ready to accept smaller salaries for the sake of being in an atmosphere which is physically and mentally more stimulating. In this fact, perhaps, lies one of the greatest hindrances to the development of high civilization in countries with unfavourable climates. We have already seen this selective process at work in the Bahamas. It is very active in tropical Australia, and it is energetically at work in the southern United States. The greater the wealth of a country, the greater its intellectual and physical activity, the better its transportation system, and the more fully it picks out and educates all its bright sons and daughters, the more likely those same sons and daughters are to move away from the unstimulating environments into those which most fully give scope to all their faculties. In this respect, as in so many others, each new advance of knowledge, each new step in the mastery of nature gives greater power to the regions whose climatic advantages already help them to be leaders. To him that hath shall be given, and from him that hath not shall be taken away, even that which he seemeth to have. End of section 17. Section 18 of Civilization and Climate by Ellsworth Huntington. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recorded by Leon Harvey. Chapter 18. The Climatic Hypothesis of Civilization. We now come to the final step in our study of the hypothesis that climate ranks with racial inheritance and cultural development as one of the three great factors in determining the conditions of civilization. As to which of the three is most important, it is impossible to say. The absence of good conditions in any one respect may hold a country back, while all three must rise to a high level if a race is to reach the highest plane of civilization. In this last chapter, I propose to consider one final objection to the general hypothesis that climate has been a determining factor in the geographical distribution of human progress. That objection is that it seems impossible that changes of climate can have exerted so great an influence as is claimed in this book. The first and most obvious effects of climatic changes are economic. We have said little about them in this book because they have been fully discussed in the publications numbered 2, 3, 7, 8, 10, 12, 14, 15, 17, and 22 in the list at the end of the preface. A single concrete case will illustrate the matter. In 1909 I visited Palestine. That happened to be an unusually dry year. During the months of April and May, I rode scores of miles on horseback amid fields of wheat that showed merely a few scanty stalks 3 to 6 inches high. In Beersheba, I talked with a number of men who had tried to raise grain during a few preceding years of good rainfall, but were financially ruined by the drought of 1909. In Moab, many villages which had been recently reoccupied under the stimulus of the building of the Mecca Railroad were being abandoned. The inhabitants were moving back across the Jordan to the better watered parts of the country. Coincident with this migration of the agricultural people away from the drier areas along the borders of the desert, there were a corresponding outward movement of the Arabs from the desert. Because of the drought, the great tribes from the interior of the Arabian desert swarmed over the grain fields on the eastern and southern border of Palestine and let their camels eat up the few scattered stalks of wheat that had survived. The poor villagers shot at the Arabs when they first appeared, then ran in terror to the villages. Soldiers were sent to stop the Arabs, but in vain. The quarrels between the Arabs and the peasants resulted in so many gunshot wounds that Dr. Patterson of the Presbyterian Hospital at Hebron was swamped with patients. I myself was in an Arab encampment when it was raided by other Arabs. I was held up and my money demanded at another time, and I came in personal contact with raiding parties on 3 other occasions. Thus a single year of drought brought distress upon all kinds of people. It caused migrations among these of the settled population who occupied the least favoured locations. It set the desert tribes in motion, and it spread poverty, hunger, raids, war, wounds, and death on every side. Consider now what must have happened when Palestine changed from a condition of relatively abundant rainfall in the early part of the Christian era to a condition drier than that of today in the 7th century. Remember that at certain periods, such as the 3rd century BC and the beginning of the 7th century AD, a relatively rapid change took place. Remember too that Professor Butler of Princeton has been quoted above as saying that an area of 20,000 square miles of land on the eastern border of Syria is now too dry for permanent human occupation, but was once more thickly populated than any area of similar dimensions in England or in the United States outside the immediate vicinity of the large modern cities. This must mean a population of at least 100 per square mile or 2 million people. South of the region described by Butler, there are additional thousands of square miles of similar dry land full of ruins, while further east, in northern Mesopotamia, in the region described above as clay, the same is true. Suppose for the sake of argument that 3 million people lived in these areas, which are now too dry to be occupied. When a diminution of rainfall gradually rendered this great multitude homeless, a corresponding reduction must have taken place in the productivity of the areas which are still inhabited. Palestine today contains about 650,000 people and Syria about 3 million. There is abundant evidence that when the outlying districts were habitable, the population of the still habitable areas was much greater than now. It seems then that at the time of Christ, or at least some 400 years earlier, there may have been over 6 million people in these areas of Palestine and Syria. Then what happened? Regions which had been supporting perhaps 9 million people in comparative comfort were so stricken by drought that the homes of about 3 million became almost uninhabitable, while the productivity of the remainder was reduced nearly half. Thus only about 3.5 million people could live where 9 million had lived before. Of course, so great a decline did not occur in a single generation or even a single century, but a reduction in the capacity of the country from 9 million to 8 million persons would produce misery, famine, death, migration, raids, wars, and misgovernment to an almost incredible degree. Then would follow a few decades or scores of years of recovery, and again a reduction in the capacity of the country to support people. Each such blow must have dragged civilization downward, and the resultant chaos of the Dark Ages is by no means surprising. The misery and discontent due to prolonged poor crops tend to make people unstable, not only politically, but in other ways. Religious bitterness is almost sure to increase under such conditions. A portion of the community attributes its poverty to the fact that there is something wrong with the present form of religion. The rest are inclined to attribute their distress to the wickedness of their neighbours who decry the old religion. Thus bitterness and persecution are engendered. Those who become discontented with the old religion are prone to accept the new ideas propounded by religious enthusiasts. This seems to have been the case when Muhammad made his appeal to the Arabs after the prolonged period of increasing aridity which culminated with a sudden excess of dryness in the first half of the 7th century. Without the genius of Muhammad, that long period of adversity might have come to an end without any serious upsetting of the old conditions. But without the discontent and unrest fostered by years of distress, Muhammad might have appealed in vain, for he would have had to speak to men who did not desire change, instead of to those who ardently longed for it. The people of the desert may perhaps occasionally pour forth from their homes without any special stimulation, but this is doubtful. Anyone who has had much to do with the Arabs and other desert nomads knows that when there is plenty of water and grass, there is very little raiding and fighting. On the other hand, a single dry year causes raids in the fashion described above, and prolonged dry periods appear to lead to great outbursts of desert people like that which reached its crest under the influence of Mohammedanism, although it began before Muhammad came into prominence. The Mohammedan migration was by no means unique. Many of the barbarian migrations of earlier times seem to have been impelled by similar dry periods. At the latter time, two similar invasions took place, first from about 1000 AD to 1200 AD. The climate of Central Asia seems to have grown decidedly drier, and distress and discontent reigned among the people of the tents. At this time, as in the days of Muhammad, no great concerted movement might have arisen, had it not been for the ambition of one man. Genghis Khan may have been no more ambitious and no more abler than other gifted men of his race, but he happened to live at a period when natural calamities had brought his people to a condition of discontent favourable to his aspirations. This condition, it would seem, was an important help in enabling him in a few years to arouse all the tribes in the steppes and deserts, and sweep over Asia, bring almost unparalleled devastation. 3 centuries later, at the beginning of the 16th century, another ambitious Asiatic, Babur by name, arose in Turkestan and emulated his great ancestor Genghis Khan. In Babur's case, also, physical conditions seem to have favoured his projects, for after a period of improved climate, a rather rapid decrease in rainfall culminated at the time of his conquests. How much this had to do with the fact that he was able to conquer India and establish there the Mughal dynasty had not yet been thoroughly investigated. It seems clear, however, that this dry period should at least be carefully considered before any conclusions are drawn as to Babur and the Mughal conquests of India. From great wars and movements of the nations, let us turn back to the individual people and see how increasing aridity may affect the race physiologically. The chief effect is probably produced by the selective actions of disease. Insidious diseases such as malaria, consumption, neurasthenia, and the like are presumably among the most important sifters of the wheat from the chaff in the physical makeup of a nation. although malaria, for example, does not kill people in any such spectacular fashion as do the great epidemics, it may be far more dangerous in its ultimate effects. The plague passes over the land and is gone, the dead are dead, and the living have suffered no serious injury. Malaria, on the contrary, hangs on year after year, not killing its victims but sapping their energy and vitality. The presence and the abundance of malaria are closely associated with climate and topography. Without entering into any discussion of the origin of malaria, let me point out how a change toward aridity in a country like Greece, and to an extent Italy, would probably foster the disease. Malaria is preeminently a disease of tropical and subtropical countries, whose climate is characterized by alternate wet and dry seasons. Except in the perennially moist portions of the tropics, the streams of such regions are subject to seasonal floods which spread over wide areas for a short period and then disappear, leaving innumerable stagnant pools and swamps, ideal breeding places for the Anopheles mosquito. Permanent bodies of water usually contain fish which eat the mosquito larvae and reduce their numbers, or else the water moves sufficiently to carry away most of the eggs that are laid in it. When the climate of a subtropical country becomes drier, the conditions which favor the mosquito are intensified. This is due in large measure to the fact that a diminution of the rainfall lessens the amount of vegetation upon the slopes and thus allows the soil to be washed away rapidly. The streams are thereby overloaded and begin to fill the valleys with sand and gravel. This causes the flowing water to wander hither and thither over broad flood plains in innumerable channels, which form pools when the floods or surge. Or it may be that the water loses itself in marginal swamps. The streams also become intermittent, and no longer contain large quantities of fish. Thus everything cooperates to reduce the number of streams which flow steadily throughout the year, and to increase the number of bodies of stagnant water in which the mosquitoes may live. This in itself may produce most widespread effects. How great they are may be judged from the success of the United States government in eradicating malaria at Panama by the opposite process of reducing the number of places where mosquitoes can breed. At the present time, malaria is endemic in Greece and Rome. That is, it is always there, and is looked upon as one of the necessary diseases of childhood, which as we look upon measles. Sir Ronald Ross of the Liverpool School of Tropical Medicine is responsible for the statement that nearly half the people of Greece have suffered genuine injury from malaria, and in Italy the case is scarcely better. Up to the age of puberty, children are attacked by it every autumn. They grow weak and sallow, their spleens are permanently enlarged, and their vitality is lowered for life. No one who has known much of malaria will question the severity of its results and the length of time which elapses before they are eradicated, even in the case of adults. In spite of quinine, which has come to our aid in modern days, malaria is one of the most insidious of diseases. Every traveller who is really familiar with the Orient knows how the sufferers from malaria lie and groan for days, and many have little energy for months. They go languidly to their necessary tasks, and as soon as possible sit down to rest with open, stupid mouths. Physicians agree that it is impossible to expect much initiative or energy from a nation in which for centuries almost half of every generation has been devitalized by this painful disease. From a painstaking study of classical authors, W.H.S. Jones has concluded that up to about 400 BC in Greece and 200 BC in Rome, malaria was almost unknown. Then it appeared, and during the succeeding century or two became common. At first it attacked adults, which shows that it was a relatively new disease, which was still epidemic and not endemic. Or else, we would add, that Greece was on the very border of its habitat. Later it became permanently located in their respective countries, and attacked chiefly children, the older people having become immune after suffering in childhood. It is noticeable that the introduction of malaria coincides with the beginning of the weakening of Greece and Rome, and the time when it became endemic, in Greece at least, is synchronous with the epoch when the lustre of the ancient names became irretrievably dimmed. Ross and Jones are of the opinion that, along with various other factors, malaria is one of the important causes of the fall of Greece and Rome. The growing effeminacy and lightness of the Greeks, and the brutality of the Romans are just the effects which they think would be produced upon people of the respective temperaments of the two races. The case is so strong that one can scarcely resist the conclusion that this pathological factor may have played an important part in the psychological changes which appear to have accompanied the decline of civilization and of population in both Greece and Rome. It would be unwarranted to assert that the increase in the amount and severity of malaria was due wholly to climatic changes. Other influences, such as contact with Egypt and the introduction of slaves, may have been equally effective. Nevertheless, it seems probable that the spread of the disease in both Greece and Rome proceeded most rapidly when a change of climate not only rendered the topography of the valleys and the behaviour of the streams more favourable than hitherto to the propagation of the Anopheles mosquito, but likewise weakened the physique of the people so that they readily succumbed to disease. Natural selection presents a still more insidious way in which the change from relatively moist, stormy, cool conditions to those of aridity may have affected the Greek, Roman, and other races. In the opinion of many scholars, one of the most important factors in the greatness of these powers was the presence of a race of blonde northern invaders. Take the case of Greece. These northern Achaeans apparently came into the country in the 13th century BC. Their coming may have been influenced by the dry period of which we find some evidence at that time both in America and Asia. After their arrival, the climate on the whole, although with many fluctuations, appears to have become more propitious. Up to the 3rd century it continued to be favourable, then it became more arid. We have seen how sensitive people are to climatic environment. The Negro would apparently disappear in the northern United States were he not replenished from the south. The Scandinavian does not seem to prosper greatly in the dry, sunny portions of the United States. He is there subject to diseases of the skin and nerves which appear seriously to deplete his numbers in a few generations. Whereas in the rainy northwest, which resembles his native habitat, he thrives greatly both in body and estate. It was probably the same with the northern invaders in Greece. So long as the climate was propitious, they flourished and lent strength to the country. Then, when conditions became less favourable, the unseen ravages of malaria and other diseases presumably attacked them with special severity, and in the course of centuries they gradually disappeared. Today, blonde Greeks are almost unknown, although classical literature and many fair-haired old statues demonstrate their presence formerly in considerable numbers. Thus far we have been discussing changes of climate, and have overlooked the fact that even though the climate remains constant, man's cultural progress may alter the location of the most favourable climate and hence of the centres of civilization. This depends upon the fact that the climate which is most favourable to a race in a primitive stage of development is not the most favourable for the same race in a higher stage of culture. Gilfillian, in an article on The Coldwood Course of Progress, has presented an interesting study in the way in which man's cultural heritage, in the form of a constantly growing command over nature, has enabled mankind to advance farther and farther into regions of low winter temperature. In a savage state, without fire, clothing, or shelter other than caves, man is not likely to thrive where the winter temperature remains, for any length of time, as low as freezing, and his main development is almost sure to be where the coldest months are not much below the physical optimum of 64 degrees or 65 degrees Fahrenheit. With each step of progress he is able to endure greater extremes of climate. The open fire, the grate, the stove, the furnace, and the central heating plant are all steps towards a condition where man is able to resist the cold, no matter how severe it may be. The use of the skins of animals for clothing, the invention of the arts of spinning and weaving, the domestication of the sheep, goat, and camel, the cultivation of flax, and especially cotton, the invention of power looms and of the steam engine, all these are important steps which have tended to make man independent of climate. So too are the inventions which enabled mankind to close the mouths of the caves in which he lived, and then to build huts, thatch them, cover them with close-fitting shingles, construct them of thick bricks, or otherwise make them warm and weatherproof. In like manner, man's power to resist unfavourable climates has been increased by every invention that has made it possible to transport food cheaply and quickly, and to preserve it for long periods. Today it is not difficult for large communities to live in health and comfort in the cold parts of the earth where their naked ancestors would have perished in a few days. Human energy may perhaps ultimately rise higher in those regions than in others, for many of the diseases of warmer regions do not flourish there, and the constant changes from the warmth within doors to the cold without seems to be highly stimulating and healthful, provided they are properly guarded against. Moreover, in cold regions, man can be free from the effects of undue heat against which he has thus far shown little ability to protect himself. Thus it appears that even without changes of climate, the higher civilization would have tended gradually to migrate farther and farther north. How far this tendency will go is not yet clear, but the far northern location of such progressive people as the Scotch, Canadians, Swedes, Norwegians, Icelanders, and Finns seems to suggest that the limit has not yet been reached. One of the phases of Gil Fillan's work deserves careful notice. It points out that when civilization takes a backward step, it also tends to move equatorward. For instance, about 200 years before Christ, the leadership of the world had passed from Greece, while Rome was falling into a state of confusion and retrogression for which its recovery was never complete, even in the days of Augustus. At that time, the intellectual leadership went back toward the south, and the Alexandrians held aloft the torch of learning. They did not, to be sure, make any great intellectual or material innovations, but they at least kept the spirit of progress alive. In the same way, in the Dark Ages, the intellectual leadership of the world went back to North Africa, where lived such men as St. Augustine and his confreres. Gil Fillan suggests an interesting explanation of what happens when the most progressive nations of any given period are suddenly thrown backward by barbarian invasions, climatic changes, or similar occurrences. At such times, regions which have formerly ranked high stand out once more as leaders. When the cooler countries fall to a lower state, the eclipsed warmer countries come into prominence. They still represent the highest type of civilization that is compatible with their climate, even though they have not been able to make that type appear great or important because the cooler and more energetic countries have not given them a chance. Thus, in the Alexandrian period, when Greece had fallen and even Rome was at a low ebb, northern Egypt took the lead because the stage of progress to which the world had regressed was suited to Egypt's climate. How true this hypothesis may be, it is hard to say. The migration of the more competent Greeks to Egypt may explain the Alexandrian period. Greece was becoming uninhabitable and poverty-stricken by reason of an adverse climatic change. But Egypt, with its perennial river, was still prosperous and attractive. Nevertheless, there seems to be much truth in the idea that man's social progress constantly alters his relation to climate. In the past, great inventions have helped chiefly in enabling man to overcome low temperature. In the future, perhaps, they will help him in equal measure to overcome high temperature, dryness, and monotony. The last matter to engage our attention is the effect of changes in storminess. In reading what has been said about Egypt, for example, the reader has probably said to himself, "This book claims that the people there were once energetic and healthy because of frequent storms. If this is so, the rainfall must have been much more abundant than now. For the sake of argument, we grant that at certain periods the precipitation was greater than at present, but we cannot possibly believe that it increased to the extent demanded by this hypothesis." This objection is so important that I have made a special investigation to determine the exact relation between storminess and rainfall. The word storm, as already explained, does not primarily mean rain. To the meteorologists, a storm is an area of low barometric pressure which is always accompanied by in-blowing winds, and usually, but not invariably, by rain. Even if there is not a drop of rain, a storm may otherwise be fully developed and may cause strong winds which give rise to changes of temperature and humidity. The matter is well illustrated by comparing Colorado and Georgia. According to Culmer's maps, Colorado is one of the stormy parts of the United States. It is crossed by the centers of about 3 times as many storms as Georgia, yet its rainfall is only about 1/3 as great. In other words, Georgia has 9 times as much rain in proportion to its storms. The reason is simple. Colorado lies far from the ocean, and the air which rises in the centers of its areas of low pressure has already lost most of its moisture. Georgia, on the other hand, lies so near the broad Atlantic and the warm Gulf of Mexico that storms draw in great quantities of moisture. The lands around the eastern Mediterranean and in western Asia have a climate far more like that of Colorado than of Georgia. Part, to be sure, are near the Mediterranean Sea, but that furnishes only a little water compared with the great oceans. Another comparison shows that in the entire United States, if the number of storms increases 20% during a given series of years, the rainfall increases scarcely 10%. In the arid southwest, however, the ratio is larger, the increase in storminess for all available stations being 3 times as great as the increase in rainfall. These figures apply to present conditions, where the variations are slight and of short duration. If larger, more permanent changes took place, the rapidity of the atmospheric circulation would probably be so much increased that the ratio between increases in storminess and in rainfall would be greater than at present, and might be 4 or even 6 to 1. The drier the region, the greater would probably be the ratio. Suppose that the ratio were 4 to 1 in Syria. A change which would increase the storminess by 200% would involve a change of rainfall amounting to 50%. That is, the number of stimulating changes would be 3 times as great as now, while the rainfall would only increase by 1/2. Such a change would render the Phoenician coast much more stimulating than at present. It would also increase the agricultural wealth, and would cause the limits of permanent habitation to advance some miles into the desert. There the stimulating influence might be less than on the coast, because the storms might be somewhat interrupted by crossing the mountains. Nevertheless, it would be important. The effect of increased storminess upon habitability, however, would be much less noticeable than upon energy, or than in better watered regions. An increase of 50% in a rainfall of 20 inches, such as is now enjoyed by many parts of Syria, would raise the precipitation to 30 inches, a figure which permits great prosperity. A corresponding change in Egypt would increase the rainfall of Alexandria from 8.8 inches to 13.2, that of Port Said from 3.3 to 5, and that of Cairo from 1.3 to 2. Farther east in Mesopotamia, Baghdad would change from 9 to 13.5, while in Persia, Tehran would rise from 10 to 15, and Isfahan from 5.2 to 7.8. Deserts would still be deserts. They would be easier to cross than at present, and the number of inhabitants might be greater, for there would be more pasturage for camels and sheep. The springs would also be larger and more permanent than now, and some new ones would appear. Yet the predominant feature would still be great wastes of blowing sand and barren gravel. The people would have to be nomads, and those who entered the desert would frequently encounter rigors like those of today. Thus a large change in the stimulating qualities of a sub-arid or desert climate is possible without a change of rainfall greater than that for which there seems to be good evidence. Consider more specifically exactly what happens when storminess increases in regions such as Western Asia and Central California. The general conditions at the time when Greece was in its prime, for example, appear to have been approximately as follows. 1. The average temperature for the year as a whole was probably a little lower than at present, but it is doubtful whether the difference amounted to more than 2 or 3 degrees at most. 2. The temperature of the seasons may have varied somewhat more than that of the year as a whole. The greater mixing of the air from wide areas by means of the winds that accompany storms presumably lowered the summer temperature a little over the lands and raised the winter temperature. 3. The amount of rain was apparently considerably greater than now. Doubtless the rain then, as now, came chiefly in winter, while the summers were very dry, just as at present. But the length of the rainy season appears to have been increased. That is, the rains began earlier in the autumn and lasted longer in the spring than at present. 4. The amount of atmospheric moisture over the lands was presumably greater than now. This would arise partially from the increased cloudiness and rainfall, and partially from the fact that the winds were presumably more efficacious in bringing moisture from the neighbouring seas. 5. The winds were apparently stronger than at present, and varied in direction much more than now because of the frequent storms. 6. The greater storminess and the more frequent changes in the winds, as well as their greater strength, must have caused great, or at least frequent, variability of temperature, as well as variations in other respects. Such variability would occur even in summer, when the storms passed to the north of the lands that were more progressive 2,000 or 3,000 years ago. It would still be more pronounced in the rainy season. Let us apply these generalizations to a specific case. Suppose that from 500 to 400 BC, the climate of Athens differed from that of the present in the following respects. 1. Temperature of July, 77 degrees Fahrenheit instead of 81 degrees Fahrenheit. January, 48 degrees instead of 46 degrees. Mean temperature of the year, 62 degrees instead of 63.1 degrees. 2. Relative humidity at all seasons, 10% higher than now. January, the moistest month, 84% instead of 74%. July, the driest month, 58% instead of 48%. As a matter of fact, the change was probably not the same at all seasons, but I wish to keep our example simple. 3. Annual rainfall, 22 inches instead of 15, ranging perhaps from 3.3 inches in November to 1.0 in July instead of 2.9 in November, and 0.03 in July. 4. Number of storms twice as great as now. Such a change seems conservative. It is scarcely more than the normal variation from one year to another. Nevertheless, when we calculate its effect upon health in the same way that we have calculated the data for our map of climatic energy based on the effect of the seasons in American cities, Figure 36, the result is astonishing. From a climatic level only equal to that of Augusta in Georgia and Vicksburg in Mississippi, Athens rises to a level practically the same as that of New York and Chicago, the best regions in North America aside from the coast near Newport. A slight further increase in storminess, or a further lowering of the summer temperature 2 or 3 degrees more, would make Athens rival Paris and Berlin. And if the storminess there should be 3 times as much as at present, which would be a small matter compared with the differences between one year and another at places like San Francisco, the healthiness and stimulating qualities of the climate of Athens would rival those of southeastern England, which seems to be well nigh the most favoured place in the whole world. When we recall that according to Figure 41, the estimated death rate in Greece is nearly twice that of England, the significance of such a change is apparent. It would presumably get rid of malaria to a large extent. It would stimulate the Greeks to a degree of persistent activity quite foreign to the country at present. It would raise the economic level and correspondingly improve the diet of the people, and would give to the Greeks a spirit of enterprise, a physical vigour, and a mental activity which would probably soon enable them to take advantage of all sorts of modern discoveries which they now use half-heartedly and ineffectively, if at all. The slightness of the climatic change necessary to produce important results seems to give to the conclusions set forth in the present edition of this book a reliability much greater than was possible in the first edition, before the health of American and European cities had been studied in its relation to the weather. As we come to the end of this volume, I am well aware that to those who accept the climatic hypothesis, it may seem depressing. To the dweller in the less favoured parts of the world, it may appear to sound the knell to his hopes for great progress in the land that he loves. To his brother in the centre of modern activity, a most disquieting vision of possible retrogression is disclosed. If our reasoning is correct, man is far more limited than he has realized. He has boasted that he is the lord of creation. He has revelled in the thought that he alone among created beings can dwell in the uttermost bounds of the earth. One more of the bulwarks of this old belief is now assailed. Man can apparently live in any region where he can obtain food, but his physical and mental energy and his moral character reach their highest development only in a few strictly limited areas. The location of those areas appears to have varied greatly in the past. It may vary greatly in the future. In 1,000 years, for all that we can tell, so the prophet of evil will say, no highly favourable region may exist upon the globe, and the human race may be thrown back into the dull, lethargic state of our own present tropical races. Even without so dire a calamity, the location of the regions of greatest climatic energy may in a few hundred years change again to Egypt, Mesopotamia, and Guatemala. The consequent rise of new powers and the decline of those now dominant may throw the world into a chaos far worse than that of the Dark Ages. Races of low mental caliber may be stimulated to most pernicious activity, while those of high capacity may not have energy to withstand their more barbarous neighbours. Even if such extreme disasters should not occur, the prospect is depressing. Take such a favoured country as the United States. In the South we find less energy, less vitality, less education, and fewer men who rise to eminence than in the North. Not because Southerners are in any way innately inferior to Northerners, but apparently because of the adverse climate. In the far West, people seem to be stimulated to such a degree that nervous exhaustion threatens them. In the North, we see still another handicap. In spite of a wonderfully stimulating climate most of the year, the people suffer sudden checks because of the extremes of temperature. These conditions favour nervousness, and worst of all, they frequently stimulate harmful activities. That perhaps is why American children are so rude and boisterous, or why so staid a city as Boston has 6 times as many murders as London in proportion to the population. Our country takes immigrants of every mental calibre, and then stimulates some of the noble deeds and others to commit murder. Break down the respect for law, and give us city governments that shame us in the eyes of the world. All these things would apparently not happen to such an extent were our climate less bracing and not its extremes often weaken the power of self-control. Other lands also have their drawbacks. Germany is much like the eastern United States, although not so extreme. France, on the other hand, is less stimulating. England suffers from too great cloudiness, and in Ireland this becomes a factor of serious import. If the best parts of the earth have such climatic disadvantages, what shall we say of Russia, weighted down with benumbing cold and comparative modesty, or with changes so extreme that they are harmful? What of China, under a much heavier handicap of monotony, or of tropical lands burdened most heavily of all? If climatic conditions influence character, as we have inferred, does not our hypothesis weaken man's moral responsibility? Will not people more than ever ascribe their failings to nature and so excuse themselves? In the favoured regions, will not men become increasingly arrogant and overbearing, because they will be surer than ever that the rest of the world cannot resist them? If all these sad results are possible, is it well to know that climate so strongly influences us? We cannot change the climate, so why ascribe it to such great effects merely to destroy hope in some of the moral responsibility in others? The answer to these questions may be put in the form of a parable. Ages ago, a band of naked, houseless, fireless savages started from their warm home in the torrid zone and pushed steadily northward from the beginning of spring to the end of summer. They never guessed that they had left the land of constant warmth until in September they began to feel an uncomfortable chill at night. Day by day it grew worse. Not knowing its cause, they travelled this way with that to escape. Some went southward, but only a handful finally returned to their former home. There they resumed the old life, and their descendants are untutored savages to this day. Of those who wandered in other directions, all perished except one small band. Finding that they could not escape the nipping air, the members of this band used the loftiest of human faculties, the power of conscious invention. Some tried to find shelter by digging in the ground, some gathered branches and leaves to make huts and warm beds, and some wrapped themselves in the skin of the beasts that they had slain. Soon these savages had taken some of the greatest steps towards civilization. The naked were clothed, the houseless sheltered. The improvident learned to dry meat and store it with nuts for the winter. Or at last the art of making fire was discovered as a means of keeping warm. Thus they subsisted, where at first they thought that they were doomed, and in the process of adjusting themselves to a hard environment, they advanced by enormous strides, leaving the tropical part of mankind far in the rear. Today, mankind resembles these savages in certain respects. We know that we are limited by climate. As the savages faced the winter, so we are face to face with the fact that the human race has tried to conquer the Arctic zone, the deserts, and the torrid zone, and has met with only the most limited success. Even in the temperate zone, he has made a partial failure, for he is still hampered in hundreds of ways. Hitherto we have attributed our failure to economic conditions, to isolation and remoteness, to racial incapacity, or to specific diseases. Now we see that it is probably due in part to lack of energy, or to other unfavorable effects produced directly upon the human system by climate. There is no reason for despair. We ought rather to rejoice because, perhaps, we may correct some of the evils which hitherto have baffled us. Again and again in our discussion of factories and other matters, we have come upon ways in which a change in our methods may do much to overcome the harmful effects of climate. I do not propose to enumerate them, for the specific application of our results may well be deferred until we know whether our main hypothesis is likely to stand. Yet one or two general lines of progress may properly be pointed out. Take the harmful winters of the northern United States. It is highly probable that the loss of energy which occurs at that time may be largely avoided, or at least greatly diminished. Much of it arises from the fact that after the wonderfully stimulating autumn weather, when we have been living under almost ideal conditions of mean temperature, of humidity, and of variability from day to day, we suddenly begin to heat our houses. We create an indoor climate of great uniformity, of unduly high mean temperature, and of the most extreme aridity. All these conditions are harmful. If our houses were kept at lower temperatures, if the temperature were varied from day to day, and if the humidity were kept at the optimum, we should increase our efficiency greatly. We should be comfortable also, for with proper humidity, and with changes from day to day, we should not feel the need of the high temperatures which we now require because the extreme dryness forces the body to give up much more heat than would be demanded by air of greater humidity. Moreover, the uniform dryness within doors does almost untold harm in parching the mucous membranes and thus rendering us peculiarly liable to colds, gripe, and similar ailments, which often leads to serious diseases such as pneumonia and tuberculosis. Of course, we cannot entirely avoid colds by the method here suggested, but we surely could diminish them. In the autumn before our houses are heated, colds are comparatively rare, and the same is true among people who live out of doors in winter. If the conditions inside our houses could be like those that prevail in the autumn, the general health of the community would probably be much improved. In this one way there might be a saving not only of millions of dollars worth of valuable time, but of an immense amount of nervous energy which is wasted because persons who are irritated by colds do or say things that they would scorn under normal conditions. Along still other lines, great improvements might be possible. For instance, in many factories the same amount of work is expected each month. Hence in certain seasons, many operatives, especially girls, work harder than they ought, while at others they do not work so hard as they easily could without special effort. If factories were run in accordance with a well-established seasonal curve of energy, we should find the machinery running slowly in winter, faster in the spring, and in May perhaps 10 or 15% faster than in January. Then in the summer it would run more slowly than in May, but not so slowly as in winter. Finally in the autumn it would run at greater speed than at any other time of the year. The operatives would scarcely be conscious of the difference, and they would probably do more work and preserve their health better than under the present system. If our hypothesis is true, it is likely to prove helpful not only to places where the climatic disadvantages are slight, but where they are great. Consider regions which have a winter of great severity, but an invigorating summer. Contrast them with places where the summer is too hot, but the winter favourable. Russia and Mesopotamia may serve as examples. Today we already have a small number of people who move back and forth each year between places of this sort. For instance, northern Germany and the Riviera, New England and Florida. Unfortunately, those who do this are usually not the workers, but the idlers, or those whose work is almost finished. In the future, however, if the principles here laid down find acceptance, we may expect that such interchanges will take place on a scale to stagger the imagination. Not only the leisure classes, but labourers and farmers may thus move back and forth. In winter, most of Russia's peasants have little to do, and their enforced idleness is harmful. They might go to Mesopotamia, where most of the farm work is done between October and May. If people could move thus from place to place, not only would there be an enormous increase in production, but many other benefits. The part of the population that moved would be stimulated, not only by the change of climate, but by contact with other races and new methods. They would be more tolerant, more progressive, and more eager for education. Both countries would benefit by such an interchange of workers, and much of the handicap of places like Russia might possibly be overcome. Perhaps the day will come when only the poorest families will stay in an unfavourable climate more than a few years at a time, without going at least for a season to some place where they will receive new stimulus. In tropical countries, the chances for improvement are at a maximum. Already most Europeans and a few natives appreciate the necessity for spending part of the year among the mountains, or in a climate different from that where they usually live. For the most part, the lowlanders go to the highlands, but in lofty plateaus like Mexico, it is not uncommon for foreigners to take a run down to the coast for a change of air. Of course, altitude has much to do with this, but even though Vera Cruz has a bad climate for permanent residence, it is stimulating for a short while when one comes from a wholly different environment. In the future, we can scarcely doubt that this method of overcoming the evil effects of a tropical climate will be resorted to on a vast scale, not only by foreigners, but by the more intelligent portion of the natives. In the warmer parts of the earth, there is another side to the question. Mankind needs not only seasonal changes, but variations from day to day, or week to week. Two methods of obtaining these suggest themselves. One is by cooling the interiors of houses. Today this is done on a small scale by shutting out the sun and sprinkling water to cause evaporation. There is no reason why the same result should not be produced on a large scale. We already know how to cool houses as well as to heat them. We do it in ice plants. 1,000 years ago, men would have laughed at the idea that hundreds of rooms would someday be heated by a single fire. Here we see it in every office building or hotel. In equatorial regions, there is as much reason for equipping the houses with coolers as there is in temperate regions for equipping them with heaters. In both cases, uniformity of temperature is apparently a mistake, for moderate changes from day to day appear to be favourable. Even though a man's work may be done out of doors, it seems probable that he would be much stimulated and much better enabled to work hard in the heat if he could sleep in a comparatively cool house. If he lives where the climate is too damp, he would be benefited by having the house relatively dry, just as the northerner in winter apparently ought to have his house more moist than is now his habit. Both need to enjoy the optimum conditions. A second method of obtaining frequent changes may possibly prove of much importance. Today the seacoast in many regions, for example on the Atlantic shore of America from New York to Boston, is bordered by an almost continuous line of houses. At first people went to these only in the summer. Now many go for weekends at almost all seasons. 50 years ago such a thing was almost unknown. 50 years hence it will probably be many times more prevalent than now. In tropical countries, millions of people may not only move to other climates during part of each year, but many may move back and forth from the lowlands to the highlands every few days. Their work may be arranged so that almost every family can spend weekends in the highlands and the rest of the time in the lowlands. In Sardinia, in order to escape the malaria of summer, many villages are today completely duplicated in the lowlands and highlands. Churches, houses, shops, everything in duplicate. Moreover, aside from farming, mining, lumbering and the like, most of the other kinds of work can be located where the climatic conditions are best, a matter which is becoming increasingly easy as our facilities for communicating improve. Yet if these are to be within the tropics, the people engaged in them must have an opportunity to obtain the stimulus of changes. Perhaps they will frequently go from their places of work in the highlands to the neighbouring lowlands, were in the high mountains. The expense of such a system of having two homes for a large part of the population will doubtless be enormous, but that is relatively unimportant. If the farmers of the tropics were as efficient as those of the temperate zone, one man's labour would produce 2 or 3 times as much as in Europe or the United States. If white men can devise a means whereby they can live in the torrid zone and retain approximately the energy which they possess in their own countries, or if they can largely increase the efficiency of the natives, they can afford to spend enormous sums in creating favourable conditions. How we shall go to work in detail cannot yet be determined, but that will easily be discovered. For the present it is enough to see that the hypothesis of climate as a condition of civilization is far from depressing. It holds out hope that the inhabitants of even the most favoured parts of the temperate zone may improve their condition. It holds out still more hope that the people of the less favoured parts of that zone and of the subtropical zone may be benefited. And it holds out far the greatest hope to those who dwell in the tropical regions, which now are the most hopeless. If our hypothesis is true, man is more closely dependent upon nature than he has realized. A realization of his limitations, however, is a first step toward freedom. In suggesting possible ways of obtaining a new ascendancy over climatic handicaps, we have dealt largely with material matters. Bound up with these, and far more important, are great moral issues. We are slowly realizing that character, in the broad sense of all that pertains to industry, honesty, purity, intelligence, and strength of will, is closely dependent upon the conditions of the body. Each influences the other. Neither can be at its best while its companion is dragged down. The climate of many countries seems to be one of the great reasons why idleness, dishonesty, immorality, stupidity, and weakness of will prevail. If we can conquer climate, the whole world will become stronger and nobler. End of section 18, and the end of Civilization and Climate by Ellsworth Huntington. Recorded by Leon Harvey.